Hello everyone, and welcome to the lecture on IDE options. In this lecture, we'll go over the different IDE options that we have, and we'll see what an IDE is. Let's start by looking at what an IDE is. IDE stands for Integrated Development Environment. And it's a software application that provides tools that we need to write and test different softwares. So there are various kinds of IDEs, and this IDEs allows us to write what we need to write. They allow us to write our codes, they let us compile our codes, do a debugging on our codes, and so on. So that's what an IDE is. For our lecture, for our course, we'll be using an IDE called Jupyter Notebook. We'll come to that later on. But these are some of the various IDE options that we have for Python. One is PyCharm, another one is Komodo. There's another IDE known as Sublime Text. And as I mentioned, for this course, we'll be working on Jupyter Notebook mainly. So the reason why we chose Jupyter Notebook is because it's very easy to use. Actually, this is Jupyter Notebook. So this GUI that you see is Jupyter Notebook. And it's divided into, the notebook is divided into what is known as cells. So this rectangle that you see here, it's one cell. This is another cell, and so on. It's easy to use. We can commit our change to Git. Git is where we can save our work if we need to share it with someone else. And Jupyter Notebook has lots of features. Some of the features are, it has some magic functions. It allows you to do inline plots. It lets you time your code. And you can do some file editing. So there are so many advantages of using Jupyter Notebook. And for instance, let's write some Python codes. If I want to do a basic operation, let's say 4 plus 5. So this is Jupyter Notebook. Let's say 4 plus 5. And then to run a cell, I'll have to hit Shift plus Tab plus Enter. Shift plus Enter. Shift and Enter, that will run a cell. Another way to run a cell is by selecting Alt plus Enter on your keyboard. So those are the two ways to run a cell. If I have another cell, let's say 56 minus 123, so Shift and Enter will run a cell, or Alt and Enter. So you see how easy it is. So you have your input here. So you have in is your code, so what you provide here, and then out, that's your result. In and out, that's your result. So for every input, you will see the output right after it. If I write some other code, let's say for I in range for print I. Don't worry about what this does. We'll learn about it. But basically, this is a code that will print the numbers 0, 1, 2, and 3. So if I run this, I get 0, 1, 2, 3. So you have your input, you see the output right after it. So it's very user friendly, it's easy to use. and it's nice for learning purposes. Okay, the other options that we have for IDE, as I mentioned, there are so many. If you go to Google and type IDE options for Python, there will be a bunch of links. If I open the first one here, let's see. Here we have various IDE names. There is Tony, Komodo, we mentioned Komodo. There is NetBeans, PyCharm, PyDev, Wing IDE, Spider. So all of these are the various IDE options that we have for Python. And there are some descriptions here about the specific IDE. If you are interested about any specific IDE, you can always Google it. For instance, let's say PyCharm. If I say PyCharm IDE, it will take me to, so this is the site for PyCharm IDE. It's another great IDE. It has two versions. There is a community version which is free, so you can learn more about the various IDEs if you want. But for us, we'll be using Jupyter Notebook. And this is the link for Jupyter Notebook. So jupyter.org. This is their official site, jupyter.org. In the next lecture, we'll see how we can install Jupyter. But this is their website, jupyter.org. And we have the option to use Jupyter online also. So they let you use it online too. So we'll cover all of that in the next lecture. Okay, let me go back to our IDE options. Great. So this is what I have for the lecture on IDE options. Just to summarize, we looked at what an IDE is, and we saw some of the IDE options that we have for Python, and we mentioned that we'll be using Jupyter Notebook for our course. In the next lecture, we'll see Python installation. Thank you, everyone. Hello, everyone, and welcome to the lecture on Jupyter Notebook overview. In this lecture, we'll look at some of the features of Jupyter Notebook. Okay, let's start. If you are using Mac, open up your terminal, or if you are using Windows, open up your Anaconda command prompt. So hit command and space and type terminal if you are using Mac. And for Windows users, click on your Windows Start button and then type Anaconda command prompt and open the command prompt. And to open up Jupyter Notebook, all we have to do is type Jupyter, Jupyter space notebook. Jupyter space notebook, and press enter. This will open up Jupyter Notebook on your machine. This is the Jupyter Notebook homepage. To start a new notebook, click on the new drop down here, new, and then select Python 2. And as I mentioned before, Jupyter has made an update and you might not see the option Python 2. You might see Python root or Python default, which is fine. Click on either Python root or Python default. So in my case, I'll click on Python 2, and this will open a new notebook for you. Okay, let's see some of the features. Here I have the title of my notebook. Right now by default it's Untitled 14. We can change the name of that. Let's name it Jupyter Notebook Overview. So this will be my notebook title. And this individual rectangles are called cells. That's where we write our codes. And here in the taskbar here, we have different options. We have file, edit, view, insert, cell, kernel, and help. And if you click on any of those features, for instance, if I click on file, I'll see a lot of options. We have a new notebook option, open, make a copy, rename, save and checkpoint, and all of those, they are self-explanatory. If you click on edit, you have options to cut cells, copy cells, delete cells, split cells, merge cells above, move cells up, move cells down. Those are so many different features. We won't be using much of those. We won't need them, but just in case if you are interested, you can explore more of these features under file, edit. We have view, insert, cell above, cell below. We have cell, run cells and select below. We have kernel, restart and run all, reconnect. Those are the different features that we have. We're not going to use much of those, but they are available for you and you can explore them. They are self-explanatory. And here we have icons. So this will save whatever you have written here. So that's the save button. And whenever you click on save, you see here, checkpoint created and then the time. This will add a new cell, insert cell below. This is to cut a cell, then copy, paste cell below, move cell up, move cell down. So those are some of the features we saw in file, edit, view, and so on. So this is to run a cell. It says run cell, select below. Let's print a simple Python statement. Welcome to the course. So one way to run a cell is to click on this play button here. So if I click on that, the statement welcome to the course is printed. That's one way. Another way that we'll be using often is by hitting Shift plus Enter on your keyboard. So you have print welcome to the course, and if you select Shift and Enter on your keyboard, that will run the cell. Okay, Shift or Enter, or you can do Alt and Enter, that will also run your cell. So it's your choice. Mostly we'll be using Shift plus Enter to run a cell. Okay, that's how we can run a cell. Print welcome to the course. And once we have that, you can explore some of these features, edit, merge cells above, merge cells below, or so on. Usually what I use to add a new cell in between my cells is I just click on the plus sign here, and that will insert a cell right below the cell where you selected. So if I want to add a new cell between the first two lines here, to the first two cells, I will just select the first cell and click on the plus sign. If I want a new line to be added between these two cells, I just select the middle one and click on plus. Okay, so those are some easy features, and if I don't want the cell anymore, I just use the scissor to cut the cell. Okay, those are the main ones that I use, but feel free to explore all these options. They are self-explanatory. And kernel is to restart or interrupt. So you can interrupt what it's running, and that will interrupt what your program is running. And here you have code, and there's a drop down. You have code, Markdown, heading and row NBC convert. So we use that for titles and if we don't want something to be printed. Right now we are in code, so whatever we write will be printed. But if I want a title, for instance, let's add a title named adding comments. So this is a title, for instance. Then we can, now this cell is selected, I can go here and then change it to heading. So this is a level to heading. Press OK. So adding comments. If I run the cell, see, so this is like a comment, this is like a heading. So adding a comment, and then we can say this is one way of adding a comment. That's we can use this hash sign or the pound symbol to add a comment. So when we run this cell, this statement will not be executed. Okay, that's one way of adding a comment. And there we can include our statement. For instance, print it is so-called today. So in this case, only the statement it's so-called today will be printed. So this comment is a way of adding a description to our statement or code. Another option we have is a markdown cell. A markdown cell will also not be executed. So for instance, let's say this is a markdown cell. So if we go here, so first we need to select our cell, and then if we change this to a markdown cell and run it, it will not be executed, right? So this is a markdown cell. But now when we go to a new line, you see it's a code. If I click on the markdown cell, that's a markdown cell. So by default we have a code. Another important feature is the following. Let's say we have a number, the number 9, and let's save our number in a variable called num. So now num is equal to 9. So I'm just saving my number 9 in a variable called num. So to run a cell again, shift plus enter on your keyboard. Now if I call my variable object num, I get the number 9. So num 9, because my variable or this num object is holding the number 9. Num is equal to 9. And another thing we can do is if I say num and then that and then hit tab on your keyboard, so we have num that, and if we hit tab we'll see a list of methods available for that object. Okay, to see a list of methods available, we have our variable, we have our object num in this case, and then that followed by tab, and that will list out a list of methods that we have. Let's create another data type. Let's create a string and save it in a variable called, let's say, string object, and let's say this is a string and is one of the data types in Python. So this is an example of a string, and string is one of the data types in Python. Okay, and we have saved our string in a variable called string underscore object. So if we run this and then call our object, string object, so if we call our string object and run it, we get the value of our string. And to see the list of available methods in our string object, all we have to do is write our string object dot and then hit tab. So these are the list of available methods or functions that we have on our string object. We look at most of these methods when we talk about strings, but here are a list of numbers, and we can use the up or down arrows on our keyboard to select any of these methods. Okay, for instance, I can select, now it's on string object that title, and then I can press enter and that will select title, and we can run the cell, shift plus enter, then we have that. So that's how we can select variable methods or functions that we have to see a list of those functions. So that's another feature. So those are most of the features, those are the main features that we'll be using for our course, but feel free to explore any of the features that we have in this toolbar. And you can also use Jupyter Online. That's also another option. To use Jupyter Online, go to jupyter.org, and you'll need an internet connection if you want to use Jupyter Online. So once you go to jupyter.org, this is the main page. If you scroll down, you'll see a button, try it in your browser. So click on that. Now we are using Jupyter Online, and we can open a new notebook by following the same steps. Click on the new drop down here, and in my case I'm using Python 2, so I'll choose the option for Python 2. So click on it, and that will open a new notebook for you online. Then I can use it here. Let's say print, this is awesome, and run it. So this is awesome is printed. We can say 7 plus 98, and we get the result. So that's another option for running Jupyter. You can run it online, which will need an internet connection, or you can run it on your own machine by starting it from your terminal if you are using Mac, or by opening it from your command prompt if you are using Windows. And once you are in your terminal or command prompt, simply type Jupyter space notebook and press enter. That will take you to that will open the Jupyter homepage, and you can start or open a new notebook by choosing new. And since I'm using Python 2, I will choose Python 2. And you might see the options Python root or default. It's okay, choose either Python root or default, and that will open a new notebook for you. Great. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome back. In this lecture, we'll look at one of the other IDE options that we have for Python. IDE stands for Integrated Development Environment, and the other IDE option that we will look at in this lecture is the IDLE. It's an integrated development environment which comes with Python, and it's very, very basic. Okay, so it's called IDLE, and it comes with Python. For our lecture, for our course, we'll be using Jupyter Notebook. But if you are interested, you can use any other IDE that you guys want. Let me quickly show you this IDE that comes with Python, which is called idle. So if you click on the Start Windows button and type idle, so you'll see idle here, idle Python GUI. You can click on it, and if you are using Python 3, you might have to type idle and then 3 if you are using Python 3. Since we are using Python 2, simply type idle, and once you open your idle, this is what it looks like. It says Python 2.7.11 shell, Python version. So this is what the idle looks like, and we can perform certain Python operations and statements. For instance, I can say print, hi there, welcome to the course, and our statement will be printed. Press enter. So hi there, welcome to the course. We can perform operations, for instance 78 minus 98, that will give us -20. We can look at some for loops. For instance, we can say for I in range 5, or let's say for I in range 8, print I. So that will print out the numbers 0 to 7. Press enter twice and we see 0, 1, 2, 3, 4, 5, 6, 7 are printed. We can say raw input, then please enter your name, and then run it. It says please enter your name, so it's prompting us, it's prompting the user to enter their name. So please enter your name, let's say Sammy, and then run it. So Sammy will be printed. Okay, so these are some Python operations, Python statements that we can perform on our idle. Okay, it's not able to handle some complex statements, okay, but it can handle, you know, the basic Python statements. So if you make any error, it will show you here. For instance, here it says end of line while scanning string literal. It's just saying you are missing a quotation. Okay, so it's basic, but it's one of the IDEs that comes with Python. Say please enter your name. So this is a function that raw input is a function that you can use in Python 2. If you are using Python 3, use the function input, and then the statement enter name. So that will be in Python 3. Use input. Okay, so this is idle, and you can also, another thing you can do with idle is you can click on the file here, the file tab, and then click on new file, and then once you have a new file open, you can print out statements. For instance, I can say for I in range, let's say 3 to 20 in step sizes of, let's say 4. These are some Python for loop statements. Don't worry what it is, I'm just showing you that it will perform and execute the statements. Once you have your statement, click on run module, source must be saved, OK to save, press OK, and you see the result here in the Python shell. Great. Just to recap, we looked at the idle IDE option that we have for Python. Again, as I mentioned, we'll be using Jupyter Notebook for our course, but feel free to use any other IDE that you like. And some IDE options are idle, which comes with Python. There's PyCharm, there's Komodo, Sublime Text, there's so many of them. Feel free to use any of those. Great. Thank you everyone, and see you at the next lecture. Hello everyone, and welcome to the lecture on other IDE options idle for Mac or Linux users. We have seen that there are so many options for IDEs, integrated development environments, and we'll be using Jupyter Notebook for the course, but if you are interested, you can use other IDEs of your option. In this lecture, we'll look at an integrated development environment called idle, which comes with Python. And we'll focus on idle on Mac or Linux. The first thing we're going to do is open up our terminal. So if you hit Command and space on your keyboard and search for terminal, press enter, that will open the terminal for you. And once we have the terminal open, simply type idle, IDLE, since we are using Python 2. If you are using Python 3, type idle 3. Okay, so once you type idle for Python 2 users, or idle 3 for Python 3 users, press enter, and that will open the idle for you. So this is what idle looks like. You have your Python version, Anaconda Python, and all this message. It's an integrated development environment which comes with Python. And once we have that open, we can perform certain statements. For instance, we can say print hello there, for instance, and hello there will be printed. You can say print welcome to the course. We can perform certain operations, for instance 5 minus 9, negative 4, 4 times 7, 28, 3 plus 4, 7, and so on. We can even do for loops. For instance, we can say for x in range, let's say 8, print x. This will print out numbers from 0 through 7. So if we run it, we get 0, 1, 2, 3, 4, 5, 6, 7. Don't worry about what this is. I'm just checking and executing certain Python statements and commands. And another thing we can do with idle is we can open a new file. So if you go here, file, open a new file, and we'll get another blank file. What we can do is we can write our operations here or statements here, and it will be executed on this Python shell. Let's see an example. Let's start with a simple print statement. Print welcome to this course. So to run a cell, to run this, go to run and then click on run module. So source must be saved. Okay, to save, let's save it. Press OK, and let's save it in our desktop. You can save it wherever you want. So save it. Here you see welcome to this course is printed. Great. Let's print some more messages. Let's also print hi there, isn't it cold? Okay, let's run it again. Run module, it must be saved. Okay, So now welcome to this course, and hi there, isn't it cold? Are printed. Good. And let's look at some more examples. Let's say I have a variable x, and let's set it to be equal to 7. Let's use some if statements. We can say if x is equal to 7, we can print the value of x is 7, or else we can say else print x is not 7. So this is a simple if statement. So we define our variable to be equal to 7, and if x is equal to 7, print the value of x is 7, else print x is not 7. In this case, this statement will be printed. So let's run it. Run module. Let's save it. So here you see the value of x is 7 is printed. Don't worry about this if statements. I just wanted to show you an example of certain Python statements and commands executed on our idle environment. And if I change this value of x to some other value, let's say 8, if I run it now, since 8 is not equal to 7, the else statement will be printed, which is x is not 7. So let's run it again. Run module, save it. So now we have x is not 7. So this is idle on Mac or Linux. As I mentioned, this idle environment comes with Python, and it's a basic integrated development environment, and this is among the many options that we have for IDEs. Great. Thank you everyone, and see you at the next lecture. Hello everyone, and welcome to the lecture on Python installation for Windows users. We'll be installing Anaconda and Jupyter. So Anaconda is a high performance Python distribution, and installing Anaconda will install Python already. Okay, why are we using Anaconda? Why do we need to install Anaconda? So these are some of the advantages of Anaconda. It's very easy to install. We can update or install packages independent of any system libraries. And when we install Anaconda, we don't need to worry about dealing with any environment paths. In addition, Anaconda has lots of packages already installed, like Numpy, SciPy, and so many other packages. And this is also one of the disadvantages. That is, since it has all of this package installed, its size is very big. It's about 350 megabytes. Okay, so that's one of the disadvantages and also advantages. Okay, now let's start by installing Anaconda. So I'll go to Google and type Anaconda Python. If you do a search and open the first link here, download Anaconda now, it will take you to Anaconda's website. So here you'll see Anaconda. It's a platform powered by Python. It's a high performance distribution of Python and R, and it includes hundreds of packages and libraries. If you scroll down a bit here, you'll see links for download for Windows, OS X, and for Linux. Click on download for Windows, and here you'll see options to install Python 3.5 version or Python 2.7 version. Our course uses Python, we use Python 2.7, so we'll be installing Python 2.7. For that, the easiest way to install Python 2.7 Anaconda is by clicking on this button, whether you are using 64-bit or 32-bit. Click on the appropriate button. So once you download the installer, and then once you finish that, double click the .exe file to install Anaconda and follow the instructions on the screen to complete your installation. And if you prefer to use Python 3.5, go ahead and click on the appropriate button, whether you are using 64 or 32 bits. Again, once you download the installer, double click the .exe file to finish installation and follow the instructions on the screen. Great. Okay. Once you complete installing Anaconda, the next thing you need to do is click on this Start Windows button, and then you can type Anaconda prompt. Anaconda prompt, and then when you type Anaconda prompt, it will pop up. I see it here. If you don't see it, you can type Anaconda prompt and open Anaconda prompt. And once you have Anaconda prompt open, the next thing we need to do is type Python. So this will make sure whether Anaconda is installed or not. So we'll type Python, and press enter. Here you'll see your Python version, Python 2.7.11. You might see a different version since I installed Anaconda a while ago. And you'll have Anaconda 64-bit and some message like this. So we know Anaconda is installed. And here you can perform some Python statements. For instance, I can say print hello there, and then enter. Hello there is printed. And if I perform some operations, let's say 4 plus 98, 102. So these are some Python operations and statements. I can say for I in range 6, let's print I. Print I. So I know that Python is working. This is to make sure whether Python works or not. And if you make any mistakes, it will show you the error that you make. So this is just to verify that Python is working on our system. Okay. Okay, now we see that Python is working. Great. And once you finish this, if you want to quit Python, you can simply type quit and then press enter. So that will quit Python. And if you want to clear your screen, you can use the command clear. Great. The next thing we need to do is install Jupyter. So if you go to jupyter.org, you can go to Google and type Jupyter and open the first link, or you can simply search for the link jupyter.org. And it will take you to the Jupyter's main web page. So we'll be installing Jupyter Notebook. So you can click install, and then it gives you some, you can read more about it here. For instance, here it says they recommend installing Anaconda for installing Jupyter. They go along very well, and you can read more about the information here. But let's go ahead and install Jupyter. So to install Jupyter, click on your Start Windows button and search for Anaconda prompt. And once you are in Anaconda prompt, simply type conda install Jupyter. So conda space install space Jupyter. That's the command you need. Conda space install space Jupyter. Press enter. So it will take a moment. It might take a few seconds. I have already installed Jupyter. So it says all requested package already installed. For you, you might see a little bit different message and also longer because it takes some few seconds to install Jupyter, all the packages and things involved. So at the end, you might have to press yes, or you'll see a message saying installed successfully or something like that. Okay. Once you finish Jupyter installation, we gotta make sure that Jupyter works or not. For that, the command we need is simply type Jupyter space notebook. Jupyter space notebook and press enter. So this will open up your Jupyter Notebook on your browser. So here I have the Jupyter Notebook homepage. This is the homepage. And then here you can click to start a new notebook. Click on new. And then you'll see the options Python Conda root or Python default. Click on either one of these two. You might see Python 2 or Python 3 depending on your installation. If you see Python 2, if you are using Python 2 and if you see the option Python 2, click on it. If not, if you see Python Conda root and Python default, click on either one of them. That will open a new notebook for you. Let's open Python root. So this is a new Jupyter Notebook. Here is where you can save the title for your notebook. Let's say the title for this will be Python installation on Windows, for instance. So you can see that will be the title of your notebook, and then these are your notebook cells. And you can type commands like print hello there, and then to run a cell, press shift and enter on your keyboard. Let me write it here. Shift plus enter on your keyboard will run a cell, and you see the result displayed right after your input. Print hello world is there. You can also perform some Python operations. We can say if x is equal to 6, print the value of x is 6, or else we can say print wrong value. So if you run this, print wrong value. If you run this, you'll get wrong value. So I know that our Jupyter Notebook works fine. So this is another Python statement for I in range, let's say 6, print I. We'll learn about all of this. These are some of the Python statements. I'm just making sure that our Jupyter Notebook works. Great, so the notebook works fine. Another advantage about Jupyter Notebook is that you can use Jupyter Notebook online for free if you want. So if we go to jupyter.org, and if you scroll down here and click on try it in your browser button here, you can use Jupyter Notebook for free online For this, you will need an internet connection. So for that option, click on New, and then select your Python version. We're using Python 2, so I'll click on Python 2, and that will open up a new notebook for you. Again, to see if Jupyter works or not, you can simply say print hi there. Hi there is printed. I can say, let's say x is 8. Then let's use some if statement. If x is equal to 8, print the value of x is 8. Else we can print, I don't know what x is. In this case, since x is equal to 8, the statement will be printed. The value of x is 8. We'll learn all about this. I just wanted to see if Jupyter Notebook works or not. So this is how you can use Jupyter Online for free. And we need an internet connection. Okay. And the other option that we have, the one we will use mainly, is by going to your Anaconda prompt and then typing Jupyter space notebook. Right now, my Jupyter Notebook is working. Right? It's running. This is all the message I see here. And if you want to quit Jupyter Notebook, you can simply press Ctrl and C on your keyboard. Ctrl and C. So now Jupyter is no longer running. And if you go to your Jupyter Notebook, it will say connection failed. That's because your Jupyter Notebook is no longer running. That makes sense, right? And you can restart your notebook by simply going back to your Anaconda prompt and then type Jupyter space notebook and then press enter. So now you have Jupyter. This is the Jupyter homebook, and then click on new to start a new notebook. Click on new and select Python conda root or Python default. Okay, and you might see the option Python 2. If you see that, click on it. If not, if you see these two options, it's fine. So you can click on Python conda root or Python default. It doesn't matter. Then you can perform your statements here. Great. So just to recap what we did in this lecture, we looked at Python installation for Windows, and we installed Anaconda and Jupyter. We saw the advantage of Anaconda, and we installed Jupyter by using the statement conda space install space Jupyter. And to open a new notebook, you can type Jupyter Notebook on your Anaconda prompt. Great. Thank you everyone, and see you at the next lecture. Hello everyone, and welcome to the lecture on Python installation for Mac and Linux users. In this lecture, we'll see how we can install Python and start using it. So we'll need to install Anaconda and Jupyter. Anaconda is distribution for Python, and it has lots of packages. Installing Anaconda will also install Python. And why do we choose to install Python? Why do we choose to install Anaconda? Here are some of the advantages of using Anaconda. It's very easy to install. If you are using Windows, you don't have to worry about figuring out the environment paths. It's very easy to install, or update packages independently. So updating packages or installing new packages is independent of any system libraries, and it has lots of packages already installed. Some of the packages are Numpy, SciPy, and so much more. And this also makes its size a bit big. So the size of this Anaconda distribution is about 350 megabytes, around that. So that's why it's a bit big, since it has lots of packages already installed. But it's very easy to use. Okay, let's go and install Anaconda now. So if you type Anaconda Python in Google and open the first link here, it will take you to the official site of Anaconda. So this is the site for Anaconda, www.continuum.io. And if you scroll a little bit down, you will see that it's an open source data science platform powered by Python. It has lots of packages already installed. And here you'll see the options for download for Windows, download for Mac, and download for Linux. So for Mac users, click on the download for OS X link here, and then you'll see Python 3.5 version and Python 2.7 versions. For our lecture, for our course, we'll be using Python 2.7 version. So click on the graphical installer here. So this is the size of the software, around 400 megabytes. So the easiest way to install Anaconda is by clicking on this graphical installer, and once you download this graphical installer, double click the downloaded .pkg file and follow the instructions that appear on the screen. That's the easiest way to install Anaconda. And if you prefer, the other option is through command line installer, and here are the instructions for that. So for Python 3.5 and Python 2.7, but this is the easiest way. Click on the graphical installer, and once you download the graphical installer, double click the downloaded .pkg file and follow the instructions to complete your installation. Great. Once you finish installation, to make sure that Anaconda is installed, open your terminal. So if you are using Mac, you can click on command and space and type terminal, enter. So this will open your terminal. My Jupyter is already running, so I'll close it, shut down. Okay, let me clear my screen. So this is what it will look like when you first open your terminal. You'll see this. So if you type Python and then press enter, you'll see your Python version. So Python 2.7, and then you'll see your Anaconda, some message like this. Okay, so now we know that Anaconda is installed and also Python is installed. So we have installed Python by installing Anaconda. And since we have typed Python, now we can use Python here. For instance, I can say print hello there. Press enter. Hello there is printed. This is a simple Python statement. You can say for I in range for then print I. You see? So now we know that Python is working. So these are simple Python programs or statements just to make sure that Python is working great. And once we check that, you can quit Python. So if you want to quit Python, simply type quit and then press enter. So now we have quit Python. And once we quit Python, if we try to run some Python statements, we'll get an error. Okay, so right now if I do that, I'll get an error because I'm not in Python, and the clear command will clear out my screen. So this is the easiest way to install Python through Anaconda installation. Now that we have installed Anaconda, the next thing we need to do is install Jupyter. Remember, Jupyter Notebook is our IDE option. We'll be using Jupyter throughout the course. That's what we'll see next, how we can install Jupyter. So if I go to jupyter.org, so you can type jupyter.org, or you can go to Google and simply type Jupyter and open the first link. It will take you to the jupyter.org main page. And you can click on install here. So we'll be installing Jupyter. And here we have Jupyter. So here it says for new users, we recommend installing Anaconda. Anaconda conveniently installs Python, the Jupyter Notebook, and other commonly used packages for scientific computing and data science. Great. So you can read more about jupyter.org here, about Jupyter. So the documentation are here, and you can read more about it on jupyter.org. But for our purpose, what we'll need is we need to go back to our terminal, and then to install Jupyter, type the following command. So conda space install space Jupyter. So this is the command that we need to install Jupyter. Conda space install space Jupyter. Then press enter. So now it's fetching all the packages and installing Jupyter. So I have already installed Jupyter on my machine, but for you, you'll see that installation completed or some other message. But since I have already installed Jupyter, I get this message, so I'll say yes. Okay, so now it's complete. Okay, now we have all the things that we need. Let me clear the screen. Okay, now we have installed Anaconda and Jupyter. Now we are ready to use Python. So how can we open Jupyter, the Jupyter Notebook? So the command to open your Jupyter Notebook is, once you are in your terminal, type Jupyter space notebook. So this command will open Jupyter Notebook on your browser. So Jupyter space notebook and press enter. So now you see Jupyter is, let me close this down. So this is your Jupyter Notebook homepage. Okay, so I have so many notebooks here, but for you, you won't see those many notebooks, those many documents here. But this is the Jupyter Notebook homepage, and in order to start a new notebook, what you have to do is click on New here, click on the new drop down here, New, and then select Python 2. So currently Jupyter has made an update, and you might not see the option Python 2. You could see the option for Python and then root. You can choose that, it's okay. Choose Python root, or if you see Python 2. So again, click on the new drop down, select Python 2, or you might see Python root. Okay, choose that, and that will open a new Jupyter notebook for you. So this is a Jupyter notebook. Here, Untitled 14, you can change your title name here. Let's say First Notebook, and then click OK. So that will be the name of your notebook. And these are your individual cells. And to double check that Jupyter is working, you can print some statements. Let's say hello Jupyter, then press Shift and Enter to run a cell. Shift plus Enter on your keyboard. So to run a cell, again, Shift plus Enter or Alt plus Enter. And if you perform certain operations, let's say 4 plus 90, you'll get the output. If in instance we have some other Python command, let's say for I in range 7, print, let's say I plus 1, enter. So you'll see the results here. So we know that Jupyter is working. And so this is running Jupyter on our browser, right? On our screen. There is also another option to run Jupyter online. So if you go to jupyter.org, to the main site. So if you go to the main site, jupyter.org, and scroll down, you'll see a button here to try Jupyter for free in your browser. You can do that. So click on the try it in your browser link or button. So this will run Jupyter online, and you will need an internet connection for this. Okay. Again, if you want to open a new notebook, click on New, and then click on Python 2, since we are using Python 2.7, and that will open Jupyter Notebook. Then print hello Jupyter to see if it's working. So hello Jupyter is printed. So this is the second option that you have for running Jupyter. It's free to run Jupyter online, but you will need an internet connection. Okay, I'll just close that down. So just to summarize what we saw in this lecture, we saw how to install Anaconda for Mac or Linux users. So we went to continuum.io, the main Anaconda site, click on download for OS X, and then we install the graphical installer, follow the instruction on the screen to complete installation. And if you are a Linux user, do the same thing by clicking on download for Linux. It has the same instructions. Download the graphical installer and then complete your installation. And once we downloaded Anaconda, we went and downloaded Jupyter. We installed Jupyter, and we mentioned that We mentioned that to install Jupyter, we use the command conda space install space Jupyter on our terminal, right? We opened our terminal and we use this command to install Jupyter. And once we installed Jupyter, we saw that we could open a new Jupyter notebook. We could open Jupyter on our browser by typing Jupyter space notebook. That will open Jupyter Notebook on our browser. And once we have our Jupyter homepage open, we can start a new notebook by clicking on New and then selecting Python 2, or if you see Python root, select that option, and that will open a new notebook for you. Great. Thank you, everyone. Hello, everyone, and welcome to the lecture on Basic Introduction to Python. In this lecture, we look at some of the basic syntaxes in Python language. We learn about variables, functions, and so many other object types in Python. And here are some of the data types in Python: strings, lists, dictionaries, and tuples. So all of this data types, variables, functions, and objects, they need to follow certain naming conventions. So we store the value of certain data types in variables or other objects, and they follow naming conventions. So for this naming conventions, our variables can start with letters. So letters, it can be upper or lowercase, or they can start with underscore. So those are the rules. The name for our variables can start with letters, upper or lowercase, or an underscore. And they can be followed by numbers or letters. Okay? For example, let's say we have this number 5. And if I want to store this number 5 in a certain variable, let's say x, I can say x is equal to 5. So this will be my variable. The variable is x, the variable name. So the variable name can start with letters, which is upper or lowercase, or it can start with an underscore. So we look at 3 examples. Let's say x is equal to 5. So this is lower x. Then we can say upper x is equal to 7, for instance. And let's say underscore x is equal to 8. So these are appropriate naming conventions. Python is case sensitive, so upper x and lower x are different, since Python is a case sensitive language. So let's run our cells. To run a cell, hit Shift plus Enter on your keyboard. That will run a cell. So let's run the cell. X is equal to 5. Now let's run the cell. Upper x is equal to 7. And the third cell. Now if we call our variable x, which is lower x, 5 will be printed. So the value of our variable x is 5. Whereas if we call our upper x, the value 7 will be printed. And if we call our variable underscore x, we get 8. So those are appropriate or valid names for our variables. And as I mentioned, these letters can be followed by one or more numbers or even letters. For instance, I can say let's say my number, let's say 45. So if we run this, this is appropriate. And if I call my variable my number, so that's the variable name, my number, 45 will be printed. My number, random cell, 45 is printed. And we cannot use punctuation characteristics like percentage sign or dollar sign for naming. So if we use this, we'll get an error. Let me show you an example. So I cannot say percentage x is equal to 22. If I run this, I get an error. So variable names cannot start with percentage or dollar sign. I cannot say, let's say $3, $x is equal to, let's say 4. So syntax error, invalid syntax. Then you have the dollar sign. So our variable names cannot start with punctuation names, with punctuation marks or characters, like percentage sign or dollar sign. And as I mentioned, Python is case sensitive. For instance, if I say my number is equal to 7, is different from my number is equal to 9. So in this case, if I call my variable my num, I get 7, whereas if I call my variable uppercase my num, I get 9. And variable names can not start with what is known as keywords. These are reserved words in Python, reserved words. So our variable names cannot start with keywords. So for a list of keywords, I have a link here. It just shows the keywords. These are some of the keywords: end, as, assert, break, class, continue, def, while, print, raise, and so on. So we cannot use any of these keywords for our name, for our variable name. For instance, if is one keyword, we cannot store, let's say, our number 5 in a variable called if, because if is a keyword. If we run this, we get an error. Okay, since if is a keyword. Another keyword is the statement except. If I say except is equal to 8, I'll get an error. That's because except is a keyword. So that's important to remember. Next, let's talk about lines and indentation. Lines and indentation are very important in Python, and that's how Python keeps track of the code that we write. Let me show you an example. For instance, let's say print x is 5, and if we run this, x is 5 is printed. Now let me show you a simple if statement. We can say if. Before that, let's define a character. Let's define a number and save it in a variable. Let's say I is equal to 8. So if I call I, 8 will be printed. The value of I is 8. Now let's use an if statement. We can say if I double equal to, let's say, 9, print the value of I is 9. Notice here the indentation. So before I wrote this, so if I remove that, so if I double equal to 9 colon, and then when I hit enter, you see it automatically indents for us, because that's how it keeps track of all the codes. So indentation is important. Let me paste it. And then if I hit enter again, so it indents, we can go back and let's have another statement, else. And then when we hit enter, it auto indents for us automatically. So that's how it keeps track of all our code. Else print, let's say, the value of I is not 9. So if we run this statement, if we run this code, this print statement will be printed. Since I is not equal to 8, the else statement will be printed and we'll get the value of I is not 9. So you get the value of I is not 9. Now, so it keeps track of all this code due to this indentation. So Python knows that this statement, this print statement, is under the if condition here, whereas this print statement is under the else condition here. So instead of this, if let's say if we don't indent this and try to print this, we'll get an error. So if we run this, it says indentation error. Okay, because after this else statement, Python expects an indentation, but it's missing an indentation. So we get that error. Similarly, under the if condition, if I don't indent, I'll get the same indentation error. It says indentation error, expected an indented block. Then it shows you where an indentation is expected. So it's expecting an indentation here. So we'll learn more about indentation when we go through the lecture, but this is just a brief introduction that indentation is very important in Python, and that's how it keeps track of all the codes. Great. In the next lecture, we'll continue our introduction on basic Python. Thank you, everyone. Hello, everyone, and welcome back. In this lecture, we'll continue our discussion on basic introduction to Python. We'll look at some more of the basic syntax in Python. In the previous lecture, we looked at how we can give variables their names. So we looked at how naming is conveyed in Python. We mentioned that we can use upper or lowercase letters or even an underscore for naming, but we cannot use punctuation characters like percentage sign or the dollar symbol for naming Python objects. And we also looked at indentation is important in Python. Now let's continue our discussion. So one important Python statement is the print statement. And you have seen me doing print and then in quotes this statement will be printed, and whatever is inside the quote will be printed. So that's how we can print a statement. We use the print keyword or statement, and then whatever we want to print, we include it in either double quotes or single quotes. In this example, it's in double quotes. We could also include it in a single quote. This statement will be printed. So it's the same. We can use single quote or double quotes. What if I say print I am cold? So in this case, Python is confused. So you have the print statement, so it expects a quote, either single or double. So we have a quote here, and then we have another quote here. So Python understands the print statement ends here, right? And then you have this m and then called. So Python is confused in this case. And what happens is if I run this, I'll get an error. So if I try to run this statement, I am called, and run it, it says syntax error, invalid syntax. Because for Python, the statement ended here, since the quotation is here. So in this case, what we can do is we can use a combination of single and double quotes. So in that case, we can say print I am called. You see here we used double quotes to enclose the entire statement, and then we have a single quote in our statement. So this is how we can use a combination of single and double quote. So I am called. Similarly, we can use the reverse print. Let's say we can enclose everything in single quotes and say he said he would be there in a few hours. So that's also appropriate. So we have our print statement, everything is enclosed in a single quote, and then we have a double quote in our statement. That's appropriate. If we run this, we get he said and he would be there in a few hours. Okay, that's how we can use single and double quotes. Depending on what you have in your statement, you can combine it both. And earlier you have seen me do using the pound symbol. This is a comment. What does a comment mean? A comment means when we run the cell, it will not be executed. So if I run this, nothing will happen. A comment means a way to add some more description to our code, but we don't want it to be printed. For instance, I can write the following. Let's say a function to add two numbers. So I'll be defining a function, define, and I'll call it add numbers, and then it takes two variables, x and y. So don't worry about this, I just wanted to show you some things. And then return x plus y. So this is a function that will take two variables and xy, two variables x and y, and return the sum of the two variables x and y. And here I use the comment, a function to add two numbers. So this comment is a description of what this function does. So it says a function to add two numbers. So whoever is reading a code will know that this is a function that will add two numbers. Okay, so that's how we can use a comment to add more description to our code. That's one way to use a comment, and we can also use it in separate places. Let me give you another example. Let's say print the value of x and y is, so we can add a comment here, whatever we want, right? So comment goes here, or we can also add a comment here. Comment can go here too. In this case, simply the statement the value of x and y is will be printed. Okay, let's see this in action. So let's use the raw input function. This raw input function is a function used for prompting a user. So we can say raw input, and then please choose a number. Okay, let's add a comment here. So we can add a comment and say this will prompt a user to enter a number. So this is a function that will prompt a user to enter a number, and in Python 3 use the function input instead of raw input. So for Python 2 users, use the function raw input, and if you are using Python 3, use the function input and then your statement, please choose a number. Good. Now let's run the cell. So if I go here and run it, it says please choose a number, and then let's say 8 and press enter. So 8 is printed. So you see here, that's another way of writing a comment. So right next to our statement, or at the end of the statement, we can say this will prompt a user to enter a number. So these are some ways of using a comment. Again, a comment will add description to your function or statement or your code. Next, let's look at multiple line statements. Sometimes our code could be very long and we want it to continue on a new line. In that case, we can use this backslash. That means it continues on a new line. For instance, we can say print, this is going to be a long comment and it needs to continue on a new line. Don't you agree? You see how long the statement is? So this is one long statement. So let's continue this statement in a new line. So we can include a backslash. So instead of putting the entire statement in one line, we used a backslash to continue the statement or sentence on a new line. Now we can run this. So we get, this is going to be a long comment and it needs to continue on a new line. We have our indentation. That's because we indented here. And then it says, don't you agree? You see how long the statement is? So if we don't want the space, we can just continue it and then remove the space and run it again. Now we got a better statement, right? This is going to be a new line. Don't you agree? You see how long the statement is? Similarly, we can copy this and then paste it here. I just wanted to show you how to use this backslash to continue statements on a new line. So we can remove that. We can bring this back here and then cut it here. So this is a long statement. Yes, I agree, it's a long statement. And let's cut it here, continue on a new line. That looks good. Let's cut that here on a new line. Let's remove this and let's put this back there. Okay, so this looks appropriate. Let's run it, and then we have our statement. So whenever we have a long statement or a long code, we can use the backslash to continue on a new line. Next, let's look at triple single quotes and triple double quotes. So what does triple single quote and triple double quote means? Similar to comments, anything in triple single quote or triple double quotes will not be executed as part of our code. For instance, let me add this inside a triple double quote, and then let's print some statement here. Print the value of x plus the value of, let's say, 3 plus 6 is, and then we can say 3 plus 6. So for triple double or triple single quotes, we don't need to include the backslash. So if we run this, we get the value of 3 plus 6 is, so we have our print statement that's executed here, and anything enclosed in triple double quotes or triple single quotes will not be executed as part of your code. Okay, so we can put, that's another way of commenting, right? So you can add as much description as you want for your code. And let me remove this. Now if I run this, this is printed, right? So that's just what we are printing. We have a new line. This is going to be a very long comment. Don't you agree? And then blah blah blah. We have a new line. So backslash n means new line. We'll look at this when we learn about strings. So backslash n means new line. So we have backslash n, new line. Backslash t means tab. So if I say print, hi there, and then let's say backslash n, new line. Let's say, how are you? And then we can say backslash t, I am good. So backslash t means tab, backslash n means new line. So if I run this, I get hi there, and then new line. We have how are you, and then backslash t means space, and then we have I am good. So that's the meaning of backslash n and backslash t. That's what we have here. New line, new line. So you see here, whatever is enclosed in triple double quotes, if you are just printing it, it will print the value. Whereas if we have another statement here, print the value of x, the value of 3 plus 6 is 3 plus 6, while when we print this, we only print, it only prints this whatever is in the print statement. So this adds more description to your code. We'll look at more of this when we learn about functions and object-oriented programming. So similarly, we can also put our multi-line comments. This is also called a multi-line comment since it's sparse over multiple lines. So we can put our multi-line comments in triple single quotes. So it does the same thing, triple single quotes. And then, no, I don't want that print statement. I want this statements. Let me paste it here. Okay. So multi-line statement, and then we can have our print statements here. Let's say print the value of x is 5. If we run this, we get the value of x is 5. So this is used for, again, this is used for multi-line comments, triple single quotes or triple double quotes. We'll learn about this when we talk about object-oriented programming. This is also called docstring, documentation string. Don't worry about it, but we'll see it in depth later on. I just wanted to show you the use of triple single quotes and triple double quotes. Great. To summarize what we looked in this lecture, we saw that we can use the pound sign to enter comments, and comments are a way of adding description to our statements or functions or our code in general. And if we want to continue our statement or code on a new line, we can use the backslash character. And we also looked at the use of triple single quotes and triple double quotes. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the lecture on strings in Python. In this lecture, we'll see how to create strings. A string is a sequence of characters, and we use strings to store data. Let's see how we can create strings. So strings are created by using double quotes or single quotes. For example, we can create a string by using double quote, and then we put the string value inside the double quotes. So this is an example of a string. So here in this example, my string is inside this double quotes. So this is an example of a string. And when we run that cell, we get our string. We can also create strings by using a single quote. So we put a single quote, and then the contents of the string will be within the quote, within the single quote. This is also an example of a string. We get the same result. What if we have a double quote or a single quote within our string? Would that be a problem? Let's see. For instance, if I want to say I am here, notice here my string is I am here, and I have enclosed that in single quotes. But if I run this, I'm going to get an error. Let me run it and show you. It says invalid syntax. That's because you see here at the beginning I have a single quote, and then I have the letter I, and then another single quote. That means this is my string. This is one string, and then so Python is confused with this. So I have one string here, and then it's this part is giving an error. So Python is reading this as one string, and then this part is producing an error. The second part is producing an error. So in order to avoid such kind of error, we can enclose a single quote within a double quote, or a double quote within a single quote. So instead of this, I can say I can enclose my string in a double quote and include my single quote inside the string. So instead I can say this, I am here. So this is perfectly fine. I am here. So the same is true for double quotes. For instance, we can say he said where is he? So in this case, I have a double quote within my double quote, and if I run this, I'm going to get an error. So for the same reason as we saw here, so Python reads this as one string since it's enclosed within those double quotes. However, this part doesn't have a beginning with a quote, so that produces an error. You see it says invalid syntax. So in this case, we can enclose this with a single quote. So instead we can say he said, and then we can include our double quote now. Where is he? Then we can enclose that. So this is perfectly fine. So we can alternate by including a single quote within a double quote, or vice versa, to create strings with quotes. And another way of doing this is by using what is known as the escape character. So this backslash is called the escape character in Python and many other languages. So what is this escape character? Let me show you an example. So here we have I am here. I can also say I and then am here. Then so this means if I execute this, I'm not going to get an error. Why is that? So Python treats this escape character as ignore the next character. So this means ignore the next character. That's why we're not getting any error. So this backslash means escape character. So slash apostrophe or single quote means ignore the next character. So anything followed by this backslash means ignore the next character. So I am here, we can write it like that. So same thing here. Instead of this double quote, we could have also said he said, and then this backslash, it means ignore the next character, which is ignore the double quote. And same thing here, we can include another backslash, and that's perfectly fine too. So this backslash, there are also other characters. We learn about how we can introduce some other characters using a backslash. Great. So in the above examples, all of our strings are on a single line. What if we have a string that's on more than one line? In that case, we use triple double quotes or triple single quotes. We use those for writing or creating multiple line strings. Let me give you an example. So triple quote, we can say this is an example of a string which is written on multiple lines, and so on. So this is how we write a multi-line string. We use triple double quotes, or we can also use triple single quotes. So this /n means new line. So here you see this is an example of a string, and then we have a new line. So this /n means new line, which is written on multiple lines. And then we have /n again. That means new line. Remember the escape character? This means new line. New line. And we have another one is /t. This means tab. Tab means space. And we can also create multiple line strings by enclosing them within triple single quotes. This is also a string written on multiple lines, and it is absolutely fine. So if we run this also, we get the same result. So this is how we can write multiple line strings. what if we have adjacent strings? For instance, what if I say this is an adjacent string? So here I have what? This is one string, this is another string, 3 and 4. We have 4 strings here. So if we execute this, we get one string. So we get one string. This is an adjacent string. That's because adjacent strings are concatenated to make a single string. This is also important to remember, that if we have adjacent strings, they will be concatenated to make a single string. Great. Hello everyone and welcome back. In this lecture, we'll continue with our introduction to strings. We finished our last lecture by looking at adjacent strings, and we said that if we have adjacent strings, they will be concatenated to make a single string. That's also true if the adjacent strings are also on a multiple line. This is a string, and if we continue this on a new line and say, let's say this is a string and it is a very long string, and continues on a new line. So this is a very long string. If we still run it, it will be, so in this case only the last part will be executed. We only see n continues on a new line. So if we have a very long string and if it continues, for writing purpose, usually you'll see codes written like this. Instead of writing this whole string on one line, you'll see it being broken down or written on multiple lines. This is for readability purpose, so this is more neat than writing all of this in one line. So in this case, we include the slash at the end of each sentence, each line. So this slash means it continues on a new line. Now if we run this, we see that the whole string is now concatenated, but that's how we write multiple lines. If we have a very long string, we add a slash at the end of each line. This basically means it continues on the next line. Good. Now I will introduce you to the print statement. So in the example above, if I have, this is a string and then this is another string on a new line. If I execute that, only the last statement is executed. This is another string on a new line. How about the first statement here? It's not executed. So in order to execute all statements, we use the print statement. So we say print, this is a string, and then we say print, this is another string on a new line. Now both of the statements will be executed. So that's the use of the print statement. So that will execute every statement that we write here. So print and then our string. Okay, let me show you. Earlier we looked at /n and I briefly mentioned /t. So this is for a new line and this is for a tab. It means tab. Let's see how we can do those. So I can say print, let's say this is a statement, and then let's say tab, and this is another statement. So if we run this, you see here this is a statement and then tab, and this is another statement. So /t means tab. I can also say let's use a tab, which is /t, and a new line /n. Anything after will be on a new line. So in this case, we'll get, let's use a tab and then tab and a new line. So this statement, anything after will be on a new line, we'll see those. You see here, let's use a tab, then we have a tab and a new line. We have a new line here /n, so anything after that will be on a new line. We can also introduce another new line here. For instance, we can say /n, and that will be on another new line also. So that's how we can use tab and then new line. So /t for tab and /n for a new line. So this print statement, print is a statement in Python 2, whereas in Python 3, print is a function. So that's one key difference between Python 2 and Python 3. So if we want to execute a print function in Python 3, we'll have to enclose it in parentheses. So this is a string. So that's how we would print a string in Python 3. Okay, so this is how you would print a string in Python 3. So that's one key difference between Python 2 and 3 when it comes to printing. Great. So far we have seen how to create strings. Next, let's see how we can access elements in our string. For instance, what if I want to access this element in my string? How can we do that? Let's start by storing our string in variables. So we can store our strings in variables. Let's say string name, that will be our variable, and then let's say I'm here. So this will be my string, I'm here, and I'm storing my string in a variable called string underscore name. And we can store our string in any variable that we want. For instance, we can say ss string variable. We can use any variable that we want. Once we have that, once we save our strings in a variable, if we call our, for instance, variable ss, we get string variable. And if we call our variable string name, we get I am here. Okay. So in the example here, ss, we have string variable. What if I want to grab r, just the character r in my string ss? How can I do that? So we can use what is known as indexing. I can simply say ss and then indexing, r is at index 2. So if I say ss rectangular bracket and then 2, that will give me r. So this is how we can access elements in my string. We use indexing. Indexing starts from 0. So here s will be index 0, and then this will be index 1, 2, 3, 4, 5. The empty space will be 6, and then 7, 8, 9, 10, 11, and so on. So indexing starts with 0, and then we use rectangular brackets or braces for indexing. If I want to grab the empty space here, that will be at index what? So 0, 1, 2, 3, 4, 5, 6. So if I say my string ss, my variable ss at index 6 will be an empty space. So this is how we can grab certain elements in a given string. And if we want to grab more than one element, let's say if I want to grab this var, how can I do it? For that we use what's known as index slicing. So we'll have to pass our index as a slice. That means from index this up to index this. So let's see that. So this is index 0, and then 1, 2, 3, 4, 5, 6, 7. V is at index 7. So I want the elements from index 7 up to 8, 9. So R, the second R is at index 9. So if I execute this, I will only get V and A. Let me show you. I'll only get V and A. You might wonder why is not R included. So another thing about indexing is that the end point is not included. So index 7 to 9 means in this case, so the starting point is included, 7 is included, and then 8 and 9 is not included. So if I want to grab R, I have to go to the next indexing number, which is 10. So this basically means grab elements at index 7, 8, and 9. So the last indexing number is not included. So if we execute this, we get, if we execute this, we get var. Great. Hello everyone, and welcome back. In this lecture, we'll learn about string operations. We finished our last lecture by looking at how we can grab or access elements in a given string. So if we have a string, let's say string, we said that we could access elements in that string by indexing it. For instance, if we want to grab the first element s, we can simply say we have our string ss at index 0. That will grab the element s. In this lecture, we'll look at string operations. So strings allow operations like addition, which is known as concatenation. That's concatenation. We can use multiplication and slicing. Let's start by looking at concatenation. So we can concatenate one string to another. For instance, we can say hello plus there. So when we run it, we get hello there. So that's concatenation. Concatenation adds one string to another. We can also say we are learning plus ss. Here ss stands for string, right? So in this case, we'll get we are learning string. So when we run this, we get we are learning string. And if we want a space between those two, you can simply include that here. So now we'll get a space. So we are learning string. Same thing here. You can either include a space here, or you can also include a space here. Okay, let's say we have, so if we add ss to ss, we get string 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 string. So we can concatenate one string to another. And let's say Python. So our variable xx has stored the string Python. So we can say xx plus ss. That will give us Python string. Okay, that's concatenation. Next, let's look at multiplication. So this multiplication will repeat a given string. For instance, if I say string times 5, so I'll get string 5 times. So string, 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 so on. Similarly, if I add a space there, I get the result string times 5. Similarly, we can say hi there. Then if we multiply by 5, we get hi there, hi there. So that's concatenation, that's multiplication. Next, let's look at slicing. We have looked at slicing earlier. We use slicing to access elements in a string. Let's say we are here and it is called. Let's save this in a variable called ss. Notice here I'm storing most of my strings in a variable ss. You might ask the question, wow, when you call ss, it's printing we are here and it's called. Why doesn't it print the previous variables that we have saved? So in this case, we can override a name of a variable. Okay, whichever gets executed last will be the value for that variable ss. So that's why I keep saving it in the same variable. So once we save this and then run it, so Python will only remember this last variable ss. Okay, in this case it will not remember all the previous ss variables, so you don't have to worry about that. But if you want, you can save it in different variables. It doesn't matter. Okay, here it says we are here and it's called. So if I want to access a certain element, we can say ss at index, let's say 8. That will give us e. What if I say ss at index 34? That will give us an error. It says string index out of range. That's because we don't have an index 34. So the maximum, it will go up to the max, and any index out of bound will give us an error. So here it says string index out of range. Great. Indexing also works in negative indexing. What do I mean? I can use negative numbers. For instance, if I want to grab the last element here, one way is to start from here and then say 0 index. This is index 0, 1, 2, 3, 4, 5, 6, and so on until I get to the last index. That's the long way. The short way is we can say index ss at index -1. This means the last element, which is d here. So we can do that. So this will be index -1. This will be index -2, -3, and -4. So if I want to grab this element or value C, I can say, so my variable SS at index -4, that will grab C. And what if I say colon? So this means, colon means grab everything from beginning to the end. So if we run this, we get, we are here and it's called. So colon means grab everything. We can also use index slicing. So we can say SS grab everything from, let's say, index 3 to 8. That means grab elements at index 3, 4, 5, 6, and 7. And we get that. And we can say, if we can also check if a given element is in our string. Let's say, I can say, for instance, I can say O in SS, we get true. That's because O is in our string. And if it's not, if the element is not in our string, we get false. For instance, we don't have X in our string. So if we say X in our string SS, we get false. So we can use in to see if a given element is in our string or not. Great. To summarize what we have learned in this lecture, we looked at some of the string operations that we can use on strings. We looked at concatenation. We looked at multiplication and how we can use slicing in strings. Thank you everyone, and see you at the next lecture. Hello everybody, and welcome back. In this lecture we'll learn about one of the important characteristics or properties of a string known as immutability. Immutability means once we create a string, we cannot replace or substitute or change the elements. Let's look at an example. So let's say we have a string called Python, and if we call our SS, we get Python. That's our string, and we've seen that we can access any of these elements by indexing it. For instance, if I want to grab O, I can say SS at index -2, and I get O. If I want to grab the last element N, I can say NN at index -1, or I can say NN SS at index 0, 1, 2, 3, 4, 5. So SS at index -1, or my string SS at index 5. That will give me N. And we've seen that if our index is out of bound, we get an error. So for instance, if I say my string SS at index 7, I get a string index out of range error. That's because we don't have index 7. Okay, those are some slicing or grabbing an element in our index. We've seen that we can also grab a slice of our elements. For instance, we can say SS from index 0 up to index 4, or simply we can say SS up to index 4. That means grab everything up to index 4. So this will grab elements at index 0, 1, 2, and 3. So that's what this means. Colon 4 means grab elements up to index 4. Similarly, we can say SS 2 colon. That means grab everything starting at index 2. So grab elements at index 2 all the way to the end. So if we run this, we get thon. T is at index 2, right? 0, 1, 2, and then everything else. That means thon. Great. Now let's look at immutability. Let's say SS at index 2. We know that the element at index 2 is T. What if we set that to be equal to R? What do you think will happen? This will give us an error. It says string object does not support item assignment. That's the property immutability. It means once you create a string, you cannot substitute or replace the elements in the string. So we cannot assign a new value to any of the elements in our string. Here we're trying to assign R to our string at index 2. So if we call our string SS, what do we have here at index 2? We have T. So this is trying to assign the value R to our string SS or to our string Python at index 2. So this is not allowed in string, and that's a very important property of string. It's called immutability. Once you create a string, you cannot replace any of the elements in your string. Similarly, if we have another string, let's say string 2, let's say it's equal to hello. So we have that, and if we call our string 2, we get hello. And if I say string 2 at index 3, let's set it to be equal to I, we get an error. So string object does not support item assignment. Great. This is what I wanted to cover in this lecture about immutability. It means once we create a string, we cannot replace the elements within that string. Great. Thank you, everyone. Hello, everyone, and welcome back. In this lecture and in the next few lectures, we'll learn about built-in string methods. Python has its own built-in string methods that we can use. Let's say we have a string S. SS is equal to, let's say, Python. So our variable SS contains the string Python. So if we say SS dot, and if we hit tab on our keyboard, so SS dot, and then hit tab, that will give you the list of all the built-in string methods that we have on a string. So SS tab, SS dot, and then hit tab on your keyboard. That will give us a list of all the string methods that we have. So we look at most of the string methods. Let's start by looking at the method known as capitalize. So this method capitalize will capitalize the first alphabet in our string. For instance, let's say we have a string SS, and let's set it to be equal to hi there. And then if I say SS dot capitalize and then run it, we see that the first letter H is now capitalized. So this is how we call a method on a string. We have our string SS and then dot, name of our method, which in this case is capitalized, and we have empty parentheses. That's how we call a method on a string, or even methods in general. And we'll see the use of this parentheses. In this case it's empty. In some of the methods we will have to pass some arguments in here, but here is one method capitalized, so that will capitalize the first letter. Now let's look at another built-in string method. It's called the lower method. This method will change all the characters in our string to lowercase. So here, if we call our ss, we have hi there. Let's create another string and save it in a variable called ss. Let's set it to be equal to hi there. Now if we call our string ss, we have hi there, everything is uppercase, and if we call the lower method on it, it will change all these characters to lowercase. Now we have hi there. Similarly, we have another built-in string called upper. So let's create another string. ss is equal to hi there, what's up. Let me save this in double quotes. So everything here is in lowercase. If we call our string ss, we get hi there, what's up. And then we can use the method called upper, and this will change all the characters to uppercase. Now we have hi there, what's up. So those are the two methods, upper and lower. There are also methods known as is upper and is lower. So let's look at the first method, is upper. This will give us true if all the characters in our string are uppercase. So all of them have to be uppercase in order for this to be true. For instance, let's call our ss hi there, what's up. So if we call the upper method on our string ss dot upper, we get is upper, we get false. That's because not all the characters are uppercase. Similarly, the method is lower will return true if all the characters are lowercase. So in this case, all the characters are lowercase. So we have the result true. If we create another string and store it in a variable called upper, and let's say all upper case. So if we run this, and then if I call my string upper, we get all uppercase. If we call the is upper method on our string, we get true, since all the characters are uppercase. Great. Next, let's look at another method called is alphanumeric. So the method is called is alphanumeric. So this will return true if all the characters or elements in our string are alphanumeric. So all of the characters have to be alphanumeric in order for this method to be true. For instance, let's use our string upper. So upper that is alphanumeric. So we're calling the alphanumeric method is alphanumeric method on our string upper, and that gives us false. That's because not all the characters are alphanumeric. Okay, notice that in our string upper, all uppercase, we have a space. A space is considered a character, right? That's why we have false here. So all the characters, all the elements in our string have to be alphanumeric. So because of this space, we have the result false. However, if I have another string, let's say string 1 uppercase, let's call the is alphanumeric on it. So string 1 that is alphanumeric, we get true. That's because all the characters are alphanumeric and there is no space. If there was a space like this, it would return false. Similarly, we can add a number here, uppercase 1, 2, 3, and then if we run it again, we get true, as long as all the characters are alphanumeric. And watch out for a space. A space is considered an element in our string. Next, let's look at the method called isAlpha. So this method, as its name indicates, will return true if all the characters are alphabets. So if we call the isAlpha method on our string 1, it will return false, since not all the characters are alphabets. So if I call the isAlpha method on it, this will return false, since not all characters are alphabets. Similarly, if I remove that, now if I call the isAlpha method on my string 1, that will return true, since all the elements in my string 1 are alphabets. Notice also that if there is a space here, that will return false, since not all characters are alphabets, since there is a space here. And for all these methods to work, there has to be at least one character. So if I have a string here, let's say empty, if I have an empty string, and if I call, let's say the isAlpha method on it is alpha, that will return false. That's because there's no alphabet, so an empty space is not alphabet. Hello everyone, and welcome back. In this lecture, we'll continue on built-in string methods. We'll look at the following methods: starts with, ends with, find, index, isSpace, and isTitle. Let's start with the isTitle method. So this method will return true if our string is title cased. Let's say we have a string and save it in a variable ss. This is title cased. Let's say this is our string, so we can call the isTitle method on it, and it will return true if the string is title cased. So if we run this, we'll get false, since it's not title cased. Whereas if we say ss, let's create another string, this is title cased. So this string is title cased, since the beginning of each word is uppercase. Now if we call the isTitle method on it, we get true. That's because it's title cased. Let's look at the next method, which is space. So the method isSpace returns true if all the characters in our string is a white space. Otherwise it will return false. For instance, if we call the isSpace method on our string ss, we get false. Whereas if we have another string, let's say our string is white space only, so it's white space. Now if we call the isSpace method, we get true. Great. So let's look at the next method, which is starts with. Let's look at the starts with method. So this method will return true if our string starts with the specified element. For instance, let's say we have another string. This string starts with t. So if we say ss that starts with, and then let's pass t, this will return true since our string starts with the element t. Whereas if we say ss that starts with, let's say h, that will give us false since our string doesn't start with the element h. We can also use this starts with method to check if a string starts with the specified element at a given index. Let's say we want to check if our string starts with the element s at index, for example, what index is this? 0, 1, 2, 3, 4, 5. So if we pass index 5, we get true. That's because our string starts with the letter s at index 5. So 0, 1, 2, 3, 4, 5. So we can pass that. Next, let's look at the intsWith method. And this method returns true if our string ends with the specified element. So here ss that ends with, and then let's pass t. Our string ss ends with, okay, today is called, let's run our string again. Okay, ss, this string starts with t. Okay, ss that ends with t, this will return true. That's because our string ends with t. Whereas if we pass some other element, let's say s, we get false since our string ss doesn't end with s. We can also check if our string ends with more than one element. For instance, I can check if my string ends with, let's say, str. So this will return false. And I can also pass index values to check. For instance, I can check whether my string ends with str between two index ranges. So here str is at index what? 0, 1, 2, 3, 4, 5, 6, 7. So if I say between index 5 and 8, this will give me true since my string ends with str between indexes 5 and 8. So this is index 5, 6, 7. Remember, indexing, so from the beginning of this, so indexes 5 through 8 means take indexes 5, 6, 7, not including 8. So our string ends with str between indexes 5 and 8. However, if I change this to, let's say, 9, I'll get false. That's because now my string ends with not str but with stri. That's why this returns false. Okay, we can also do that. Next, let's look at the method. What do we have? Index, I think. Index and find. Okay, find and index. Let's look at the find method. So this will find an element, and if there is an element, it will tell us the index of that element. And if the element doesn't exist in our string, we get -1. Let's look at an example. So ss.find. Let's find the element. So this is our string. So if I pass the element r, so this will give me the index of my element r, which is, let's see, 0, 1, 2, 3, 4, 5, 6, 7. So let's run that. We get 7. And if the element doesn't exist in our string, we get -1. So for instance, if we say ss.find, let's say x, we get -1 since the element x doesn't exist in our string ss. We can also pass an index with the find method. So let's see, we have ss, the string starts with t. We can also say ss.find, find the element, let's say r, and start with index, let's say 10. So in this case, it will look for the element r starting with index 10. So here is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will start from here and check this part of the string. Let's run it. So we got 15, which is this r is at index 15. Good. Next, let's look at the index method. So this index method will give us the index of the element, if there is any. So it's very similar to the find method. However, if the element doesn't exist, we get an error. So if we say ss.index of element, let's say t, we get 0 since t is at the beginning. We say ss.index of, let's say, ring, we get index 7 since ring starts at index 7. Similarly, we can say ss.index of, let's pass an element that doesn't exist. If we say, for instance, x, this will throw an error. It says substring not found. That's how the index method is different from the find method. And similar to the find method, we can also specify where to start in the given string. So let's say ss.index of the element t and start at index, let's say 14, and run it. So we get 16, which is the last t here, I think. Let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, so it's this t, which is at index 16. Okay, so that's how we can use the index method. Thanks everyone. To recap, we looked at the index method, the find method, the isSpace method, isTitle method, and we looked at starts with and ends with method. These are all built-in Python string methods, and in the next lecture we'll continue with some more of the built-in string methods. Thank you everyone, and see you at the next lecture. And welcome back. In this lecture we'll look at the following built-in string methods: left justified, right justified, left strip, right strip, and length functions. Let's start by creating a string and we'll save it in a variable called ss. Let's say today is a great day. So let's start by looking at the left justified ljust method. This method returns the string left justified in our string of a given length. So let me show you how we can use this. So we have our string ss dot ljust, and then we provide what length we want. Let's say a length of 40 characters, and then if we just leave it like this, the default value will be an empty space. So when we run this, let me run it and show you the result. So you see here, today is a great day, and we have this many empty spaces and then the end of our string quotation. So this is left justifies. The method returned our string ss left justified in a string of the given length 40. So this is left justified. So if we leave it like this, it will fill the remaining spaces with empty space. So from the beginning to the end of the string this, it's 40 characters wide. The width of the string is 40 characters. And then let's say if this part is 20 characters, it fills the remaining space with empty space. So this is left justified. We can also specify what to fill this empty space with. For instance, we can fill it with any character that we want. Let's say if we want to fill it with the element u or the letter u, we can do that. And then now if we run it, instead of empty space, we have u. Similarly, we can fill it with, let's say, an exclamation mark. We can do that. Let's run it and see. So 40 characters, and then fill the remaining space with exclamation. So we have that. ss.ljust, let's say 25, and then fill the remaining with, let's say, greater than symbol, and so on. So it will do that. What if the length of the string we specify here is less than the actual string length? For instance, what if I say ss.ljust, then we pass, let's say, 8. So in this case, my original string is more than, the length is more than 8 characters. So if we pass this, we only get our original string, nothing else. Great. Similar to the ljust method, there is a method called rjust, right justified. Okay, rjust. This basically returns the string right justified in a string of the given length. So let's look at our ss string. Now let's see the right just method. So if we say ss that right just, if we call the right justified method on our string ss and pass, let's say, 50, so this will give us a string with a total width of 50 characters, and then it will fill all the spaces on the left with, by default, this is empty space. So it will fill it with white spaces. You see here, the white spaces are at the beginning now. You see that? Similarly, we can fill it with any other character also. Let's say 50, and then fill it with, let's say, V, and then run it. So we get V. Today is a great day. Next, let's look at the length function. The length function will return length of a given string. So for instance, in our string SS, if we say length and then pass our string SS, we get 21. So that's the length of our string SS. We can simply also pass length and then say, how long is this string? And then run it. We get the length 24. How about length of this? 1. Even if it's an empty space, remember length is 1. So that's the length function. Length of Python world. Length is 12. Great. Next, let's look at L strip and then R strip. So the L strip method will remove all the characters from the beginning of our string. By default, it removes empty white spaces. Let's look at an example. Let's create another string and save it in SS. Let's have few more spaces and say this is a string, and then if we call our string SS, notice here we have few white spaces at the beginning. Now we'll call the L strip method. So ss.lstrip, and then it will remove all the empty white spaces from the beginning of the string. Let's run it. Remember, by default, it removes empty spaces from our string. Let's look at another example. Let's say if we call our SS, okay, we looked at that. Let's create another string SS and set it to be equal to, this is a nice day. And let's use our write just method, and then let's say 40, and then add, let's say, V at the beginning. So if we run this, we have V. This is a nice day. So I'll save that in a variable called left. So now if I call my string left, we get V. This is a nice day. So now what we'll do is we'll call the left strip method on the string and remove all the V's. Remember, by default, the left strip method removes empty white spaces. We can also pass any character or specific character, and that character will be removed. So let's call the left strip method. And then what do we want to remove? We want to remove the character or element V. So let's do that and run it. Now we have the string, this is a nice day. Okay, similar to the left strip, there's another method called R strip for right strip. So this method will return a string where all the characters are removed from the end of the string. By default, it removes empty white spaces. Let's look at an example. Okay, let's say we have a string and save it in a variable SS. This is another string, and let's have a bunch of white spaces. Okay, let's run it. If we call our string SS, we have, this is
another string and a bunch of white spaces. Now we can call the rstrip method and then remove all these white spaces from the end of the string. Okay, by default it removes all the empty strings. Next, let's create another string and then add some values at the end. So ss dot left just, and then let's add 5 for instance, and let's specify the length to 39, and we'll save this in a variable called right. Now if I call the object right, we get this is another string and then a bunch of empty spaces and then 5. So what we'll do next is we'll take our right object or string and then call the right strip method, and then we pass what do we want to remove. So if we leave it by default, it will remove this white spaces, but I want to remove all these 5s. So I pass 5 as an argument in my right strip method, and then if we run it, now we have this is another string and then empty spaces. Now I can save this in another variable called, let's say, right2. Now if I call my right2 object, I have that, and we can call the right strip method strip, and then since by default it removes empty spaces, we don't have to pass anything. If we run that, we get a nice string. So that's the rstrip method. Let's look at one more method. I want to show you the count method. So the count method will return how many times that element exists in a given string. For instance, so we have our, let's create another string. ss is equal to, this is a string. Let's run it. We have ss, this is a string, so we can say ss dot count and then pass, let's say if we want to find out how many times s appears in our string, we can simply say ss dot count and then pass s. It says 3, so s appears 3 times in our string. Similarly, we can say ss dot count, let's pass an empty space, an empty white space, so that should also return 1, 2, 3, since we have 3 empty spaces. So we can use the count method to find out how many times a given element exists in a string. Similarly, we can say, if I say, let's say ss.count w doesn't exist in my string at all, so this will give us 0. Great. To summarize, we looked at a few built-in string methods like the length built-in function or method. We looked at the count method. We looked at the l-justified and right-justified, and we also looked at the rstrip and left-strip methods. Thank you everyone, and I'll see you at the next lecture. Everyone, and welcome back. In this lecture, we look at the following built-in string methods: the strip method, center, split, join, and swap case, and we'll briefly look at the dot format string formatting. Let's start by looking at the center method. The center method will return our string centered in a given width. Let's create a string and look at the method. See, this is a string, so we have our string. So let's call our center method ss.center, and if we simply pass it like that, and let's put 40, so this method will center our string in a given length of 40. So let me run it and show you. So the whole length of the string is 40, and our string SS, our string, this is a string, is centered in the given width, which is 40. By default, all this remaining width will be filled with empty space, but if we want to fill it with some other character, we can specify that. So we can say ss.center pass 40 and then fill the remaining spaces with, let's say, a star or asterisk. We can do that. So this is a string, and then the remaining space is filled with the character or element that is passed. Great. Let's save this in a variable called center. Now if we call center, we have, this is a string and a bunch of stars on the right and left. This will take us to the method strip. In the previous lecture, we have looked at the left strip and right strip methods. Now let's look at the strip method. So the strip method will remove all the characters or elements specified in the method. For instance, let's try to remove all these asterisks from our string center. So we say center dot strip, and we want to remove what? The character star asterisk. So if we do that and then run it, we get our clean string, which is, this is a string. So by default, if we don't pass any character here, we get, it removes empty white spaces. So let's create another string. Let's say ss is equal to a bunch of empty white spaces. This is another string. Then let's say some empty white spaces. So if we call our string ss, we have that, and then by calling the strip method, it will remove all the white spaces. Run it. Now we got a clean string. Next, let's look at the swap case method. So as the name indicates, this will return the opposite case. Basically, if the string is an uppercase, it will return a lowercase, and vice versa. Let's look at an example. Let's say we have a string ss, or we can just use the ss string that we created above, which is, this is another string. So we can call the swap case method on it, and in this case, all the uppercase characters are now lowercase, which is just the letter T, and all the other elements which are lowercase are now uppercase. Let's create another string and save it in a variable. Let's say upper, and then say all uppercase characters included. So now let's call the swap case method on our string upper. So upper dot swap case. Now all the characters will be lowercase. So that's how we can use the swap case method. Next, let's look at the split method. This method will split our string at the specified character. So let's say we have ss. Let's call our string upper. We have this. If we call the split method on our string object, that split, so it will split our string. By default, it will split it wherever there is an empty space. So that's the default split method. So let's run it. So here we get a list of many strings. So this is a list of strings containing all upper case characters and included. So the split method splits a given string wherever there is a space. So that's the default split method. And if there is no empty white space, it gives you the entire string. For instance, let's say we have a string ss. This is a string without any space. If we call the strip method on it, ss.strip, we get our entire string. Now let's create some other string. Let's say this is a string with a bunch of spaces. Next, let's try to split our string. So string.split. Oh, the method we just saw earlier, this should be split, not strip. split. Let's run it again. Okay, let's run it again. We get the entire string. Now let's use this string ss. So we have our string. If we split it now, we'll get a bunch of strings in a list. Now let's split it wherever the letter I appears and run it. So in this case, it will split it wherever the past character or element appears. So here I appears, so it splits th and then I, so it will skip that, and then the second string is s and then empty space, which is this, and then we have the splitter I, and then in the next string we have this substring, which is s space a space str, and it goes on like that. Similarly, we can split our string wherever, for instance, we can pass more than one character. We can split it, let's say is, so it will split our string wherever is appears. So we'll get th, and then we'll get another space, and then we'll get a big string containing this. Let's run it and show you. So we have th, an empty string, and then a longer string. So that's how we can use the split method. Either by itself, by default it splits wherever there is an empty white space, or we can pass a certain character so that it will split it at the given character. Next, let's look at the join method. So this join method will join a string to a given element or character. Let's say x is equal to star. So if we call x, we have a star, and let's create another element containing string, let's say ss. So this object ss, let's store 1, 2, and then 3. So this is a sequence of strings. What we'll do next is we'll join each of these elements to this element star. So we can say ss, we can join our star x that join, and then we can pass our sequence of strings ss, and that will join a star to our strings here. Similarly, we can say a plus sign that join SS and run it. So we get 1, 2, 3. Let's see one more example. We can say dash that join and then SS. We get 1, 2, 3. So this is the join method. Next, let's see how we can format a string using the dot format method. Let me show you an example. So I can say this is Python, and let's say empty curly braces. Then we call the dot format method, and then we pass, and we can simply say it is a great language. So what this will do is it will take the string after the format method. So it will take the string, it is a great language, and then place it in the curly braces here. So whatever we pass after the dot format method will be placed in the curly braces. So if we run this, we get this is Python and it's a great language. Similarly, we can say today is a great day. There we can put curly braces. Don't you think so? There another curly braces. It's a question mark, and then we can pass the dot format method. Then let's say John. So we get today is a great day, John. Don't you think so, John? This is a good way of formatting strings, both in Python 2 and 3. It works really well. You can say hi there, how's your day going? And then another, I am doing well, thanks. And then another curly braces, and then we can call the dot format method and pass whatever we want. Let's say hi there. So that will be placed in the first curly braces. Hi there, John, and then how's your day going? Let's say team. That will go in place of the second empty curly braces. Then we have I am doing well, thanks. Let's say John and team, for instance. So if we run it, we get hi there, John, how's your day going? So team is placed in the second curly braces. I am doing well, thanks. And then in the third curly braces, we get John and team. So that's print formatting in strings using the dot format method. To recap what we learned in this lecture, we looked at the print formatting in strings. We looked at how we can use the join method, the swap case method, and we also looked at the center method, the split method, and the strip methods. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the lecture on lists in Python. In this lecture, we'll learn about how we can create lists and then how we can access elements in a list. Let's start by defining lists and how to create them. A list is a sequence of values or elements, and we can simply create lists by enclosing elements in a rectangular bracket, and then elements in the list are separated by a comma. So 1, let's say 2, and so on. So each element in a list are separated by a comma. And one good thing about lists is that it can accept any data type. So let's create a simple list. Let's say a list containing the numbers 1, 2, 3, 4, and 5. So this is a simple list. The values are enclosed in a rectangular bracket, and the elements or items in the list are separated by a comma. And we can save our list, let's say in an object X. So that will be our list X. So if we call our list X, we get elements 1, 2, 3, 4, 5 in our list. So as I mentioned, the elements can be of different data types. In this example, it's integers, but our list can contain integers, strings, characters, or even other lists, or even a combination of this. For instance, let's create another list and store it in a variable XX, so it can have, let's say, item 1, item 2, and item 3. So that's another list. If we call our list XX, we have the elements item 1, item 2, item 3. Let's create another list and save it in a variable called XXX. Let's have a combination of integers. We can have characters, let's say X. We can have strings. Let's say string 2. Or we can even have another list. Let's say 1, 2, and 5. So you see this? This is a list. So it doesn't matter for the data type in our lists. So if we call our list XXX, those are the elements. So here in this case, this is one element. So this is an element containing a list of these three numbers, 1 to 5. But this is considered as one element. And each element is separated by a comma. So there is one function called the length function. To find out the length of a list, we simply say length and then pass our list. So in this case, let's pass our list XXX. So it has the element. The length is what? 1, 2, 3, 4, 5, 6, 7. So length of XXX, X is 7. Length of, let's see, the other list that we created is XX. So the length should be 3. And similarly, we can check the length of our single X. That should be 5. So if we run it, we get 5. So that's the simplest way to create a list, by enclosing the elements in a rectangular bracket and separating each element by a comma. There is another function called range, and this range function can be used to create a list. So we simply say range and then pass a number, let's say 9. So what this will do is create a list of numbers from 0 up to, let's say, if we say n, so this will create a list of numbers from 0 to n minus 1. Let's look at an example. So if I say range 4, this will create a list of numbers from 0 up to n, in this case is 4. So 4 minus 1 is 3. So 1, 2, 3. Let's run it and see. So if we run it, we get a list containing the elements 0, 1, 2, 3. So that's another way of creating a list. We can say range 12. It creates a list containing the elements 0 all the way through 11. We'll discuss more about the range function and we'll be using it a lot in the future, but I just wanted to quickly show you that we can use this range function to create a list. And similarly, we can save this in a variable. Let's say Xrange. We can do that. And then if we call our object or variable Xrange, we get a list containing the elements 0, 1, 2, 3. We can also do that. Okay, next, let's see how we can access elements in a list. Hello everybody and welcome back. In this lecture, we'll learn about accessing elements in a list or indexing. Let's call the list that we created in the previous lecture X. So we created that by simply saying or enclosing the values in a rectangular bracket and then saving it in a variable. Now let's see how we can access elements in my list X. So for accessing elements in a list, we use indexing. We simply pass the index of the element we want to obtain. So we have our list object X, and then we pass the element that we want to grab. We pass the index of the element we want to grab. Let's say we want to grab the element 3. So 3 here is at index 2, right? So this is index 1. This is index 0. This is index 1. And then this is index 2. So we simply pass 2. And we get the element 3. What if we want to get 5? We can simply say X and then pass the index of the element 5. Let's see. So this is index 0, 1, 2, 3, 4. So we simply pass 4. Another thing we could have done to grab the element 5 is use a negative indexing. So negative indexing starts from the int. If I say X at index -1, it means grab the last element. So that will grab 5. Okay. Let's create another list. XX. And then let's say it has the elements 2, 4, 6, 9, A. Let's say string and list. So if we call XX, we have that. And if we call the length function and then pass XX, we see that the length of our list is 7. Let's say we want to grab string. So one way to do it is to start indexing from here and then say this is index 0, 1, 2, 3, 4, 5. We can say XX at index 5. Or we could have said, we can use negative indexing and say index -2. So this is -1 and this will be index -2. And we get the same result. We can also obtain more than one element. We can get a slice of our list. For instance, let's say we want to grab the elements 6, 9 and the character A. So we can pass that as an index slice. So let's see here. This is index 0, this is 1, this is index 2. So index 2, 3, 4. that's what we want to grab. So xx2, so I'll pass 5. Remember, index slice from the beginning up to the end, but not including the end. That's how slicing works. So this will grab elements at index 2, at index 3, and at index 4. So that's how slicing works. Now if we run this, we get the elements 6, 9, and the character A. And let's say we want to grab all the elements to the right of 6. So we want to grab 6, 9, A, string, and list. How can we do that? So for that, we can simply say xx, and then index 2, and everything else. This means grab element at index 2, and all the elements after that. So if we run this, we get 6, 9, A, string, and list. Let's look at few more indexing methods. What if we want to grab all the elements? So we can pass double colons. So this means grab every single element in the list. What if we say xx, then double colon, and pass 2? This means grab every other element. So it will grab the first element, and then leave the second one, grab the next element, so every other element, which is 2, 6, A, and list. We could have passed, let's say, grab every fourth element. So in this case we get 2, and then the fourth element is A, and so on. So we can do that also. We can say xx double colon -1. This means grab every single element, but in the reverse order. So now we have list, string, A, 9, 6, 4, and 2. So that's about list slicing. What if we pass an index that's not in our list? So earlier we saw that length of our function xx is 7. So what if I say xx at index 9? We know that it doesn't have index 9. So if we try to do that, we'll get an error. We get a list index out of range error. So that's one thing to note. If the index doesn't exist, we get this index out of range error. Let's call our list xx. So we have the elements. We can use the delete statement to remove an element from our list. Let's say we want to delete the element 6 from our list xx. So we can simply say delete del space and then our list xx and the index of that element. So the index of 6 is 2, right? 0, 1, 2, and then simply pass 2. Run it. Now if you call our list xx, we see that it doesn't have 6 anymore. And if we want to remove the entire list, we can simply say delete and name of our list. So I don't want to delete this one. Let's delete the other list that we created, x. So again, we can delete elements at any index. Let's say x at index 3. So if we delete that, it will delete. So this is index 0, 1, 2, 3. So it will delete the element 4. Let's call x. So it doesn't have 4 anymore. Now we can delete our entire list by simply saying delete and then x. Now if we call x, we get an error. It says
name X is not defined because we don't have X anymore. So in this lecture, we looked at how we can access elements in a list by using indexing and index slicing, and we briefly saw how we could delete elements in a given list. And in the next lecture, we'll look at list operations. Thank you, everyone. Hello, everyone, and welcome back. In this lecture, we'll learn about list operations. Let's start by looking at concatenation. So we can concatenate one list to another. Let's say we have a list containing the elements 3, 4, and 5. So we can simply concatenate this to another list containing the elements 6, 7, 8, and 9. So we have a new list containing these elements. So that's concatenation. And to do concatenation, the list don't have to be of the same length. So for instance, I can concatenate a list containing these numbers to another list containing, let's say, some character alphabets, A, B, C, and they don't have to be of the same length, D. So we get that. We can save our list in some variable, let's say 4, 5, item 1, and then let's say another list containing the elements 2, 3. And from our previous lecture, we have a list containing these elements XX, so we can simply concatenate them by saying X plus XX, and we get a new list containing these elements. So 4, 5, item 1, and a list containing 2, 3 from our list object X, and the remaining elements are from our list object XX. That's concatenation. Next, let's look at multiplication or repetition. So we can simply say, let's call our list X. So we can multiply this by, let's say 2, and that will repeat the elements in X. So 4, 5, item 1, 2, 3, and now it's repeated again. If we have, let's say we have another list 2, 3, 4, item 2, and we can simply say our list times 4, and the elements will be repeated 4 times. So that's multiplication or repetition. Another operation we have is in. We can use the in to see if an element is in our list. So we'll get a Boolean result. Boolean means true or false. For instance, we can say 5 in a list containing 2, 3, and 5. So that will be true since 5 is in this list. Whereas if we say 4 in 2, 3, and 5, we get false. Similarly, we can save our list in some object, in some variable. So if we call our XX, we have this. We can simply say A in XX, and we get true since A is an element in our list XX. Similarly, we can say list in XX, we have true. Whereas if we say 3 in XX, we get false. So those are some of the list operations.
Great. And in the next lecture, we'll look at nested lists. Thank you, everyone. Hello, everyone, and welcome back. In this lecture, I want to quickly go over three functions: the length function, the minimum and maximum function or methods, and also about a property known as mutability. We have seen that string objects are immutable, meaning once we create an object, the elements in our string cannot be changed. That's called immutability. Whereas lists have a property. Lists are the opposite. That means once we create a list, we can change the elements in our list. For example, let's say we have a list containing the elements 2, 4, 6, and 8. So if we call our list object X, we have the elements 2, 4, 6, and 8. If I want to change the last element here, if I want to change 8 to, let's say, 12, we can do that. All we have to do is index our element. So 8 is at index 3, 0, 1, 2, 3. And we can set it to be equal to the new element that we want, 12 in this case. Now if we call our object X, our list X, we see that 12 is our new element. Similarly, if I have another list called X1, let's say it has the elements item 5, item 2, and 4. So if I call my list object X1, we have the following elements. And if I want to change the element item to some other element, I can simply index that element, index 0. Then we can set it to be equal to whatever we want, some other element. And then if I call my list X1, we have this as a new element. So list objects are mutable. Now let's look at the length function. The length function tells us how many elements are in our list. So length of X1 will be 4. And we can also do length of, then we can pass our list, let's say 3, 4, 5, 6, 7, 22, 33. We can do that also. So the length of our function, the length of our list is 7. Now let's look at the minimum and maximum method or functions. The minimum method tells us the smallest of the element in our list. So if I pass minimum of X, I get 2. Let's call our list X again. So our list contains the elements 2, 4, 6, and 12. And the maximum will give you the maximum element in the list. So maximum of our object X, we see that it's 12. So that's the maximum method. Okay, that's what I wanted to cover in this lecture. Thank you, everyone. Hello, everyone, and welcome back. In this lecture, we'll learn about nested lists. We'll be creating nested lists and see how we can access elements in nested lists. So let's create a couple of nested lists and we'll save them in a variable, let's say 1a, and I'll set that to be equal to, first of all, nested list means a list within a list. So when we have lists inside a list, we call them nested lists. So let's say we have a list 1a and has the elements 2, 4, and 6. Let's create 2 or 3 more lists. let's say list 1B, then let's say it has the elements 3, 7, and 9. Let's create one more list 1C, and it has the elements 12, 22, and 45. Let's add one more list 1D, and it has the elements 46, 34, and 11. So we have 4 lists here. Now what we'll do is we'll create another list and then use this as elements of our list. So let's say nested list, and then that will have this 4 lists. So we can say list 1A, list 1B, list 1C, and finally list 1D. So let's run that, and let's call the individual list elements. So if we call list objects, if we call our first list object list 1A, list 1A is not defined. Oh, I haven't run myself. Run this, and let's run list 1A. So list 1A has the elements 2, 4, 6. Similarly, if we call the other 3 lists, list 1B, we have 3, 7, 9, and so on. Now let's call our nested list So if we call our nested list object, we have a list containing these 4 lists. So that's one element, this is the second element, third element, and last element. So if we call the length function and then pass nested list, we see that it's of length 4. Good. Now let's see how we can access different elements in our list. Let's say we want to grab 4 from our nested list. How can we do that? So we use indexing for that. First we have to know where 4 is. So 4 is in the first list here. So this is index, this whole list is index 0. This is index 1, 2, and 3. So first we have to obtain this list. So we can simply say nested list at index 0. So that will give us this list. Remember, it's a single element. So we have 2, 4, 6. And then 4 here is at index 1. So this is index 0, this is index 1. So we can say 0 and then 1. So if we run this again, we get 4. So nested list, first the index of the list, and then the index within that list. Let's look at another example. Let's say we want to grab 45 here. How can we do it? So we can say nested list. So 45 here is first the index of the list. So 0, 1, 2, index 2. And within this list, 45 is at index 0, 1, 2, again at index 2. So we can simply say 2, and that will grab 45 for us. Another way to do this is, I think it's simpler, okay, to do it step by step. So first grab this list which is at index 2, so simply pass 2, so you have that, and then let's save this in a variable called nest1. If we call nest1, you get the same result, 12, 22 and 45. Now it's easier to index 45, right? Which is nest1 at index 2. So this is index 0, index 1, index 2. So nest1 at index 2 will give you 45. So you can do it by breaking it down into 2 steps. That could be simpler. Great. Next, let's create another nested list, and I'll save it in a variable called nested list 2, and I'll set it to be equal to my nested list, which is this. Then let's add 2 more elements. Let's say 26 and 29. So we can do that, and if we call our nested list 2 object, we get this. From here, let's say we want to grab 4. How can we do it? The first thing we have to do is grab this list, right? Grab this list. And if you notice here that if you call the length function and then pass nested list, the nested list 2 object that we created, you see that this list is of length 3. It looks like it could be, it looks like it has a bunch of elements, but the length is only 3. Well, that's the first thing you have to figure out. And if you see, this big nested list is 1 element, and then you have this element and then this. So to grab 4, we first have to grab the list within this big nested list. So to index that, so this long nested list is at index 0. Since it has 3 elements, this is index 0, 26 is at index 1, and this is at index 2. So let's grab index 0. So we can simply say nested list 2 at index 0 and run it. Now we have this. Here 4 is where? 4 is in this list here. So now my list here has 4 elements. 1, 2, 3, 4. And this is the first index, which is index 0. So we can pass 0 again, and that will give us 2, 4, and 6. From here it's much easier, right? So 4 here is at index 1. So that will give us 4. You see here, we're doing index, another index, sub-index, and so on. So that's how we can do it. Let's look at another example. Let's say we want to grab 11. How can we do it? Okay, we'll break it down into 3 steps to grab the index of this element 11. So first, same thing as we did. This is index 0. So let's grab that. We have our nested list 2 object at index 0. That will give us this. And if we save this, let's say in some variable xxx. Now let's call our xxx object. We have this. We want to grab 11. So our object xxx, if you call the length function on it, you see that it's of length 4. So let's grab this. which is at index 3. So index 0, 1, 2, and 3. So XXX at index 3 will give you this last list. Let's run it. Okay, we have that. So far so good. And let's save this in another variable called x. Now if we call x, we have 46, 34, and 11. So here to grab 11, it's easy, which is 11 is at index 2. So we simply pass x at index 2. And we get 11. So the indexes that we passed are 2 at the end, 3 before that, and then 0. So if we call our nested list 2 object and simply pass the individual indexes. So first we passed 0, in the second step we passed 3, and then 2. So 0, 0, and then index 3, and then index 2, 0, 3, 2. So that will give us 11. Great. That's what I wanted to cover in this lecture. So we saw what nested lists are, and we saw how we could grab individual elements from our nested lists. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome back. In this lecture we look at built-in list methods. Let's start by creating a list and save it in a variable called x. Let's say it has the elements 3, 4, 5, 6, and 7. So if we call our object x, we get a list containing the elements 3, 4, 5, 6, and 7. To see the list of available methods on our list object, we can simply say x dot and then hit tab on your keyboard, and you'll see a list of available methods. We'll look at each of this method one by one. Let's start by looking at the first method, append. So append will append. This method will append an object to your list. So the element will be added at the end. Let's say we want to append 8 to our list. So we can simply say x dot append, that's the method, and then we pass our element 8 and run it. Now if we call our list x, we have 3, 4, 5, 6, 7, and 8. And let's append another element, x dot append. You can say, let's say item. Now if we call our object x, we see that item is appended to our list. We can also save another list in a variable, let's say xx, and let's set that to be equal to 4, 5, and 6. We can also append this list containing these elements 4, 5, 6 to our list x by simply saying x dot append, and then we can pass this xx object. And now if we call x, we see that this list containing the elements 4, 5, and 6 is appended to our list x. So that's the append method. It appends an object to our list. Next, let's look at the extend method. Extend. This extend method appends the contents of some sequence. Okay, it's very similar to the append method, but this extend method, it appends the contents of some given sequence. Let's look at an example. Let's try to append. Let's create another list to make it easier. So I'll create another list and then save it in a variable called y. Let's say y has the elements 1, 2, and 3. So earlier we saw that we can use the append method and then add whatever we want to add. Let's say 4. And now if we call y, we get 1, 2, 3, 4. Now let's append a list containing the elements 5, 6, and 7. So in this case, this will be added as one element. This will be appended at the end as one element. That's the append method. We just saw that. So if we call y, we get, you see here, 5, 6, 7. The list containing 5, 6, 7 is added as one element. Now let's use the extend method. So extend, and then let's add 8, 9, and 10. So unlike the append method, this extend method will append these elements individually. So the content of this list will be appended individually. So let me run it and show you. So if I call y now, you see here we get 8, 9, and 10. So 3 elements are added. So the contents of each element here in my list is added individually. So all the sequence elements in our list are added one by one. So that's the extend method. Let's look at another example. Y dot extend. Let's say we want to extend 7, a list containing 7, 3, 5, and 2. So if we call y, we'll see that those individual elements in my list are added one by one. So that's the difference between append and extend. Next, let's look at the count method. So the count method will tell us how many times a given element occurs in our list. For instance, to see how many times this element 2 exists or occurs in our list, we can call the count method on our y object on our list y. So we can simply say y.count, C-O-U-N-T, and then pass 2. So here we see that 2 exists once here, twice here. So the result will be 2. 2 occurs in our list twice. So the count method gives us 2. How about 4? 4 only occurs once. So if we use the count method to get how many times 4 appears in our list, we get 1. What if the element doesn't exist in our list? For instance, y.count 36. So this will give us 0, since 36 doesn't appear in our list. So that's the count method. Next, let's look at the index method. So the index method will tell us the index of the specified element in our list. For instance, let's try to find out the index of this element 10. So we know that 10 is at index 0, 1, 2, 3, 4, 5, 6, 7. So y that index of the element 10, we get 7. So that's how we can use the index method. We call the index method on our list y or whatever list, and then we pass the element that we want to find. So let's say 3, pass 3, and it will give us the index of that element. Hello everyone, and welcome back. Let's continue our discussion of the built-in list methods. The next method we'll look at is the pop method. The pop method removes the last element in our list. Let's look at an example. Let's say we have a list containing the elements 1, 5, 6, and 9. Now if we call the pop method on our list X, that will remove the element 9 from our list. So the last element or item in the list. So x.pop is 9. If we call X, we have 1, 4, and 6. If we call the pop method on it again, we get 1 and 4. So 6 will be removed. And if we call our list X, we get 1 and 4. So it removes the last element added, or the last element in our list. We can also specify an index with the pop method to remove any element in our index, in our list. Let's say we have another list containing the elements 4, 5, 6, item, another item, item 1, let's say 9, item 3. Then let's have a list containing the elements 1, 2, 3, and then 8. So if we call that's X, if we call the pop method on X, it will remove the last element, which is 8. So if we call X again, we see that 8 is removed. If let's say we want to remove 6 from our list, we can, using the pop method, we can also say x.pop and pass the index of the element we want to remove. In this case, 6 is at index 2, 0, 1, 2. So x.pop and then pass 2. So 6 is removed. If we call our object X, we see that 6 is removed. So this brings us to another method known as the remove method. So this method will remove the given element from our list. So it's similar to the pop method, but with the remove method we have to specify the element we want to remove. Let's say in the above example we want to remove 9. So we can simply say x.remove and then pass the element that we want to remove, which is 9. Now if we call X, we see that 9 is no longer in our list. And if we want to remove, let's say, this item, we can simply say x.remove and then pass our element, which is item. Now if we call X, we see that item is no longer there. So that's the difference between remove and pop. Remove and pop. Next, let's look at the sort method. So the sort method will sort the elements of our list, either alphabetically or numerically. So it sorts it. Let's look at an example. Let's say we have a list Y containing the elements 2, 6, 3, 6, 2, 1, 9, 8, 4, 3, 4, and 12. So if we call the sort method on our list Y, we see that the elements in our list Y will be sorted in an ascending fashion, from the smallest to the largest. So if we call Y, we see that it's sorted 1, 2, 3, 3, 4, 6, 8, 9, 12. Similarly, we can call the sort method on lists containing strings. Let's say we have another list called A containing the elements, let's say item, C, W, I, K, and V. Let's call the sort method on it. Now if you call our list A, so we get the items C, I, K, V, W. So it's sorted alphabetically. This takes us to another method known as the reverse method. This method simply reverses the order of elements in a given list. So here, if we call list A again, that's the order C, I, item, K, V, and W. If we call the reverse method, it will reverse the order of these elements. So basically we'll see W first, followed by V, K, and so on. Let's run it. And if we call A again, we see that the order is in reverse or reversed. Let's create another list X containing the elements 4, 5, 7, 2, 1, 8. So if we call the reverse method X dot reverse, we'll see that the order of the elements is reversed. So now we have 8, 1, 2, and so on. So 8, 1, 2, the reverse order. Great. Next, let's look at the insert method. Insert method inserts an element or object at a specified index. So this is similar to the append and extend method in a sense that it adds elements or an object to our list. Let's look at an example. So if we call our list X, we have the elements 8, 1, 2, 7, 5, 4. Let's say we want to add an element at index 2. So here we have 2 at index 2, right? This is index 0, index 1, index 2. So let's say we want to add another element at index 2. For that, we'll use the insert method. So we can simply say X dot insert, and then we specify the index. So I want to add an element at index 2, and then whatever element we want to add. Let's say this will be added at index 2. So if we run this and then call X, we see that my new element, this long string, is added at index 2. Let's say I want to add another element at index 5. So I can simply say X.insert at index 5. You can simply say insert at index 5 or whatever. So if we call x again, we see that this element is added at index 5. Let's count 0, 1, 2, 3, 4, and 5. Similarly, you can say x dot insert at index 0. Let's add what? 4, for example. Run it. If you call x again, we see that 4 is added at index 0. Finally, I want to quickly mention about a method called compare. This method will compare elements in two lists and then gives you a result of either -1, 1, or 0. Let me quickly show you this example, this method. So let's say compare list containing the elements 1, 2 with another list containing the elements 2 and 3. In this case, the second list is what it does is it compares each individual element in each of the lists. So in this case, we'll get a result of -1. That's because this first list is less than the second list. That's what this -1 means. And if they are equal, let's say 1 here and 2, we get a result of +1. This means the first list is greater than the second list. Whereas, let me change this to 1. In this case, we'll get a result of 1. That just means that the first list we are comparing is greater than the second list. And if the elements are not of the same type, we get numbers are usually smaller. So if I am comparing a list containing the elements 1, 2 to a list containing, let's say, A and B, we get -1. Usually, numbers are smaller compared to other data types. And if we are comparing alphabets, let's say list containing some alphabets, let's say A and C, and another alphabet containing another list containing the alphabets A and let's say bat, we'll get +1. That just means the first list is greater than the second list. So here A and A are equal. So here C is greater than B. So I just wanted to quickly show you this compare method. So to summarize, we looked at the remaining built-in list methods and saw an example for each. Thank you everyone, and see you at the next lecture. Hello everyone, and welcome to the lecture on tuples in Python. A tuple is a sequence of elements, and tuples are very similar to lists. The only difference is we create tuples by enclosing elements in this parenthesis. So in the previous lecture, we saw that we create lists by including elements in this rectangular brackets, whereas tuples are created by including the elements in parentheses. So this is an example of a tuple. Say 1, 2, 3, 4, 5. So that's a tuple containing the elements 1, 2, 3, 4, and 5. And we can save this tuple in a variable. Let's say tuple xx. And if we call our tuple xx object, we get a tuple containing the elements 1, 2, 3, 4, 5. And similar to lists, tuples can contain integers, floating numbers, strings, characters, different data types. So those are supported in tuples also. For instance, we can create a tuple containing characters A and B and C. That's valid. We can create another tuple containing the elements 1, 2, 3, and then let's say A, B, and C. That's also valid. We can also create a tuple containing integers and floating numbers. Let's say 1.2, 3.4, 3.4, 5.08, time, item, or even a list containing the elements, let's say 2, 3, 4, or even another tuple containing, let's say, the elements 1, 2, and 3. So all those data types are supported while creating tuples. So that's the same as lists. They support various data types. And to find out the length of our tuple object, we simply use the length function and then pass our tuple object. For instance, if we want to find out the length of this tuple xx, we simply say length and then pass xx, we'll get 3. Similarly, if we want to find out the length of this tuple yy, that should give us 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is one element, this is one element. As you see here, we create tuples by separating each element by a comma. So length of yy, we get 9. And similar to lists, we can also index our tuple objects. For instance, if we want to find out what element exists at index 5, we can simply say our tuple at index 5. We get a list containing the elements 2, 3, 4. What if we say yy at index -1? That should give us the last element, which is B, negative indexing. Whereas if we do yy at index 9, we get an error, similar to lists, tuple index out of range. Unlike tuples, unlike lists, tuples are immutable. Remember the property immutability? Once we create a tuple, we cannot change or alter the contents of our tuple. So last time we have seen that, let's say we have a list 2 containing the elements 2, 3, 4, and 5. If I want to change this element 5 to some other element, we can do that in lists. All we have to do is index that element. In this case, 5 is at index 3, and set it to be equal to some other element. Now if we call our list2 object, we see that we have our new element, but this is not supported in tuples. Tuples are immutable. So if I have a tuple object, let's say tuple 1 is equal to 2, 3, 4, and 5. If I try to do the same thing, I will get an error. That's because tuples are immutable. So if I want to change this element 5, which is at index 3, to some other element, let's say 22, I'll get an error. So tuple does not support item assignment. Okay, so tuples are immutable. That's very important to remember.
Hello everyone and welcome back. In this lecture we look at tuple operations. In the previous lecture we learned how to create tuples. So we can create tuples by enclosing elements in parentheses and separating the elements by a comma. And tuples can hold different data types. We saw that in the previous lecture. And we can find out the length of our tuple by using the length function. And we also saw that tuples are immutable. So if we try to change the elements in our tuple to a new element, we get an error. That's because tuples are immutable. We get that error. So let's continue with our tuple operations lecture. So similar to strings and lists, we can do concatenation on our tuple. For instance, we can concatenate a tuple containing the elements 147 plus with another tuple containing the elements 49 and 8. So we get a new tuple containing those elements. You see, these elements are concatenated or added to our tuple. So if we call our tuple x, it has those elements. We can say x plus, let's say 4, item 4, and a list containing 3, 4, and 5. So we see that these elements are concatenated for item 4, and this element containing a list are all concatenated to our tuple x. We can also say x plus x. So those are concatenation. Next, let's look at repetition or multiplication. So we can say, let's see, our tuple 1, 2, 3 times 2, we get 1, 2, 3, 1, 2, 3. Our tuple containing the elements 1, 2, 3, 4, we can say times 4. So our tuple is multiplied by 4. So it's repeated 4 times, 1, 2, 3, and 4. So that's repetition in tuples. We can say x times 5. So all the elements will be repeated 5 times. So that's the first time, second, third, fourth, and fifth. That's tuple repetition. We can also check if elements are in our tuple by using this in. For instance, we can say 2 in the tuple 2, 3, 4, and 5. So this will give us a Boolean result, either true or false. In this case, we will get true since 2 is in our tuple 2, 3, 4, 5. Similarly, if we say 9 in tuple 5, 6, 7, we get false since 9 is not in our tuple. If you say 2 in x, we get false. Let's see our tuple x. It has the elements 3, 4, 5, test, and item. We can say test in x. That should be true since we have that element, that string element in our tuple x. And in the previous lecture, we have seen that we can index our tuple. So let's call x again. We have seen that we can index x at index, let's say -2. That will give us test. Negative indexing starts from the int. We can also say x : : that will list out all the elements in our tuple. Similarly, we can say x colon colon 2. That means grab every other element in our tuple. So that will give us the first element and then every other element. We can also do slicing. So let's say grab every element up to index, let's say 3. So that should grab elements at index 0. So this should grab elements at index 0, 1, and 2. So that's what this means, up to index 3. So if we run this, we get 3, 4, 5, which are elements at index 0, 1, and 2. We can also do x, grab everything from index 1 up to index 4. What does this mean? This means grab elements at index 1, 2, and 3. Run it. So 1, 2, and 3. The last thing I want to cover is deleting our tuple. Last time we saw that we could delete specific elements in our list object. So if I have, for instance, we can delete 2 from our, let's say, list. If our list has the elements 2, 3, and 4, we can specify the index of 2 and then delete only 2. Let me show you an example. So let's say we have a list containing the elements 3, 4, and 5. If I want to delete 3, I can simply say delete x at index. So 3 is at index 0. We can do that. If we call x, we get the elements 4 and 5. But that's not allowed in tuples. So if I have a tuple containing the elements 3, 4, 5, and 6, I cannot do delete. Tuples are immutable again. We cannot delete delete my tuple x at index, let's say 1. We cannot do that. We get an error. Tuple object does not support item deletion. But we can delete the entire tuple. We can delete the entire tuple by just saying delete and then our tuple x. We can do that. So now if we call our tuple x, we'll get an error. Name x is not defined because we have deleted our tuple x. Great. In the next lecture, we'll look at some built-in tuple methods. Thank you, everyone. Hello, everyone, and welcome back. In this lecture, we'll look at built-in tuple methods. Let's create a simple tuple. X containing the elements 1, 2, 3, 4. So if I say x dot, and then if you hit tab, you'll see a list of methods. And for tuples, we don't have a lot. We only have the count and index methods. So we look at those two methods, count and index. Count and index. And before we look at those two methods, I wanted to quickly show you the length method, the minimum, the maximum, and then the compare methods. Let's start by looking at the length method. So as you know, this will tell us the length of our tuple object. So if I say length of x, that will give me 4, since I have 4 elements in my tuple. Similarly, if we have another tuple containing the elements, let's say 1, 2, 3, item 1, let's say a list containing the elements 2, 3, 4, a tuple containing the elements, let's say 2, 5, and 6, and so on. If we call our tuple x, we see that it has 1, 2, 3, 4, 5,
6, 7 elements. So we can simply say length of x, and that will give us 7. Next, let's look at the minimum method. So that will give us the element with the minimal value in our tuple. So if we have a tuple t, let's say it has the elements a, c, and then v, and let's say the number 9. So usually numbers have the smallest value. So if I say minimum of my tuple t, I will get 9. Okay, whereas the max method will give us the element with the maximum value. So if I call the max method on our tuple t, that will give us this character v. So that's the minimum and maximum methods, and that takes us to the compare method. So this will compare two tuples, tuple 1 and tuple 2. So if our tuple objects are both numbers, the comparison is easier. So it will compare, let's say we have tuple 1 contains the elements 2, 3, 5, or 3, 4, 5, and then if we have another tuple xx, let's say this has the elements 4, 5, and 6. So we can call the compare method on it. So cmp compare, and then compare tuple 1, which is x, and tuple 2 xx. So if tuple 1 is greater than tuple 2, we get a value of 1. If they are equal, we get a value of 0. And if the first tuple is less than the second tuple, we'll get negative 1. In this case, our first tuple x is less than the second tuple, so we'll get negative 1. We get negative 1. If they are equal, for instance, if I change this to 4, 5, and 6, now both tuples are equal. So if I do a compare method, I get 0, meaning they are equal. And let's say instead of a, 5, and 6, if we use a character a here, we know that the first tuple x is greater than the second tuple xx. So our compare method will give us positive 1. Great. Next, let's see the count and index method. So the count method will tell us how many times the element appears in our tuple. For instance, let's say we have a tuple t1. Let's say it has the elements 2, 3, 4, 5, 6, 0. Let's say 4, 4, 5, 3, a, c, item, and 1. So our tuple 1 has all these items, and if I want to find out how many times 4 appears in my tuple, we can call the count method on our tuple 1 object, that count, and then pass the element 4 in this case. So I get 3. That means 4 appears 3 times in my tuple t1. And if we want to find out how many times the element, let's say 5 appears in our tuple, we simply pass 5 and we get 2. If the element doesn't appear in our tuple, we get a 0.
for instance, if we say t1 that count and then pass, let's say b, we get 0 because b doesn't exist in our tuple t1. Another way of checking this is if we say b in t1, that should give us false, right? So that's the count method. And finally, let's look at the index method. So the index method will tell us the index of our element. For instance, t1, if I want to find out the index of this item in our tuple, we simply say t1 that index and then pass our element, item in this case, and that will give us the index of the element item, which is 12. Similarly, if I want to find out the index of the element c, we simply say t1 that index and then pass the index of the element, which is c, and we get 11. So those are the tuple methods that we have. Thank you everyone, and see you at the next lecture. Hello everyone, and welcome to the lecture on dictionaries in Python. Dictionaries are an ordered set of key and value pairs. We create dictionaries by using curly braces, and they contain key and value combination, and we separate the key from the value by using a colon, and we separate one key value combination from another by using a comma. Let's create a simple dictionary. Let's say it has key1 colon, and the value will be, let's say, value 1. Then let's have another key and value combo, so key2 colon value 2. So this is an example of a dictionary. We enclose the key and value combination in a curly brace, and we have our key colon value. We use a colon, key and value, and we separate one key and value combination from another by using a comma. And if we want to add more key and value combinations, we can do that. So key 3 and then value 3. And we can save this dictionary in a variable, any variable that you want. Let's say dictionary new is equal to this, and we can call our dictionary object, let's say dictionary new, and we have our dictionary key 1 and value 1, key 2 value 2, and key 3 and value 3. And once we have a dictionary, we look at the values by using the keys. So we can only access these values by referring or by looking up the keys. For instance, if I want to find out this value for my key 1, all I have to say is I have my dictionary object, and then we'll index the first key, key 1. So that will give me value 1. That will give us the value. Similarly, if I want to find out the value for our key 3, we can simply say our dictionary object and then index key 3, and that will give us the value 3. So here we used strings for both key and value, but our values can be of any data type. They can be integers, strings, or even lists, tuples, anything. They can be of any data type. However, there is more restriction on our keys. Our keys can mainly be either integers or strings, or a few more data types, but they cannot be of any data type. There is more restriction on our key. So we have to remember that. Let's create another dictionary object. Let's say for our first key, we'll just say 1. And for our first value, let's say 23. For our second key, let's say 2. And for our value, we'll use a string. Let's call it string value. For our third key and value combo, let's say name, and for value we'll pass a list of names. Let's say Joe, Jane, and Smith. Let's add one more key and value combination. Let's say key4, and for value let's use a list containing, let's say, person, 5, 8, 13. Okay, that should be good. And let's save this in a variable called mixed dictionary for mixed data type for our keys and values. And similar to the other data types, there we can use the length function on our dictionary. So in this case, the length will be, so key and value pair will be one length. So this will be a length of 4. And if we call our mixed dictionary object, and if we want to find out the value for our value for our key 3, so this is the third key, right? We can say our dictionary object mixed dictionary, then we index the key. Remember, we can only access the values from the key, so we index the key, and that will give us the value. So in this case, the value is a list containing 3 name strings: Joe, Jane, and Smith. We can further access any of the strings by indexing it. So this will be index 0, 1, and 2. So if I want to access Smith, all I have to do is further index it. So name and then pass index 2. Run it. So we have Smith. We can also take this further. You see the result is a string, and we can say type, we can pass the type on our object, and we'll see that it's a string. So all the methods that apply on a string, we can use it. Okay. So if we run it again, we have Smith, and we can use methods that we can apply on strings. For instance, we can change this to, we can check if our string is upper or lower, and so on. We can do that. Similarly, if we want to access Joe, all we have to do is pass the index 0. So that's how we can do it. And if I want to index, if I want to find out the values for key 4, all we have to do is we have our dictionary object and then pass the index, pass the key as an index. So in this case it's key 4, and that will give us a list containing these values. We can take this further, and then if we want to find out the value 8, we can pass its index. So 8 is at index 2. So at index 2, and that will give us 8. So this is an integer. If we want to find out the type of this object, it's an integer, and methods that we can apply on integers, we can use it. For instance, we can add numbers to it. Let's say we can add +5 or 8, 16, and so on. Right? Same as what we did here. So when we create dictionaries, we have key and value combinations, and usually we cannot have duplicate keys. If you have duplicate keys, only the last key and value combination will be used. So for instance, if I create another dictionary and let's duplicate one of the keys, let's say let's duplicate key 1 and give it a different value. Let's say value 4. In this case, you see here we have duplicated the key 1 here, and then we have the same key 1 here. So if we have duplicate keys, only the last key and value combination will be used. Okay, so if I say dictionary new and then key 1, so the value I get will be value 4, not value 1. Value 4. So that's important to remember. And another thing about dictionaries is that if we assign a new value to our key, so the latest value will be used. For instance, here I have key 1, value 1, right? So if I call dictionary new now, I have key 1 value now, value 1. If I change this value to a different value, let's say value 8, and call my dictionary object, key 1 will have our new value, which is value 8. Great. So this is a general introduction to dictionaries, and in the next lecture we'll continue looking at dictionaries and some of the methods that dictionaries have. Thank you, everyone. Hello everyone, and welcome back. In the last lecture we looked at how we could create dictionaries. In this lecture we'll continue with our discussion on dictionaries, and we'll see some methods that we can use on dictionaries. Let's start by creating a dictionary and save it in a variable called person. So we'll pass a key and value combination for our dictionary. Let's say for our first key we can say name and colon for its value. Let's see, Jane. For our second key and value combination, we'll use age for our key 2, and for our value 2, let's say 43. And then for our third key and value combination, let's use state, and then value, let's say New York. So here, key and value combination separated by colon, and then one key and value combination is separated from another by a comma. So let's run it, and we can find out the length of our dictionary by calling the length method. So our dictionary is of length 3. We can add values. We can add key and value combination to our dictionary by one of the following two ways. One is by using the update method. So we call our dictionary object, which is person in this case, and then dot update. And then we pass a dictionary key and value combination. For instance, we can say, let's see, department for our key, and for our value, let's say IT. So person.update, department will be key and value will be IT. So all enclosed in a bracket, in curly braces. Run it. And now if we call our person dictionary, we see that a department and IT key and value combination is added. Remember, dictionaries do not retain the order in which items are added. Dictionaries contain an unordered list of elements, right? Even if we added department and IT at the end, the order is not followed. So this is one way. We can add more key and value combinations by using the same method. For instance, we can say, let's see, 6 for our key, and value we can say, we can pass a list. Let's say a list containing 3, 4, and 5, for instance. So dictionary keys can be of any type. They can be of string, integers, tuples, lists, and so on. Now if we call our person object, we see that a new key and value combination is added. Now let me show you the second way of adding key and values or elements to our dictionary. We can say, so we have our person dictionary object, and then we can pass our new key as an index. For instance, let's call it key 6, and then for value we can say equal to, and then pass our new value, let's say value 6. So this is another way of adding members to our dictionary. Now if I call our dictionary person, we see that key 6 and value 6 are added. Similarly, we can add more key and value combinations. Let's say key 7, person, and then we index our key. We pass it as an index, and then we set it to be, for our value, we set it to be equal to the value. Let's say 7 and then 7. Run it. Now if we call our dictionary object, here we see the new value is added. We can also use this method to update the value for our key. For instance, if I want to change the age, the value for our age, what we can do is we can say person and then pass the value as an index. So we'll be indexing our key, which is age. And then for value, remember that's how we can access dictionary keys. We cannot directly access keys. So person, we are indexing the age, which is the key. We cannot access the values directly, sorry. Person, we index the key, and for values, so instead of 43, we can make this 44, for instance. Run it. Now if we call our persons dictionary, we see that age is 44. That's how we can change any of the values for our dictionary, how we can update it. For instance,
let's change the state to some other state. Let's say Jane moved to New Jersey. So we can say person, and then key is state. Then for value, we can say New Jersey or something. Now, if we call our persons dictionary, we see that New Jersey is the new value for the state key. Next, let's see some built-in methods for our dictionaries, built-in functions or methods for our dictionary. So here we have our persons dictionary. So if you say person dot and then hit tab on your keyboard, you'll see a list of built-in methods on dictionaries. Okay, these are the methods that we have for dictionaries. Let's see some of those methods. One method is called values. So this method will list out all the values for our dictionary. So in this case, this is one value, and then 7, 44, IT, and so on. So person.values, and if you run it, you'll get a list of all the values, right? Jane, a list containing 3, 4, 5, 7, 44, and so on. Similarly, we have a method to a built-in function or method to list out all the keys for our dictionaries. The method is called keys. So we call the keys method on our dictionary object. Now if we run this, this gives us a list of all the keys of our dictionary. So 6, 7, age, department, and so on. And there's another method called items. And this method will list out all our keys and values. You see here, we get a list of all our keys and values as tuples. Person.items. So it gives us a list containing all our key and values as tuples. Great. Next, let's create an empty Python dictionary and fill it with some values, keys and value combinations. So to make an empty dictionary, we simply use curly braces. So that's an empty dictionary. So this is an empty dictionary. And we can save this in a variable. Let's call it dictionary1, and we can set it to just an empty dictionary. So this is an empty dictionary, and if we check the type of dictionary1, so let's say type our dictionary1 object, we see that it's a dictionary object, and we can use one of the previous methods that I showed you to add key and value to our dictionary object. So we can say dictionary1, let's say key1 equal to value1, run it, and then let's add one more key and value combination. Dictionary1 key2 is equal to value2. Now if we call our dictionary1 object, we see that we have two pairs of key and value combination. Let's add two more items to our dictionary. Dictionary1, let's say key3, and we'll set it to be equal to value3. Let's add one more item, dictionary1 key4, we'll set it to be equal to value4.
Now our dictionary is of length 4. So we have 4 pairs of key and value combination. And let me show you one method. It's called the pop method. So to use the pop method, we call our dictionary object. We call the pop method on our dictionary object. And this pop method will remove the key and value from our dictionary. So if I want to remove, let's say, this key and value combination from our dictionary, we can call the pop method on our dictionary object and pass the key. So in this case, key 2. So dictionary1.pop, and then pass the key of the combination we want to delete. Run it. So this is now value 2 is deleted. So if we call our dictionary1 object, we will not see key 2 value 2 combination. So we only have key 1, 3, and 4, and its associated values. Another method to delete a key and value combination is by using the delete method, the del method. So we can say delete del space our dictionary object, and then we pass the key that we want to delete as an index. Let's delete key 4, for instance. So delete space our dictionary object, and then we pass the key we want to delete as an index. So run it. Now if we call our dictionary1 object, we will not have key 4 and value 4. So let's call our dictionary1 object. So we only have key 1 and key 3. Great. This is what I have for this lecture. Just to summarize, we looked at how we can update or add key and value combinations to our dictionary by using 2 methods. One is the update method, the other one is by calling our dictionary object, then passing the key value as an index and setting the value like this. The other one was using the update method. And we also saw a few built-in methods in dictionaries, like the keys methods, the values methods, the items method, and we also saw how we could update dictionary values and how we can delete a specific key and value from our dictionary using the pop and delete method. In the next lecture, we'll see some more built-in dictionary functions. Thank you, everyone. Hello, everyone, and welcome back. In this lecture, we'll look at some more dictionary built-in functions. In the previous lecture, we looked at the keys, values, and items built-in methods mainly. Let's start by creating a dictionary object, and we'll save it in a variable called dictionary1. Dictionary1, let's set it to be equal to, and then let's pass key and value combinations. So let's say key 1, and for our value we'll pass the integer 456. So key 2, and for value 2 we'll pass a list containing the numbers, let's say 3, 9, and 15. For our third key and value combination, we'll use key 3 as our key, and for our value we'll pass a tuple containing the numbers 4, 8, and 23. Or let me include the parentheses. And for our fourth key and value combination, let's use key 4 as our key, and for our value we'll pass a list containing a few items. Let's say item 1, item 2, and item 3. If we want to find out the value for our key 2, we can simply say dictionary 1 and then pass the key as an index, key 2 in this instance, and we'll get our value 2, which is a list containing 3, 9, and 15. And we can even use one additional level of indexing to access these values in a list. Since this is a list, indexing is possible, right? That's because if we use the type method on our dictionary 1 key 2 object here, we'll see that it's a list, so we can use indexing. Another way we can do this is by saving this value, dictionary 1 index key 2. We can save this in a variable, let's say x. Now if we call x, we get a list. We can also call the type function on our object x, and we see that the type of object x is a list. So we can either say x and then at index, so the result is what? 3, 9, 15. If we want to grab 15, we can simply pass the index to 0, 1, 2. That would give us 15. And now this is an integer, right? So if we check the type here, it's an integer. Let's run it. It's an integer. So we can perform various operations on integers, right? So we can say this plus 35, and that should give us 50. So we can perform operations on integers, similar to what we did here on lists. Similarly, if I want to access any of these items, first I have to grab the value for key 4, which I can do by simply saying dictionary 1 and then index key 4, and that gives us a list containing these items. Now we can further, let's save this in a variable called x, and now we can index x. Since it's a list, let's pass index 1. That should grab item 2. We get the string item 2. If we check the type, we should see that it's a string. So this is a string, so we can perform operations on a string, right? So x at index 1, that's an item 2, that's a string. So we can perform operations that we do on strings, right? For instance, we can check if it's upper, but we can call the isUpper method, and that should give us false since it's not upper. And we can use other string functions. Great. In the previous lecture, we saw methods to get a list of all the keys called the keys method. We can call the keys method on our dictionary 1 object, and that gives us a list of all the keys. Now let's see, there's a similar method called viewKeys. Let's call the viewKeys method on our dictionary object, and we get dictionary keys. So what's the difference between the keys method and the viewKeys method? The difference is the type of this method. So the keys method gives you a list, the result is a list, whereas the viewKeys method gives you a dictionary object.
So you can do that by checking the type. For instance, let's save this in a variable called x, and let's save this in a variable called y. Let me run both of them, and let's check the type of x, which will give us a list, whereas if we check the type of y, we get a dictionary key object. So that's the difference. We get a list versus a dictionary keys object. Similarly, we have other methods called view items and view values. Let's look at those methods. So dictionary one, that last time we saw the values method, and this will give us a list of all our values, right? These are all our values, and similar to the values method, there is a view values method that will give us a dictionary values object. Okay, a dictionary values containing all the values. And the last method we saw last time was the items method, and that gives us a list containing a tuple of our key and value combinations. And we have a similar method called view items. Okay, and we get a dictionary items object. If we check the type of this object, we see that it's a dictionary items object. Next, I will show you three methods called, they start, both of all the three methods start with iter. They are called iter keys, iter values, and iter items. They are used to iterate over, for instance, let's start with iter keys. So by using this iter keys method, we'll be able to iterate through all of the keys of our dictionary. And we use these methods in combination with for loops. We'll learn about for loops in depth in the future, but I wanted to quickly show you how we can use these methods. So the way we use them is by using for loops. So we can say for our keys in our dictionary one object that iter keys, we can print key. So this is the general syntax for loops. For a certain item in some object, print that item. So don't worry about this for loops. I just wanted to quickly show you the iter methods that we have on dictionaries. So in this case, we said for key in dictionary one that iter keys print key. So this will print out all the keys in our dictionary one object. Let me run it and show you. So we get key 3, key 2, key 1, and key 4. So this is the use of a for loop. A for loop goes through an object, an iterable object, and then it prints out each of the items one at a time until everything is printed out. Okay. Similarly, we have a method called iter values that will print out all the values. So let's see that quickly. You can say for value in dictionary one that iter values, let's print value. So the most important thing about for loops is that you see here I used key and then I said print key. This statement can be, I can use any
anything for this. Instead of key, I could have said for, let's say, W in our dictionary that iter keys print W. So it can be anything, but it has to be the same where I have it here and in the print statement. So here I said for value in our dictionary 1 that iter values print value. So I use this word value because it makes more sense, as this method, this for loop, will be printing all the values. So if I print it, we get all the values, right? This is one value, another value, 456 is another value, and a list containing these items is our last value. So we could have gotten the same result if we said, let's say, instead of value, I can say anything. Let's say for X in our dictionary that iter values print X. As long as it's similar, it can be anything. So X, it can even be, let's say, A, B, C, D, E, A, B, C, D, E. It could be anything that you want. Again, the reason why I used value is because it makes a little bit more sense since we are printing values. And same thing here. Since we are printing keys, I used the word key, but it could have been anything. Okay, next, let's see the last method, which is the iter items method. So similar to this items method, the iter items method will print out the key and value combination. So for that, we can say for, let's say, key and value in our dictionary 1 that iter items. So this method prints out both the keys and values as a tuple, right? That's why we are saying for key and value. So print key and value. Let's run it. So we have key 3 and then its value, key 2 and its corresponding value, key 1 and its value, key 4 and its corresponding value. Okay, if we want a tuple, we can enclose this in parentheses, run it again, so we get a tuple of the key and value combination. So this is how we can use the iter values, iter items, and iter keys methods. We use them with for loops. Basically, the methods iterate over the entire dictionary, and by using for loop, it prints out each of the items one at a time. Okay, at this point, don't worry about for loops, what they do and so on. I just wanted to quickly show you these methods, and they are used in combination with for loops. There is an entire section on for loops. Okay, that's what I have for dictionary built-in methods. Just to summarize what we learned in this section, we started by defining dictionaries. We said that dictionaries contain an unordered list of objects with key and value pairs, and we create dictionaries by using curly braces, and we separate a key from its value by a colon, and we separate one key value combination from another by using a comma, and we access the value of our dictionary by indexing the key, right? We said that we cannot have duplicate keys for our dictionary, otherwise the last value will only be remembered, and dictionary values can be of any data type like integers, lists, tuples, and so on. But there is a bit more restriction on dictionary keys. Okay, and later we saw how we could grab values for our values from the keys. We saw how we could update our dictionaries. We saw how we could grab our dictionary keys or values by using the keys methods and values methods, and we also looked at some other built-in dictionary methods like the view keys, the pop method, the delete method, and so on. And finally, I touched upon the iter keys, iter values, and iter items built-in dictionary methods that we can use in conjunction with for loops. Great. Thank you, everyone, and I'll see you at the next lecture. Hey, everyone, and welcome to the lecture on sets in Python. A set consists of an ordered collection of elements, and these elements are enclosed in curly braces. Each element in our set are separated by a comma. We create sets by using the built-in function known as set. For instance, we can create an empty set by simply using the set method. And if we save this in a variable called x, now if we call x, we have a set. This is an empty set. And we can add values by using the add method. So we can add values one at a time. You can say x.add, let's say 3. If we run it, and then if we call x now, our x is a set containing the element 3. We can add another item, x.add, let's say 2. Now if we call our x, we see that it contains the elements 2 and 3. Similarly, we can create sets from a list. For that, we simply pass our list to the set built-in function. So we have our set, and then we pass our list. Let's say 3, 4, 5, 6, and 7. And let's save this in a variable called y. Now, if we call our object y, we see that y is a set containing the elements 3, 4, 5, 6, and 7. Similarly, we can create another set from a list of some strings. Let's say item 1, item 2, and item 3, item 3. If we call our object a, we see that it's a set containing the 3 items 1, 2, and 3. We can add items to it. We can add elements to it by using the add method, and then we pass, let's say, another item, item 4. Now if we call a, we see that a new item is added. We can also pass tuples to create a set. Let's see an example. Let's say tup set is equal to set, and then we pass a tuple containing the elements a, b, and c. Run it, and then if we call our tuple set object, we see that it's a set containing the elements a, b, and c. We can also create sets by using the range function. For instance, we can say set, then range, let's see, 3 to 20, and we can save this in a variable called, let's say, I. And if we call I, we see that I is a set containing numbers 3 to 19. We can also specify step sizes. For instance, let's say
in step sizes of 3. If we run it again, we see that I is a set containing the elements 3 to 18 in step sizes of 3. We can also save our items in a variable. Let's say var1, and let's set it to be equal to a list containing A, C, K, V, 1, 2, 3, 4, 5. Then we can create a set by passing our variable object var1, and let's save this in some variable called set2. Now if we call our set2 object, we see that set2 is a set containing the elements 1 through 5 and the characters A, C, K, and V. Hello everyone, and welcome to the lecture on built-in functions on sets. In the previous lecture, we saw how to create sets by using the set built-in method and passing elements. For instance, we can create a set and then store the values in a variable called C. So C is equal to set. That will create an empty set C. We can call our set, and we saw one function called the add function. So C.add, and then we can add elements to our set. Let's say we add the element 3. Now if we call C, we have a set containing the element 3, and then to add more elements we can call the add function C.add, and we can add, let's say, 4, and similarly we can add C.add, let's say 5. If we call C, we have a set containing the elements 3, 4, and 5. And to see the available built-in functions, we can simply say C dot and then hit tab on your keyboard, and you'll see a list of methods available on sets. So we'll try to see most of these methods. Okay. So let's start with, we already saw add. Next, let's see the copy method. Let's copy our set C. So C.copy, and then we'll save it in a variable called D. Now if we run it and then call our D object, we have 3, 4, and 5. And we can add elements to our new set D. So C.add, let's add the number 6. If we call D now, we have the elements. We have a set containing the elements 3, 4, 5, and 6. Now let's look at some methods that we can do, some built-in methods we have on sets. One such method is the union method. So as the name implies, the union method will give us the union of two sets. For instance, so to use the union methods, we have our two sets C and D. So C dot union, and then we pass our second set, which is D. So that will give us 3, 4, 5, and 6. If we check the reverse, we'll get the same result, which is D dot union, and then pass our list, our set C. We get the same result. So the method union gives us the union of both sets. So all the elements in both sets will be displayed. And that takes us to another method known as the subset. So we'll check the is subset, and there's another method called superset. We'll look at those two methods next. So D dot, let's say, is subset, and then we pass our second set C. So this will give us a Boolean result, true or false. In this case, D that is subset C will be false. Subset means all the elements in one of our sets are in the other set. In this case, are all the elements in our set C. Let's call D first. So D is 3, 4, 5, and 6, whereas our set C has the elements 3, 4, 5. So D is D subset of C. Are all the elements in D included in C? No, because of this last element. So this will result false. So we get false. Whereas the superset method, if we check if our set C is a subset of D, that will be true. So C that is subset, we pass D, that will be true. Now let's look at the superset method. So C that is superset and then D. So superset is the opposite of subset. In this case, D is a superset of C, but C is not a superset. So this will return in false. Whereas D is superset of C will be true. Okay, superset is the opposite of subset. Next, let's look at the intersection method. So C that intersection, then we'll pass D. So this will give us elements where the two sets intersect. In our case, it will be 3, 4, and 5, right? Intersection means common to both sets. Similarly, if we do D that D intersection of C, we get the same result, 3, 4, and 5. Next, let's look at the difference method. So we have C that difference, then we'll pass D. So the difference method will give us elements that are missing in the second set. So in this case, C that difference is the difference between those two sets is the element 6. So C that difference. So C that difference D will give us an empty set. That's because the elements in C are not different from D, whereas D that difference C gives us 6. That's because 6 is not in our set C. So the results are different if we check C that difference, the second set, and then the second set that difference, the first set, unlike the other methods like union and intersection. So that's one thing to note. Okay, let's call our two sets, C and D. And next, let's look at the difference update method. So D that difference underscore update, and then we pass C, run it. So what this will do is that it will get the difference and then update it to our set. Here, our set D contains the elements 3, 4, 5, 6, and our set C contains the elements 3, 4, 5. And once we apply the difference update method, and if we call our set D, it has the element 6, whereas if we call our set C, we have 3, 4, 5. So what this method does is it takes the difference of the two sets and then updates the set with the difference. So that's what the difference update does. Now we have D as 6 and then
C as 3, 4, and 5. Let's look at another example. Let's create 2 more sets. Let's say I. We'll save the first one in I. Okay. The set. Let's use the range function. Range. Let's say from 4 to 10 in step sizes of 2. So if we call I, we have 4, 6, and 8. And let's create another set. I, let's call it J. Set range 4, let's say 4 through 8. If we call J, so J has 4, 5, 6, and 7, whereas I has the elements 4, 6, and 8. So if we do I dot difference update and then J, the elements that's only in I is 8, right? So if we apply this difference update on I, it will update our set I to only contain the number 8. So if we run this and then call I again, so now our new set only has the element 8, whereas J still has the elements 4, 5, 6, and 7. Let's add some more elements. Let's say I that add, let's add 6. If we call I now, we have 6 and 8, right? And if we do J dot difference update I, in this case, so J and I, the numbers or the elements 5, 7, and 4 are unique to J, right? 4, 5, and 7. So it will update our set J to contain those elements when we call this difference update method. Okay, so if we call J now, we have 4, 5, and 7. Great. Next, let's look at the symmetric difference method. So this symmetric difference will remove all the intersection elements, all the elements common to both of the sets. Okay, let's add some more elements to our set J. J dot add, let's add 6. So now J has 4, 5, 6, and 7. How about I? I has 6 and 8. Let's add one more element to I. I dot add, let's add 7. Let's call I. Okay, I has the elements 6, 7, and 8, whereas J has 4, 5, 6, and 7. So now let's see the symmetric difference method. I dot tab and then symmetric difference. I dot symmetric difference and then J. So this symmetric difference gives us elements that are not common, that are not found in both sets. So basically this is the opposite of intersection, right? So J has 4, 5, 6, 7, and set I has 6, 7, and 8. And these three elements, 4, 5, and 8, are unique. That means not found in both sets. That's because 4 and 5 are only found in our set J, whereas 8 is found in our set I. So that's the symmetric difference method. Similarly, if we do J dot symmetric difference I, we get the same result, 4, 5, and 8. And this takes us to another method called the symmetric difference updates.
So what that will do is it will update the set with the symmetric difference elements. So if we apply I dot symmetric difference update j, it will take these elements 4, 5, and 8, and it will update our set I so that it contains these 3 elements. If we run this and then call our set I, it now has the elements 4, 5, and 8, and j still has its previous elements 4, 5, 6, and 7. Now if we see the symmetric difference between our two sets I and j dot symmetric difference I, that will give us the elements 7, 6, 7, and 8. Let's run it. 6, 7, and 8. And now if we do j dot symmetric difference update I, now our set j will be updated to contain the elements 6, 7, and 8. So if we run it now and then call j, it has the elements 6, 7, and 8. So that's the difference between symmetric difference update and symmetric difference. Symmetric difference will give us the elements unique to the sets. That means elements not common in either set. And the symmetric difference update will update our set with those unique elements. And similar thing happens with the difference method and then the difference update method. The difference update method will update a given set with the difference. Next, let's look at the discard and remove methods. So as the name implies, both discard and remove methods remove an element from our set. Discard and remove. The only difference is the remove method will throw an error if the element does not exist in our set. Let's look at an example. So our set J has the elements 6, 7, and 8. So we can simply remove the element 8 from our set. We can say J dot remove. So we can remove it by using both remove and discard. So J dot remove, let's say 8. And now if we call J, our set only has the elements 6 and 7. Let's try to remove 8 again. So J dot remove and then pass 8. So right now 8 doesn't exist in our set, so this will throw an error. So if you run it, you'll get a key error. Okay, now let's look at the discard method. Let's call our set I. I has the elements 4, 5, and 8. Let's do the same thing. Let's remove 8 by using the discard method. So I dot discard and then pass 8. Now if we call I, we have a set containing the elements 4 and 5. If we try to remove I again, if we try to remove 8 again by using the discard method, since 8 doesn't exist in our set and we are using the discard method, so we'll not get any error. If we run it, nothing will happen, no errors. If we call I again, we'll get a set containing the elements 4 and 5. So that's the difference between discard and remove. Great. Those are most of the built-in methods that we have on sets. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the lecture on numbers in Python. Numbers are one kind of data type in Python, and we have different kinds of numbers like integers, floats, long, complex numbers, and so on. Integers are numbers like positive or negative numbers. So examples of integers: -2, 0, 7, or 5. No decimal point. An example of floats: floats have decimal points. For instance, 3.0 is an example of a float. 4.90 is an example of a float, and so on. Okay, and we can store integers in variables. For instance, we can say x is equal to 4, and if we call our variable x, we get the number 4. X is equal to, for instance, negative 0.98. We can do that. Then if we call x, we get negative 0.98. Next, let's see the operations that we can perform on numbers. We can perform operations like addition, subtraction, multiplication, division, modulus, and so on. We'll look at some of the operations that we can do on numbers. Let's start with addition. So we can add two numbers. For instance, 4 plus 5, we get 9. 9 plus 0.34 plus 9, we get a result, and we can store our result in some variables. Let's say x. If we call x, we get 18.34, and we can add values to our x. You can say x plus 34. We have a new value now, and then we can store this in some other variable. Let's say y is equal to that. Now we can add x plus y plus y. We get that. So that's about addition. Next, let's see subtraction. So we can subtract one number from another. 2 minus 9, we get -7, and we can use the variables that we created earlier, and then we can say x minus y, -34. We can say x minus y, and then close that in parentheses. Then we can say minus x. So the order of precedence is obeyed for these operations. We can say x minus x, that will give us 0. So those are some operations using subtraction. Next, let's look at multiplication. We can multiply two numbers, 4 times 3. Let's say 4 times 5 times x. We can do that. 336.8. Can say x times y, and we get the result. That's multiplication. And let's see division next. Division is a little bit different in Python too. I'll show you why. So if I say, let's say 7 divided by 7, that will give me 1. That will give me 1, right? What if I do 7 divided by 3? This should give me what? Let me run it and show you what the result is in Python 2. So it gives me 2. We know that 7 divided by 3 is not 2. And in Python 2, Python 2 doesn't perform actual division. Anything after the decimal point gets removed. Another example, we know that 5 divided by 2 is 2.5, but the result we get is 2. So So the actual result 2.5, anything after the decimal point is taken out in Python 2. So we get 2. We don't get the true division result. And we can avoid that in one of the following ways. The first thing we can do is convert one of the numbers to a float, either the numerator or the denominator. So we can say 5.0 divided by 2. So that will give us the actual true division result. Similarly, we can do 7 divided by 2.0 and we get 3.5. 7 divided by 3, 7 divided by 3.0, we get 2.333, so on. The second method is to cast either the numerator or denominator to a float. So we can do that by saying float, and then let's say 7 divided by 3. That's called casting. So we're casting it to a floating number, to a float. That will give us that result. We can also cast the denominator. You can say 7 divided by float 3. We'll get the same result. And another way to perform this true or actual division is by using or importing the division module from the division function from future module. Let's import it. So from future import division. So future here underscore underscore future underscore underscore, this is called a module. A module consists of various functions. So what we're doing here is from a module named future, we are importing the division function. So this will allow us to perform the true actual division. Okay. So once we import that, we can do 7 divided by 3. We get 2.3. 11 divided by 5. We get 2.2, and so on. If you are using Python 3, you don't have to worry about this. Python 3 performs actual or true division. So these methods are for those using Python 2, including myself. So this is how we can perform the true actual division in Python 2. Next, let's see the modulus operation. Modulus will give you the remainder. For instance, if we do 5 modulus 2, this is the same as 5 divided by 2 is what? 2 times 2, right? And then the remainder is 1. So the modulus gives you the remainder. So in this case, 5 modulus 2 is 1. 6 modulus 5. 6 modulus 5, this means when you divide 6 by 5, the remainder you get is 1. So 6 modulus 5 is 1. 12 modulus 6 is 0, because you don't get any remainder. The remainder is 0 basically. And 3 modulus 2 is 1. 3 modulus 2 is 1. So that's the modulus function. We'll be using modulus a lot to determine, if a number is, for instance, if a number is divisible by 5, if a number is divisible by 6, if a number is, divisible by 8, and so on. Next, let me show you the power function. We can do power function is double asterisk. That's 2 to the power of 3 will give you 8. 2 to the power of 5 will give you 32. And then for square root, we can say 16 to the power of 0.5. 0.5 will give you 4. This will give us 4. And let's say 225 to the power of 0.5. It means square root of 225, and that will be 15. So those are some of the operations that we can do with numbers. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome back. In this lecture we'll look at certain functions that we can perform on numbers. Before we do that, I want to show you how we can convert one number data type to another. We'll mainly look at how we can convert a number from an integer data type to a float or vice versa. Let's say we define a number 5 and store it in a variable x, and to know the data type of this number we can simply say type of x. So this is the type function, type, and then we pass our number. In this case we passed our object x, which holds the number 5. So integer. We could have also said type of, let's say, the number 5. We get integer. And in order to convert this integer data type to a float, for instance, we can simply use the float function. All you have to do is use the float function and then pass the number. For instance, we can pass x. So this method will convert x to a float data type. So 5.0. We could have also said float, convert 5, float. And we can save this in another variable, let's say y. Now if we call y, we have 5.0, and type of y is a float. Great. Now let's have another number and store it in a variable a, and let's say it's 3.45, and type of a is a float. And we can convert a float data type to an integer by using the int function. So we say integer and then pass our object, in this case a, and now it's an integer 3. Notice here the 2 digits after the decimal are dropped, because integers are either positive or negative numbers and 0, and they don't have any decimal points. We could have also said integer, convert the number 3.45, and we get 3. And we can save this in another variable, let's say b, and if we call the type of b, it's an integer, and b now holds the number 3. Great. With this, let's see some of the math functions that we have in Python. We have functions like absolute value, ceiling, exponent, log, floor, modulus, power function, the square root function, and so on. So we'll try to look at each of these one by one. And most of these functions are in a module called math. This is a module that contains a lot of mathematical functions. So in order to use any of these functions, we need to import the math module, and we can simply import it by using the import statement. So we say import math. So that will import the math function, the math module. And then we can reference this math module to use the functions in it. Let's start by looking at the absolute value function, the ABS function. So this absolute value function returns the absolute value of a number. So absolute value of a number is either 0 or a positive number. So for instance, the absolute value of 0 is 0, and the absolute value of a negative number, let's say negative 8, is positive 8, and the absolute value of a positive number is a positive number. ABS absolute value of negative 4.2 will give us 4.2. So that's the absolute value function. It gives us 0 or a positive number. Next, let's look at the ceiling method. The ceiling method returns the upper value of a given number. As I mentioned earlier, most of these functions are in the math module. So in order to use them, we first have to import the math module, and then we can use the functions or methods in the math module. And the way we do it is as follows. We have once we import the module, we have the module dot and then name of the function. So in this case, ceiling or method. Name of the function or method is ceiling, ceil. So math dot ceil. Then we pass the number. Let's say 23.2. So in this case, the ceiling is 24. So ceiling is, in this case, is 24. So if we run this, we get 24. Math that ceiling of, let's say, 23.001, it's still 24. So you have to distinguish this method, this ceiling method, from the round method. Here we're not rounding, we're taking, if there is any decimal after this point, if there is any numbers after the decimal, we'll be taking the next integer. Basically, that's what ceiling is. So that ceiling of, let's say, 23.9999, we get 24. So we get the upper integer. And that takes us to another method known as floor. So floor is the opposite of ceiling. It gives us the lower integer of that given number. In order to use it, we say math dot floor. Then we pass our number. Let's say, for instance, 23.3. That will be 23. Math dot floor. And then if we pass 23.999, we still get 23, because we'll be taking, it takes the lower integer value of the given number. Okay, math dot floor, let's say 23.5, we get 23. And it works the same way for negative numbers. If we pass negative 3.4, we get negative 4. Math, and same thing for the ceiling method. It works for negative numbers. If we pass 3.4, we get negative 3. Great. Next, let's look at the exponent function. So this exponent function, let's say exponent of some number x, this will give you the result of e to the power of x. So basically this is the same as saying e to the power of x. Let's see some examples of the exponent method. So math.exponent, and then let's pass 2. So that's the same as saying e to the power of 2, which is around 8, somewhere between 8. So 7.38. So the value for exponent is 2.17, I believe. 2.7, and it goes on. So it's somewhere around that, 2.7. So that's the same as saying 2.7 squared. So 7.29. I was close. Okay, let's look at some more examples. Math.exponent. Let's see. 7. So that will give us 1096.63. We can also pass negative numbers. Math.exponent. Say negative 2.5. We get 0.08. Math.exponent. Let's say negative 123. We get 3.8 times 10 to the power of negative 54, and so on. That's the exponent function. This takes us to another method known as logarithm, and that returns the natural logarithm of a given number. In order to use that, we say math.log, then we pass the number. Let's say logarithm of 2, we get 0.693. Math.logarithm of 10, we get 2.302. Math.logarithm of, let's say, 234, we get 5.45. There's also another logarithm function, which is to the base 10. We can use that by calling the math module that, and then log 10, and we pass the number, whatever number we want. So this is logarithm to the base 10. For instance, if you say math logarithm 10 of 10, that will give you 1, and math that logarithm of 1000 log 10, then we pass, let's say 1000, that will give you 3. Logarithm math that logarithm to the log 10 logarithm of, let's say 2, that will give you 0.301. so that's logarithm to the base 10. That's how we distinguish it from the logarithm to the natural logarithm. And math log 10, if you want to find out logarithm of 1, I think it's 0. Yep. And if you try to find the logarithm of 0 or a negative number, you'll get an error. So if you try 0, you get an error. It says math domain error. Similarly, if you try to find the logarithm of a negative number, you get an error. So be careful with those. So these are some of the functions that we have for numbers, and in the next lecture we'll see some more functions. Thank you everyone. Hello everyone, and welcome back. In this lecture we'll continue our discussion of the math functions. Last time we mentioned that we need to import the math module, since this module has most of the functions, and we'll be using the math module to use some of the functions. So when we call the functions, it goes like math, then module name dot, and then method name. That's for most of the methods, most of the functions. Okay. Let's start by looking at
the square root method or function. So the square root function tells us the square root of a number. That will give us the square root. Let's look at an example. So that square root of, let's start from the ones we know, 16, that will give us 4. That square root of 25, that will give us 5. So that way we can find out the square root of any number. Let's say 2, 3, 4, and so on. Next, let's see the round method. So this round method will round a given number to certain decimal points. Let's see how we can use that. So to use this, we just say round and then pass the number. For instance, let's say we want to round 12.4 to 1 decimal point. So one digit after the decimal point. Or maybe, yes, 1 digit should be fine. So then once we pass the number, comma, and then how many digits that we want after the decimal point, we specified here. So we said 1. So we simply pass 1. We get 12.4. Now let's round the same number to 2 decimal digits. So 12.423. We want to round this to 2 digits after the decimal point. So we pass the number, comma, then how many digits we want after the decimal point. In this case, 2. So we pass 2. And we get 12.43. And if you don't want any decimal points, any digits after the decimal point, you simply pass the number in the round function and just leave it like that. So 12.0. That's the same as saying this to 0. Okay. Then round, let's say 12.52 to 4 decimal digits. So we get 12.52 since we don't have any more digits. That's the round function. Next, let's look at the power function. So we saw that we can use double multiplication for power. For instance, if I say 2 times 4, that means 2 to the power of 4, and that will give me 16. There's also a power function specific for this. It's the POW, that's the power function. Okay, let's see some examples. So math.power, and then we pass the number we want to power, let's say 2, and then the power that we want, comma 4. So this means 2 to the power of 4. That should give us 16. Similarly, we can say math.power of 3 to the power of 3. That should give us 27. Math.power of 5 to the power of 4. That should give us 625, I believe. 625. Math.power. We can also power to a negative number. Let's say 100 to the power of -2. That's 1 over 10,000. Similarly, we can do math.power of, let's say, -3 to the power of -4, and that will give us this number. So that's the power function. Next, let's look at the maximum and minimum methods. So as the name implies, the maximum method returns the largest of the numbers in a given sequence. Let's look at an example. So we can say maximum of, let's say, 2, 4, 2, 4, and 3. That will return 4. Maximum of, let's say, 34, 45, and 44. That will return 45. Let's look at one more example. Maximum of -3, -4, -5. That returns -3. That's the maximum function. And similar to the max, we have a minimum function, and the minimum function returns the smallest of the numbers passed in the function. Let's look at some examples. The minimum of 5, 8, and 3. We get 3. Minimum of 33, 33, 45. We should get 33. Minimum of, let's say, 0, -1, -3, -1. We get -3. So that's the minimum function. We also have trigonometric functions like sine, cosine, tan, and then arcsine, arccosine, arctan, and so on. We can use those similarly by importing the math module, and then by calling the function in the math module. So for instance, if I want to find out the sign of a given number, I can say math.sign and then pass the number that we want. Let's say sine of 1. We get 0.841. Math.sign of 45. We get 0.85, and so on. That's the sine function. And similarly, to use the other trig functions, we can call whatever function we want in the math module. So for instance, we can say math.cosine and then pass cosine of, let's say, 0. I think that's 1. Oops. Math.cosine of 0. That's 1. Math.cosine of 90. I think that's 0. -0.44. Math.cosine of 30. I think that's 0.8 something, 0.15. So we can also use these trigonometric functions that are found in the math module. These are few of them, but there are plenty more. There is a radian function also, there's a degree function, and there are much more. Okay, thank you everyone, and see you at the next lecture. Hello everyone, and welcome back. In this lecture, we'll look at the following 3 functions: range, random, and the shuffle methods, and they are found in another module called random. And these functions or methods are used to create random numbers. They are used to generate random numbers, and I wanted to quickly show you how to use them. Okay, similar to the math module, the first thing we need to do is import this random module. So we start with our import statement, import random, and then we can use any of these functions by referring to this random module. Let's start by looking at the range function. So this range function returns some random number from what we pass. Let me give you an example. So we have our range. So here from the word, it implies there will be some range of numbers. So let's pass that range of numbers. Let's say between 2 and 34. So that will be the range, right? Okay, so rand range 2 and 34. From this, what this function will do is it will generate a random number between 2 and 34. So let's do that. Random.rand range. Then we pass our starting point and ending point for our range. Then we run it. So we get 5. So that's the random integer generated between 2 and 34. So if we run it again, we're gonna get different results. Now it's 4. Now it's 33. Now it's 24. Now it's 20. So it's returning number by randomly choosing one. Okay, we can also specify step size. For instance, we can say 5. That means this means a step size, so it will generate a random number in a step size of 5. So now the random numbers are more limited. So 32, 7, 27. So the choices are 7, and then 7 plus 5 is what? Let's see. The choices are 7. 7 plus 5 is 12. 12 plus 5 is 17. 17 plus 5 is 22. 22 plus 5 is 27. And then 27 plus 5 is 32. So the random number generated this time will be one of these numbers. Okay, 7, 2, 17. Okay, let me add 2 here. 32, and so on. Okay, that's how we can use the rand range method. Next, let's look at the random method. So the random method, as the name implies, it returns a random number between 0 and 1. So it will give us a random floating number between 0 and 1. Let's look at an example. So random, that's the module name, that, and then we'll call the random method or function from this module. So random, and then we run it. So we get 0.10, 0.89. So it generates a random floating number between 0 and 1. So if we run it again and again, we'll be getting different results. 0.01, 0.7, 0.39, and so on. But those random numbers are between 0 and 1. Next, let's look at the shuffle method. So the shuffle method, as the name implies, it shuffles elements in a given list. If we have some list, and if we call the shuffle method on it, if that list contains some numbers, it will reshuffle them or randomizes them. Let's look at an example. Let's say we have a list of numbers, list 1, and let's say it contains the numbers 2, 3, 4, 5, 6, 7, 8, and 9. Let's call the shuffle method on our list 1. So random.shuffle, and then we pass our list 1 object, and then run it, and then if we call our list 1 object, we see that the numbers are now shuffled. So instead of 2 through 9, we have 2, 7, 4, 6, 3, 8, 5, 9. Similarly, if we call the method again, random.shuffle list 1, and then run it again, we get 9, 2, 8, 5, 4, 7, 6, 3. If we run it again, we get 3, 7, 4, 6, 5, 9, 2, 8. So it randomly reshuffles the numbers in a given list. That's the shuffle method. And that brings us to the conclusion of this lecture. I wanted to quickly cover these three methods: random range, random, and shuffle. So they are used to generate a random number. Thank you everyone, and see you at the next lecture. Hello everyone, and welcome to the section on Python operators. In this section of the course, we look at different types of Python operators. Here we have a list of operators. We have arithmetic operators, comparison operators, assignment operators, logical operators, bitwise operators, and so much more. In this section, we'll mainly look at the first three operators. We'll start by looking at arithmetic operators, and we'll see comparison operators, and later on we'll look at assignment operators. So arithmetic operators, those are the basic arithmetics. For instance, addition, multiplication, division, modulus, and subtraction. And comparison operators are operators like equal sign, greater than or equal, less than or equal, and so on. And examples of assignment operators, they are double equal, not equal to, greater than or equal to, less than or equal to, and so on. We'll see each type of operators in a separate lecture. Let's start with arithmetic operators. So these are some of the basic arithmetic operators. We have addition, subtraction, multiplication, division, modulus, and exponent. Next, let's look at some live examples of arithmetic operators on Jupyter Notebook. Thanks everyone. Hello everybody, and welcome to the lecture on assignment operators. So here is a list of assignment operators. We have equal sign, plus equal, minus equal, multiplication equal, division equal, and we have modulus equal. These are some of the main assignment operators. Let's say we have two variables, a and b. So we can compare them by saying a is equal to b, and that will give us true or false. We can say a plus equal b. It means a is equal to a plus b. We can say a times is equal to b. It means a is equal to a times b. Let's go to Jupyter Notebook and see some live examples. Thank you everyone. So if I say C is equal to A plus B, and if I call C, I get 14. Remember, initially C had a value of 8. Now I have assigned C as A plus B, which is 14. 7 plus 7. I can also do C is equal to C plus 5. And if I call in C again, I get 19. So I assigned a new value to C. Instead of writing this whole thing, I can also do C plus equal C. C plus equal 5.
run that, and if I call in C again, I get 24. This basically means take the value of C and add 5 to it. So if I do C plus equal 4, what this is doing is C is equal to C plus 4. It's basic, it just means that. Let me comment that. So if I run this, C is 24 and add 4 to it, I should get 28. And then call C again, I get 28. Similarly, I can do C minus equal 9. So this is the same as saying C is equal to C minus 9. Oh. C is equal to C minus 9. That's what it means. So C is what? 28. 28 minus 9, I'll get 19. So if I call C, I get 19. Same way, if I have a new variable, let's say B is equal to 2. If I call B, I get 2. If I say B times equal 3, this is the same as saying B is equal to B times 3, which is 2 times 3, I should get 6. If I call B again, I get 6. And I can do the same thing for division. B equal 3. And if I call B again, I'll get 2. Great. Finally, let's look at precedence of operations. Python also follows operation precedence. So I can say B plus 4 plus 5 minus 2 plus C. Let's see what I will get. I get 24. By following, this follows order of precedence. However, if I do B plus 5 minus 2 plus C, oh, I get the same. Let me give you another example. B plus 5 minus 2 plus C. So if I put that in parentheses, run it, I get negative 14. This is to show you that the order of precedence is followed in Python. In this case, whatever is in parentheses is performed first, which is 2 plus C. What was the value of C? Let me call in C. So 19. 2 plus 19, that's 21. And then the next order is subtraction. 5 minus 19 is negative 14. And then B has a value of, let me call him B. B has a value of 2. So this statement is the same as saying 2 plus 5 minus 2 plus C has a value of 19, right? So 2 plus 19 is 21. This is the same as 2 plus 5 minus 21. 5 minus 21, negative 16, plus 2, I get negative 14. Great. So in this lecture, we looked at the different types of operators. We started by arithmetic operators, and then we looked at comparison operators, and finally we looked at assignment operators. And it's important to note that Python also follows order of precedence. Thank you everyone, and I'll see you at the next lecture. So if I have two variables a and b, let's say I assign a value of 5 to my variable a and a value of 7 to my variable b. I can do a plus b, that should give me 12, which is 5 plus 7. If I do a minus b, I get negative 2. If I do a times b, I get 35. And if I do a divided by b, I get 0. Last time we looked at how we can get the true division result. And if I do a to the power of 2, I get 25. And similarly, if I do b to the power of 2, I get 49. Let's look at some example of modulus. Modulus basically means if you have two numbers, let's say in our case a and b, and if I do b, the sign for modulus is percentage, b modulus a will give me 2. Basically what this means is if I divide 7 by 5, the remainder is 2. So that's what modulus is, the remainder. Simply if I say 2 or 4 modulus 2, I'll get 0. That's because 4 divided by 2, remainder is 0. So that's modulus. And if I do 7 modulus 5, I will get 2. Great. And if I have 3 variables, I already have defined a and b. And if I add variable c and assign it a value of 8, I can still do a plus b plus c, and I get 20. Similarly, I can do a minus c. Great. And also I can combine a times b, and I can create a new variable and say, let's say I create a variable d, and d will hold the values of a plus b. So if I call d, I get 12. And I can do operations on my new variable d. For instance, d plus 5. 12 plus 5, I get 17. So here I have 3 variables, right? A is equal to 5, b is 7, and I have c here, 8. So let's call a let me call B, right? And let me call C. If I do A double equal to B, I'll get false. That's because 5 is not equal to 7. If I say A less than B, I get true. That's because 5 is less than 7. Similarly, if I do A greater than B, I get false. So it's comparing the value on the operand on the left side with the operand on the right side. Similarly, if I say A less than or equal to B, I get true. That's because 5 is less than or equal to 7. Let me define another variable here, A, and assign it the value of 7. So if I say A less than or equal to 7 or B, I get true. That's because now both A and B are 7. If I say A less than B, I get false. That's because 7 is not less than 7. Similarly, I can do A equal to B less than C, I get true. That's because A has the value of 7, which is equal to B, yes, and the value of C is, let me go up, C. Here, C has a value of 8, right? So 7 is equal to 7, which is true, and 7 is less than 8. That's true. Similarly, I can do A less than B less than C. I get false. That's because this first part is not true. 7 is not less than 7. Similarly, I can do C greater than B greater than 2. I get true. That's because 8 is greater than 7, which is also greater than 2. So I can compare multiple values. Okay. Hello everyone, and welcome to the lecture on the range and Xrange functions. In this lecture, we'll see how to use the range function and the differences between the range and Xrange functions. We use the range function to create a list of numbers. For instance, I can say range and then pass, let's say 4. So this will create a list of numbers from 0 to 3. Let me run it and show you. So now we have a list of numbers from 0 to 3. So if we pass the range function and then pass n, that will create a list of numbers from 0 to n minus 1, where n is a positive integer, right? So that's the range function. Similarly, I can say range and then 22. This will create a list of numbers from 0 to 21. So by default, the range function will give you a list starting from 0. However, we can change that initial point by passing another number. For instance, we can say range from 4 to 10, for example. In this case, we'll get
a list of numbers from 4 to 9. So if we run that, we get 4, 5, 6, 7, 8, 9. So if we pass a starting point, the range function will start from that number. Otherwise, it will start from the default value from the default 0. Similarly, we can say range, let's say from 3 to 11. This will give us a list of numbers from 3 to 10. Right, starting point 3 and ending point will be 11 minus 1, which is 10. So that's the range function, and we can store our result in a variable. Let's say list1, and we can call our list1 object. So we have a list of numbers from 3 to 10. Another thing we can do is we can pass a starting point, which is our initial number, and then we have our final, and then we can also pass what is known as step size. Step size means in how many steps do we want our list to be. For instance, we can say range, and then I want a list of numbers from, let's say, 5 to 25 in step sizes of 2, for example. So this will give me a list of every other number from 5 to 25. So the list will look like 5, and then 7, 9, all the way to 23, right? So this is a step size. We can do that. And here, if I change this to, let's say, in step sizes of 10, I will only get 5 and 15, right? Similarly, I can say in step sizes of 4, and gives you 5. 5 plus 4 is 9, plus 4, 13, and so on. So the range function is mainly used to create a list of numbers, and we can save that in some variable and then use that variable. You'll see the range function used a lot with for loops. We have a section on for loops in the future. We'll look at that, but just to give you an overview, we can say for I in range, let's say 5, print I. So we have already seen what this range function will do. So this will create a list of numbers from 0 to 4, right? 0, 1, 2, 3, 4. What this for loop does is that it will go to each of the elements in our range and then print those elements. So not to make it confusing, let me use the variable number. So for number in our range, print each of the numbers. So if we run that, we get 0, 1, 2, 3, 4. Don't worry about this. We have a section dedicated entirely for loops. We'll see a lot of this, but I just wanted to give you an example of how we can use the range function with for loops. It's a very common usage, range function in for loops. Okay. So main use of the range function is to create a list of numbers. And the range function can be used in Python 2 and Python 3. However, in Python 2 we have another function known as the Xrange function. The Xrange function is unique to Python 2. We don't have the Xrange function in Python 3. So what this Xrange function does is that it returns an Xrange object, and this is a generator object, and we use those generator objects to generate numbers whenever we need. So for instance, if I say Xrange and then pass 6 and run it, we get an Xrange object. So if we check the type of this Xrange object, we'll see that it's of data type Xrange. So you'll see the difference if you are using a large list of numbers. For instance, if I say range, let's say 4 to 100,000. So if I call this range function, it will give me a list of numbers from 4 to 100,000 minus 1, right? So 4, 5, 6, all the way to 99,999. And that, as you can imagine, will take a lot of space in memory, right? It will occupy a lot of space in memory. Whereas if we call the Xrange function, that will only give us an Xrange object. Okay? So if I call that, it will give us an Xrange object. It won't give us all of that list. But we can use this Xrange object, and then we can, so let me show you the type of this object. It's an Xrange object. We can use this Xrange object to generate the numbers that we want when we want it. This is called this is a generator object, and we also have another section on generators and iterators, and in that section we look in depth about generation and iteration. But I wanted to quickly show you the difference between the Xrange and range functions. So Xrange function only exists in Python 2, and we use this Xrange function in case we deal with a larger list of numbers. For instance, if this was 1 million, 10 million, 100 million, we would use the Xrange function instead of the range function, right? As you see, it occupies a lot of space in memory. No Xrange function in Python 3. But does that mean we cannot perform this in Python 3? The answer is we can. So when we use the range function in Python 3, it does what the range and Xrange functions do in Python 2. So range in Python 3 is equal to range and Xrange in Python 2. So that's the difference. So if you are using the range function in Python 3, you have to specify which one to use. You have to let your Python 3 know that you want to generate a range of numbers, but not, an iterable object. In that case, if you are using the range function in Python 3 to create a list of objects, you have to include the list method and then pass your range function. For instance, list and then range 10. So this will create a list of numbers from 0 to 9. Okay, so don't forget to cast your range object into a list if you are using Python 3. So list and then range, let's say 3. So you'll have to cast your object into a list. And if you want to use step size, it's the same thing. Let's say list range for step sizes, so starting point and then ending point, let's say 28 in step sizes of 3, for instance. So you'll have to cast your object into a list if you want to use the range function in Python 3, since the range function does both Xrange and range. Okay, that's how you can create a list by using the range function in Python 3, casting it into a list, since the range function does both creating a list containing numbers and also iterating by using Xrange. So that's the difference between range and Xrange functions. And usually, if we are dealing with small lists of numbers like this, range 22, these are small lists and they don't occupy much space in memory. So in those cases, we use range functions. Whereas if we are dealing with a larger set of numbers, a larger list. So to summarize, we saw how to use the range function to create a list of numbers. And we can also specify where our range function can start and end by passing an initial value for our list to start and a final value. And we also saw that we can pass a step size value so that we can create the list as we want it. For example, here we created a list of numbers from 5 to 25 in step sizes of 4. And we saw that there is another method called Xrange in Python 2. Thank you everyone, and see you at the next lecture. Hello everyone, welcome to the Project 1 section of the course. In this project, we'll create a game. So we'll ask the player to guess a number. And here are some instructions to play the game. So we'll create a game on guessing numbers between 1 and 20. We'll ask the player to guess 7 times. And then we'll give the player a clue if their guess is too low or too high. And if the player guesses right, we'll tell them that they guessed it right in n number of guesses. And if the player runs out of guesses, we'll tell them the number we thought of initially. Alright, great. Let's start coding. Okay, first, let me create a variable that will hold the number of guesses taken. So I'll name it guesses taken, and I'll give it a value of 0 initially. And let me create another variable called secret number, and this number will be equal to random integer, then between 1 and 20. So I'll explain this in detail, and then let's print hi there, I am thinking of a number between 1 and 20. Okay, so here I am using the random module, so I have to import that module. Let me import that. Import random. So this is one module in Python. So in here I have imported the random module. Modules are just Python programs that contain additional functions, and we can use the functions of these modules by bringing them into our program with the import statement. So in this case, I am importing the random module. And here, rand integer, it's a function provided by the random module. So to call a function from a module, this is how we do it. Name of the module dot name of the function. Great. And this random integer function will return a random integer between two numbers. So in this case, let me make this 20. So in this case, it will give us a random integer between 1 and 20. Great. And then whatever random integer is provided by the system, we'll store it in this variable called secret number. Great. Okay. Next, let's ask the player to guess 7 times. So ask the player to guess 7 times. Okay. So we can do that in several ways. Let me show you how we can do that using for loops. So I can say for guesses taken in range 1 to 8, since the player is going to guess 7 times, print, let's say, take a guess, right? And then we can have guess is equal to row input. So this row input is a string, right? So we need to store it as integer. So I'll convert it using this function, integer, and then the row input. So whatever string will be converted into integer and then stored in the guess variable. Great. And then I'll check if I'll compare my guess to the secret number generated by the system. Okay, let's do that using the if statement. So I can say if guess is less than secret number, print your guess is too low. So that will be a clue for the player. Elif guess is greater than secret number, print your guess is too high, right? Your guess is too high. And then else will break, right? So this condition is the correct guess, break. This condition is the correct guess. Okay, let's move on. Now I'll check if the guess is equal to the secret number, right? So if guess is equal to my secret number, print. So we'll let the player know that they have guessed it right. Let's say, awesome, you have guessed my number in, we can say that, plus and then we have guesses taken. Here we have guesses taken, and then since that's an integer, we have to convert it into string, right? So we have guesses taken plus guesses. Let me put that in parentheses and in quote. So here it says if guess is equal to the secret number, awesome, you have guessed my number in this number of guesses. Great. And then else print, we can print something like nope, game is over. The number I was thinking of was, and I can say plus secret number, right? And since secret number is an integer, I have to convert that into a string. So I do that as follows: str string, and then let me close the parentheses. Good. Now let me save that. Okay, great. Now we have our game ready. So let's go through it and explain some of what we did here. So initially we created a variable called guesses taken, and then we assigned a value of 0, and then we created another variable called secret number, and this variable will store the randomly generated number. The computer will generate a random number between 1 and 20. Great. And then here we have a for loop. So for the guesses that we take between, so we're taking a guess of 7 times. So range between 1 and 8. And then we converted the input to integer, and then we store that in the guess variable. And once we store it, we compare that guess with the secret number the program generates. And if our guess is less than the secret number, your guess is too low will be printed. And if the secret number is less than the guess taken, your guess is too high will be printed. Else it will break out of this loop, meaning the person has guessed right. And then here I have a condition. If guess is equal to the secret number, this statement will be printed, and then it will say, hey, you have guessed it right in this number of trials. Or it will say, game is over. The number I was thinking of was the secret number. Okay, let's play the game. So here it says, hi there, I'm thinking of a number between 1 and 20. Take a guess. Let's say 7. Oh, awesome. It says, awesome, you have guessed my number in 1 guesses. Okay. Here, let me make a space, and then another space. Let me make a space here, so there will be a space in the result. Okay, let me save that and play again. Okay. Hi there, I'm thinking of a number between 1 and 20. Take a guess. Let's say 16. It says your guess is too high. Take a guess. Okay, 14. Your guess is too high. Take a guess. 12. Your guess is too high. Take a guess. 10. Awesome. You have guessed my number in 4 guesses. Great. So this part is working. what if my guess is not right? Let me see if I can print out this else statement. Okay, let's play again. So take a guess, let's say 8. Your guess is too high. Let me say 9. I just want the second statement to be printed. Okay, 11, 12, 12, 14. Let me show you here. 13. Okay, finally, after I guess 7 times, it says, nope, game is over. The number I was thinking of was 1. Great. So this is just one way of guessing a number between 1 and 20. Okay, next I'll show you another way of accomplishing the same program. And then we'll use the while loop. Great. Okay, let me show you an alternate way to build my game using the while loop. Okay, first I'm going to import the random module, and then I'll have a variable named guesses taken is equal to 0. And then let's generate a random number between 1 and 20, and then we'll store it in a variable called secret number. So random integer between 1 and 20, right? Good. Then we'll have our print statement. Hi there. Let's play a game. I am thinking of a number between 1 and 20. Okay. Then we'll ask the player to guess 7 times. Okay. Ask the player to guess 7 times in our case. Okay. Let's use the while loop. So while guesses taken is less than 8, colon, we can print the statement, please take a guess, right? Or something like that. And then we'll create a variable called guess, and then we'll store the player's input. So that guess will store the raw input, right? And then since that raw input is a string, we need to convert that string into an integer. And we can do that as follows. I can cast it like that, right? Great. Or the alternate way will be, I can also do this. So guess is equal to integer. So I can cast the guess, right? Initially guess was raw input, and then so this will be the alternate way. Guess is equal to raw input. So like that, guess equal to raw input, and then I'm casting guess into integer. Okay, let's move on. Then guesses taken will be equal to guesses taken plus 1. Great. We talked about infinite loops while using while loop, so make sure not to run into 1. because otherwise if I am not adding 1 to the guesses taken, we will run into an infinite loop because 0 will always be less than 8. But this statement will make sure that we add 1 at the end of each guess, so we don't run into an infinite loop. That's very important to note. Okay, now let's check if the guess taken is equal to the number generated by the program. So we do that by using if statement. If guess is less than our secret number, print your guess is low. Elif guess is greater than secret number, print your guess is high, right? And then else we can break the condition. Break. Okay, and then we can check if guess is equal to the secret number. Secret number. In that case, we'll print out great job, you guessed my number in plus guesses taken, right? Since guesses taken is an integer, I have to convert that into a string. Plus guesses. So this will print out in how many guesses the player got it right. Else print nope, the game is over. The number I thought of was, let's put a space there, plus our string secret number, right? Since secret number is an integer, we have to convert that into a string. Great. Let's save it and run our program. So let's play. Hi there, let's play a game. I'm thinking of a number between 1 and 20. Please take a guess. Let's say 3. Your guess is too low. Please take a guess. Okay, 7. Guess is too high. Please take a guess. 4. Great job. You guessed my number in 3 guesses. Okay. So this condition is working. Let's see if the second condition is working. All right, let's run it again. Okay, let's take a guess. 9. It says your guess is too low. Let's say 4. Let's say 4. Your guess is too low. 5. Your guess is low. 6. Your guess is low. 7. Your guess is too low. 2. Your guess is low. 1. Your guess is low. 4. Okay, here we got your guess is low. Nope, the game is over. The number I thought of was 18. So both conditions are working. And you can build this game in other ways if you want to. I just wanted to show you that you can use various ways to build a game or a program. Great. Thank you, everyone. And I'll see you at the next lecture.
Hello everyone, and welcome to the lecture on if, elif, and else statements in Python. This if, elif, and else statements are also called decision making. This is because there will be certain conditions, and based on those conditions, either some code will be executed, and if the given condition is not satisfied, some other code will be executed. That's why it's a decision-making process. And based on statements given, the outcomes can be true or false. Usually, if the value given is not 0 or not null, the statement is evaluated as true. And usually, this is what the if-else statement looks like. We have the if statement, and then we have some, let's say, condition. So this condition is defined, and if that condition is true, this code will be executed. This code gets executed if that condition is true. Else, some other code gets executed. So we have a condition, and if that given condition is true, so whatever statement underneath gets executed. And if that condition is not true, some other code will be executed. So this is the general flow for if statements. And we have three kinds of statements. We have if statement, we have if and else statements, we have if, elif, and else statements, and we also have nested if statements. We'll see each of this one by one. First, let's start by looking at a simple if statement. Let's say we have some number. Let's say the number is 22. Now we'll execute an if statement, and then some code will be executed. So let's say, first we'll see a simple if statement. We can say if number, we can simply say print the number is what's expected. We can simply run this. So the way we write if statement is we have if, and then we have our condition, colon, new line, indent. So execute this statement. So this if statement will execute. We'll check this condition. This is the condition. So if that condition is true, the statement underneath it will be printed or executed. So let's run the statement. We get the number is what's expected. So in this case, we mentioned that if the given condition, if the value is not 0 or if it's not null, that condition is evaluated as true. So here, the number we have defined is 22. Then if number, so in this case, number is not equal to 0. So the condition underneath it got executed. So that's the same as saying, in other words, it's the same as saying if number is double equal to 22. So that's another way of saying it. Okay, what if this condition was not true? Let's define another number. Let's call it number 2, and then let's set it to be equal to 0. Now if we say if number 2, print the number is not expected, or whatever statement that we want. So what do you think will happen if we execute this statement? So let's run it. Nothing will happen. That's because this condition, when it checks for this condition, so the condition is not true. The value is 0. So in this case, when it checks for the if condition given here, it's not true. So this code of statement, this print statement, is not executed. As a result, we didn't get anything. And if we have another statement, let's say print this code regardless. So if we add this condition, remember, this print statement is not part of the if condition. It's not part of our decision making. You see, it's by itself. So if we run this last code will be printed. Print this code regardless. But if this was indented again, none of it will be printed. But this is by itself. It's not part of the if statement. Similarly, in our above example, if we had another print statement here, print this will be executed regardless. Okay, if we run that, we have the statement. This will be executed regardless. Okay, so this is the if statement. It will check if the value is true, and if the value is true, it will execute the code beneath the if statement, beneath the condition. That's the if statement. In this example, we saw that this condition is not true. So what's next? This brings us to if and else statements. So in the next lecture, we'll look at if and else statements. Thank you everyone, and see you at the next lecture. Hello everyone, and welcome to the lecture on if and else statements. We ended our last lecture by concluding that we can combine the if statement with an else statement. And we mentioned that in this case, if the condition under the if statement is not true, whatever condition the else statement has will be executed. So the general flow for the if and else statement is if we have some condition, and then colon, and then execute this, and then else execute this part. So this is the general flow. If the condition under the if statement is true, this statement will be executed. Whatever code we have under the if statement will be executed. And if that condition is not true, the else statement will be executed. Okay? Again, if the given value is also 0, the else statement will be executed. Let's look at some examples. And this is how we indent. If we have the condition, colon, new line, and then indent. So this is very important. This is how Python knows that the statement we have underneath is part of this if condition. And we can have more than one code of statement underneath this. We can say execute this part also. So many things we can have here. Okay, let's look at an example. So let's say we have a number and we assign it a value of 48, and let's use an if statement to check if that number is equal to 48. So we can say if number double equal to 48, we can say print number is 48. Then we can say else print number is not 48. So this is a simple if else statement. We use double equal sign. That's because we want to know if two objects have the same value. So in this case, number is 48. So this statement will be printed. So if we run this, we get print. This statement will be printed. Number is 48. What if the number we pass is not 48? Let me copy this, paste it here. What if I have another number, let's say 12? So this condition will check if number is double equal to 12. Is that true? No. Number is not equal to 12. So this statement will not be executed. So it will go to the else statement and then execute this else statement. So print number is not 48. So this statement will be printed. Number is not 48. Again, we can also have another print statement outside of the if else statement. Print this will be printed regardless. We can have that, and that will be printed whether the given number is 12 or 48 or whatever. Similarly, we can also have a print statement outside of the if else statement and say this will be printed regardless. Again, that will be printed regardless, and it's not part of the if else statement. Okay, this will be printed regardless. Let's look at one more example. Let's say we have a number and then let's say it to be equal to an input. So we'll use the raw input function so that we can enter a number. Please enter your number, and then we'll provide the number. So this is the raw input function, and if you are using Python 3, the equivalent statement is input. So you can say input and then the statement, please provide a number. Please enter your number. So that's the equivalent if you are using Python 3. For Python 2 users, we use the raw input function. And then once we provide this number, so the user will enter this number, and then we'll convert that into an integer. So we'll use the integer function, the int function. We simply type int and then put everything in parentheses. So this is, we are converting our input into an integer. That's because our input is string at this case, and using the integer function or method here, we convert our input into an integer. So this is called casting. So we are casting our input to an integer. Great. Now let's have our if else statements. We can say if number is less than, let's say, 20, print number is less than 20, else print number is not less than 20. So let's execute this statement. So what will happen is when we run this, we'll be prompted to enter a number, and if that number is less than 20, the statement will be printed. If not, the else statement will be printed. So let's run it. It says please enter your number. Let's say 12. Enter. So number is less than 20 gets printed. That's because the number we provided is less than 20. Okay, let's run it and enter some other number. Please enter your number. Let's say 23. Enter. So number is not less than 20. So this is another if and else statement. So this example checks if the number is less than 20. The statement gets printed. If not, the else statement gets printed. Again, if I have another print statement outside, this will be executed no matter what the outcome is. So whether the number you provide is less than 20 or greater than 20, this last print statement will be executed because it's not part of the if else statement. Let's run it again. Please enter your number 2. See, this last statement gets printed regardless. Okay, let's run it one more time. Please enter a number. Let's say 46. Run it. So this will be executed no matter what the outcome is. And we have our results here. Great. And what if we want to check more than one condition? Let's say in this example, it's only checking whether the number is less than 20 or not. What if I want to check more than 2 conditions? Let's say what if I want to check if my number is, so this will be the first condition, if my number is less than 20. And what if my second condition is if the number is between 20 and 100, and if the number is between 100 and 200. So that brings us to our next topic, which is if, elif, and else statements. And in the next lecture, we'll look at the if, elif, and else statements, and we'll learn about those if, elif, and else statements to execute more than one condition, mostly more than 2 conditions. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the lecture on if, elif, and else statements. So far we have seen the if and else statements. Now we'll add the elif statement. So this elif statement allows us to check for more than 2 conditions. So we can have our code check for multiple conditions. So the flow for if, elif, and else statement goes like this. If we have some condition, if that condition is true, execute this, and then we have the elif statement. Elif, and then execute this. So this will be, there will be another condition here. If, let's say, condition 2, and then finally we have the else statement. So this is the flow for if, elif, and else statement. If the given condition is true, the statement underneath the if statement will be executed.
elif, if this condition is true, the statement under the elif statement will be executed, or else. So this is the final else. Else means if the above two conditions are not true, execute this. So this will be executed. And we can have more than one elif statement. We can add as many elif statements as we want. We can have, let's say, condition 3, execute this. So we can have multiple elif statements. Let's look at an example. Let's use the example that we created in the previous lecture. So I'll copy this, Command C, and paste it here. Let's say, so we have our number variable here. Row input, please enter your number. And let's see, if number is less than 20, we have print this statement. Now let's add an elif statement. Let's say elif number is greater than 20. We can say print number is greater than 20, and for any other condition the else statement will be executed. So in this case, let's run it. So it says please enter your number. Let's say 23. In this case, the statement will be executed. Number is greater than 20. Enter. Test number is greater than 20. And this last statement will be executed regardless. So I'll just comment it out. Let's run this again and enter another number. Let's say 20. So none of the statements are checking whether the number is 20 or not. So the first if condition is if number is less than 20, and then we have elif number is greater than 20, and for any other condition execute number is not less than 20. In this case, let's say number is not 20. So when we run the statement, this last statement will be printed. Number is not 20. Enter. This number is not. Let's run it again. 20. We get number is not 20. Okay, that's the else condition. If all the above statements fail, if all the if and elif statements fail, the condition under the statement under the else condition will be printed. Let's look at another example. Let's say we have a variable called movie, and let's set it to be equal to, let's say, departed. Then we'll use the if, elif, and else statements to see if the movie we enter is departed. We can say if movie is equal to departed, if movie is equal to departed, print that was a great movie. We can have an elif statement. Elif if movie is equal to, let's say, Toy Story. Let's say print movie was Toy Story.
Let's have another elif statement. Elif if movie is equal to, let's say, minions. Let's say print that movie was funny. And let's have our else statement. Else print what was the movie. So here we have a few conditions. The first condition is if movie is departed, it says print that was a great movie. Elif movie is equal to Toy Story, print movie was Toy Story. Elif movie is equal to minions, so this part will be executed. And for any other condition, print this statement. So if we run this statement will be printed. That was a great movie. Let's run it. That was a great movie. What if we change this to some other movie, let's say Minions, and when we run this statement gets printed. That movie was funny. And if we set this to some other movie, let's say Star Wars, the last else statement will be printed since it's not equal to any of the conditions above. So if we run that, let's run it. Oh, we have our print statement inside the code. Okay. Print what was the movie. Let's run it again. Okay. So what was the movie? So this is an example of if, elif, and else statements. Let's look at one more example. Let's say we have a number, then we'll use the raw input function so that the user can enter any number. Enter a number, please. Then we'll convert it into an integer. We'll cast it to an integer. Again, if you are using Python 3, use the input instead of raw input function. And we can check if number is equal to 0. You can say print number is 0. And let's have a few elif statements. Elif number, so this is not num. If number is greater than 0 and number is less than, let's say, 20, you can say print number is between 0 and 20. Let's have one more if elif statement. Elif number is greater than 20, and if number is less than 45, you can say print number is between 20 and 45. And for any other condition, the else statement will be executed. Then we can say print, I don't know the number. So you can have more than 2 elif statements. You can have as many as you want. So let's run this. It says enter a number, please. Let's enter 0. So number is 0 will be printed. number is 0, so we'll check each condition. Run it again, enter a number please. Let's enter 12. Oops, let's enter 12. Enter, number is between 0 and 20. Good. Let's run it again. Please enter a number, let's say 28. So number is between 20 and 45. Great. And for any other condition that I don't know, the number statement will be executed. So any other condition, let's say 20, run it. It says I don't know the number. Great. And one thing to notice here is that we are only checking if it's between 0 and 20. So you can also check equality. For instance, we can say Elif number. So let me copy this, paste it here. We can also check if number is between 0 and 20, and we can include this part. So we can say, and number is, we can check if number is less than or equal to 20. So if we run this and then enter 20, the statement will be printed. Number is between 0 and 20. So run it, we get number is between 0 and 20. So I kept it simple, but you can check those conditions also. You can put it in your example. You can put it here or you can include it here, but make sure that it's not in both. So make sure not to say number is less than or equal to 20 here, and also number is greater than or equal to 20 here, because that condition will be true in both of these Elif statements. So check that out. And you can have various kinds of inputs like this. Okay, and in the next lecture we'll look at nested if statements. Thank you, everyone. Hello everyone, and welcome to the lecture on nested if statements. So nested if statements are if, elif, and else statements inside an if, elif, and else statement. Let me show you what I mean. Let's say we have a condition. If that condition is true, this will be executed. Execute this. And we have our elif condition. Elif condition 2. Let's say execute this. And then we have our else statement. Else execute this. So this is a simple if, elif, and else statement. Nested if statement means we have another if, elif, and else statement within one of this. For instance, we can have another statement inside this if condition. We can say if condition, let's say A, execute condition A, and then we can have an elif statement here. Elif condition B, let's say this is condition 1, condition 1A, execute condition 1A, elif execute condition 1B, execute condition 1B. We can have multiple elif statement, but I'll simply end it with else. Else execute condition 1C for simplicity. So this is what a nested if statement looks like. If I have one condition, execute this, and let's copy this whole thing, Command C, and we can have that also
inside the elif condition. Let's say this is condition 2. If condition 2 is true, this could be 2a, 2b, this one is 2a, this is 2b, execute, and the final one will be 2c. So this is nested if statement. If elif else statement with another if statement. Okay, this is the flowchart for nested if statements. Let's look at an example. Let's see. Let's say we have a grade, a student grade. Okay, let's have a variable called grade, and let's see, grade is equal to 85. So we'll have if, elif, and else statements, nested if, elif, and else statements to see a student's grade. So we can say, let's start with our if, elif, and else statement. So we can say if grade is greater than 60, if grade is greater than 60, we can say print student scored. Then we can say student scored. Let's make it simple. And passed. Student scored a passing grade. I'll just make it simple. Student scored a passing grade. Then let's have an else statement, and let's conclude this. Else print student failed. So this will simply check if grade is greater than 60. It will say student scored a passing grade, else student failed. Now we'll have an if, elif, and else statement within this if statement to check if grade was A, B, or C, and so on. Let's do that. So inside the statement we can say if grade is greater than or equal to, let's say, 90, you can say print passed with A. And we can say elif grade is greater than or equal to 80, we can say print passed with B. Elif grade is greater than or equal to 70, you can say print passed with a C, or else print grade was a D. So let's look at the statement. So we have a grade of 85. If we run this, so it will check if grade is greater than 60. In this case, it's true. The statement will be printed first. Student scored a passing grade, and since it's also greater than 60 and it has some nested if statements, it will check for these conditions. The first thing it will do is it will check the first if condition. If grade is greater than or equal to 90, print this. Since 85 is not greater than or equal to 90, it will go to the next condition. So this condition is true if grade is greater than or equal to 80. So this statement will be printed. So passed with a grade of B. So when we run this, we'll get two print statements. This will be printed. Student scored a passing grade and then passed with a B. Let's run it. So student scored passing grade and then passed with a B. Great. What if the grade was 90? In this case, this statement will be printed since it's greater than 60, and this statement will be printed since grade was greater than or equal to 90. Let's run it. So now we have passed with A. Great. What if the grade was 72, for instance? In that case, we'll have passed with a C. Run it. So student scored a passing grade and then passed with a C. So looking good so far. And then here it says for any other condition, print grade was a D. Any other condition means first the grade still has to be above 60 but less than 70. So let's say 61 and run it. So student scored a passing grade and then grade was a D. What if we have 60? 60 means grade is not greater than 60. So it will go to the else statement. So else statement, it says student failed. So if we change this to 60, we'll get student failed. Great. And we can add an elif statement in the main if, elif, and else statement. Here we can say elif grade is equal to 60. We can say print student will have to retake the exam, or whatever you want. So in this case, if we run this, we'll get the statement will be printed. Run it. So it says student will have to retake the exam. Similarly, if we have a grade below 60, let's say 53, student failed will be printed. Student failed. So this is an example of a nested if statement. We'll have an if, elif, and else statement within the if, elif, else statements. And multiple conditions will be executed in this case. So this if, elif, this nested if statements could be very complex, or they could even be a simple one. We can make this more complex by adding another if statement within if, elif, and else statement within one of these if statements. For instance, we can add another if statement here. Let's see. We can say if grade is greater than or equal to 96, let's say, we can say print passed with A plus, elif grade is greater than
or equal to, let's say 93, you can say print passed with, what can we say, a high A minus. This is just for the example. And then else print passed with a low A minus. And then let's say student scored 97. So in this case, score is greater than 60. So this statement will be printed, and then it will check if grade is greater than or equal to 90, which is true. So it will print passed with A. So far we have two statements. And it will also check if any of these conditions is true. It will check if grade is greater than or equal to 96. In this case it is. So this will be printed last. Passed with A+. So student scored with a passing grade, and then passed with A, and then passed with A+ will all be printed. Let's run it. So student scored with a passing grade, passed with A, passed with A+. Similarly, we can do the same thing and categorize students, their score into B+ or B- or whatever. We can say if grade is greater than or equal to, let's say 87, we can say print passed with a B+ and Elif grade is greater than or equal to, let's say 83 or 84, it doesn't matter. We can say print passed with a higher B-. Then we can say else print passed with a B-. And then if we, let's say the student scored 85, that should be a B+, I guess. Greater than 85 is a B-. So in this case, let's go through the loop and see what will be executed. So grade is 85. Is grade greater than 60? Yes. So this will be printed. And then it will check if grade is greater than or equal to 90. No. So it will jump to the next condition. Is grade greater than or equal to 80? Yes. So this will be printed. Passed with a B. Good. And then it will check what was the grade again, 85. And then it will check these conditions. So the first one is not true. The second condition is true, so this will be printed last. Passed with a higher B-. Let's run it. So we have student scored a passing grade, passed with a B, and then passed with a higher B-. So our nested if statements could be a complex like this. So we can have a nest within a nest within a nest. Okay, I just wanted to show you that it could be like this. We could have multiple nested if statements. Great, thank you everyone. Hello everyone and welcome. In this exercise we'll go over two questions and it's on if statements. We'll see how we can use if statements to answer these two questions. The second question is relatively simple, and the first question is a bit challenging. And what we'll do is start with this second exercise. So the question says, ask a user to input a number and check if the number the user enters is a negative number, 0, or a positive number. So this is a simple exercise. It's a simple, we can check for 3 conditions. One way to do it is if we can define a number, and then if that number is positive, let's do that. We have our number, and then we can set it to be equal to, we'll be asking a user to input a number, so we'll be prompting that user. We can say raw input, then please enter a number. Then we need to convert this into an integer, so we'll cast it to an integer. Again, if you are using Python 3, use the function input instead of raw input. And once the user enters a number, we can check if, one way is if number is greater than 0, we can say print number is 0, number is positive, and then, so I'm showing you the simple way first. Then we only have 3 conditions, if it's positive, 0, or negative. Elif number is equal to 0, print 0, and the last condition is else print negative. So that's a simple way of answering this question. Please enter a number 3, so that should be positive. Please enter a number negative 2, so that's a negative, and the last one is 0, so we have a 0. So that's the simple way, and I'll show you how to do that using a nested if statement. Still a simple way, but I'll show you using a nested if statement. So we have our number to integer, and then we have raw input, please enter number, and then we have our if statement. So if number, we can say if number is greater than 0, we can say, and then within that we'll have, so first we'll have 2 conditions, if number is greater than 0, and then we'll have an else statement, print, let's say negative, number will be negative, and if the number is, instead of greater than 0, let's make it greater than or equal to 0, and then we can check, within that we can check if the number is equal to 0, good, and then we can make it, we can use an else statement, then we'll have an else statement. So this is the general layout of our nested if statement. So if number is greater than or equal to 0, check the following conditions. If number is equal to 0, print number is 0, and then else, we have our else condition, print number is positive. So that's the other way of answering the question using nested if statement. So if we run this, it says please enter a number, let's enter a positive number. Okay, number is positive. Please enter a number. Let's say -9. Number is negative. And finally, we enter 0. We have number is 0. Great. Let's move on to our next question. It says, use a for loop together with if statement to check the grade of students and what they scored. So we have a list of score. We have a list of scores. And then what we'll do is we'll use a nested if statement to see if a student passed or failed and whether they got A plus, B, C, or D. And we'll do that by combining a nested if statement with a for loop. Great. Let's get started. So I'll start by creating a list containing the student grades. So let me copy this. So I'll create a list of all my scores, my student scores. Let's do that. Okay, Command V. And I'll store it in a variable called, let's say, student scores. And this is a list. What I'll do next is I'll have a for loop that will go through this list and then print out each individual grade or score. And then for each individual score, we'll have an if statement to check the grade. Let's do that. Okay. So we have for, let's say, grade in student scores. We can say print the grade of the student is, and then plus the grade, plus the grade. So right now this is a string, whereas grade is integer. If you see here, this is an integer. These are all integers. So we need to cast this into integer. So I'll cast the grade to integer. Right now, if I execute the statement, I'll get each individual score will be printed. So 98, 92, 85, and so on. Let me run it and show you. Cannot concatenate string and integer objects. Oh, so let me change this to, sorry. So since this is a string, I will cast grade into a string because we cannot add string and integer objects. So we'll cast this into a string. Let's run it again. So we have the grade of the student is 98, and then we have the grade of the student is. So it goes through each grade in our list and then prints the grade. Great. Now what we'll do is we'll have a nested if statement to check if the student got an A, a B, a C, and so on. Let's get started. So we'll do all of that within our for loop. So let's start. We can say if grade is greater than or equal to 60, we can print student has passed, or simply passed. We can say passed with a passing grade, and then otherwise the other option is what? Else print student has failed. So that's our if and else statement. If grade is above 60 or above, student has passed, else student has failed. Now within my
passing grade, we'll have some nested if statements to check if the student scored A, B, C, and so on. So we can say if grade is greater than or equal to 90, print passed with A, Elif grade is greater than or equal to 80, student passed with a B, so print passed with a B, Elif grade is greater than or equal to what, 70. This will be print passed with a C. Okay, so far it's good. And then the last statement is else print passed with a D. Okay, so far we have taken care of that also. Now let's run our code here. So in this case, we'll have for each grade. So when grade is 98, first it will print the statement. So it will say grade of the student is 98, and then it will go through this if statement. If grade is greater than or equal to 60, it will print passed with a passing grade. Good. And then it will go, since 98 is greater than 60, it will go through this nested if statement, and it will execute the first statement. So the grade will be printed, and then passed with a passing grade, and then passed with A. That's just for 98. And all of those, the same thing will be executed for each of the grades in our student scores list. Let's run it. Okay, the first one is the grade of the student is 98, passed with a passing grade, passed with A. Then the grade of the student is 92. So for each grade, it does that check. When it's 55, student has failed, so still good. When it's 81, passed with a B, a D, a C, a B, A. So we have a grade representative of each score. Okay. Other thing we can do is let's indent some of this. So I'll indent this once, couple of times. Let's indent this also. Okay. So that it's easier to read. Let's run it again. So the first one, when the grade is 98, passed with a passing grade, passed with A, and so on. And again, we can also have used /t for tab. Let's use that. /t backward slash. This is just to make it more readable. Let's run it. Okay, much more readable, right? Next, we'll go through each of this grade and then see if the student scored A or A+. And you can do for the remaining ones. I'll just show you for A only. Let's have some nested if statements. Within our nest, we can say if grade is greater than or equal to 97, let's say print passed, let's say
grade is A plus. And then let's have two tabs, /t/t, so that we can read it much easily. Okay, Elif grade is greater than or equal to, let's say, 93. We can say print grade is higher A minus, or whatever you want. And then we'll /t/t tab, and let's conclude this. Else print, okay, we'll tab twice, grade is A minus. Okay, let's run it now. So when grade is 98, the student passed with a passing grade, passed with A, grade is A plus. Right? Let me indent this back. I think that should be okay. And then this last part. /t there. I think everything else looks good. Okay. The grade of the student is 98, passed with a passing grade, and then passed with A, grade is A plus. The grade of the student is 92, passed with a passing grade, passed with A, grade is A minus. So I just did it for A plus, A minus, and you can do the same thing for each individual grade. So you can divide the B's into B minus, B plus, and so on. Okay, another thing we could have done is we can distinguish each of this by adding an additional print statement. Let me show you what I mean. So I'll simply add another print statement here, say print, just so that it's more readable, nothing fancy. And then print, add a line here, then same thing here. This is just to distinguish each grade. If I run it again, it looks much nicer, right? So the grade of the student is 98, passed with a 98, and then we have, so this is one grade, one score, or grade, another score, and so on. We can do that too. We can copy this and apply it for when grade is a B. So the same situation is true. So if grade is greater than or equal to, let's make this 87, and then grade is B plus, and then when it's greater than or equal to 83, the grade is a higher B minus, and for any other condition we'll make the grade B minus. So that looks good. To have more representative numbers, we have 85. Let's add one more. Let's say 89. Okay, run it again. So when grade is 85, passed with a passing grade, and then passed with a B, grade is higher B minus. When it's 89, grade is B plus. So you can do the same thing when the grade is C. You can add the same thing so that you can see C plus, C minus, and so on. So this is how we can use a for loop together with an if statement to check each individual grade. First we are printing the grade, and then for each grade we are going through our if statement to check if the student passed or failed, and if they passed
what they got for their result. Great. That's all I have for this exercise. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the lecture on for loops in Python. We use for loops to iterate over items or elements in a given sequence, like lists, strings, dictionaries, or tuples. Let's see how we can use for loops in lists for iterating items in lists. Let's say we have a list of numbers. Let's say list containing numbers. Let's say 2, 4, 6, 8, and 20. So to iterate over each of the numbers in our list, we can use a for loop. We can say for. So the statement for a for loop is like this: for, let's say, x in our case. So this could be a sequence. Let's call it sequence. So for x in sequence, print, let's say, x. So this is the general format for a for loop. It can be for x, or let's call this element. For element in sequence, print element. So in our case, in this case, element will be each of these elements, each individual element. So this is one element, another element, and so on. In sequence, in this case, will be our list. So this is a sequence. It could be string, dictionaries, or lists. And then colon, new line, indent, print element. So it is the same element as this. One thing important in using for loops is that whatever element we pass here and whatever element we print have to match. Okay, but it doesn't matter what you put here. I could have said, instead of element, I could have said for item in my sequence, print item. So either way, it's fine. Now let's use this for loop to iterate and print out all these numbers in the list number. So we can say for, let's say, numbers in the list number. So that's my list, colon, new line, indent, print numbers. So in this case, I used numbers to represent each element in my list. So now when we run this, each of the numbers will be printed out: 2, 4, 6, 8, 10. Instead of numbers, we can use some other thing. We can say, let's say, we could have said element in list number, print element. That also works. And if we run this, we get the same result. And instead of element, we can use anything: number, num, for num in our list, print number. Basically, it means the same thing. So for each of the items or elements in your list, which is defined here, print each of the elements. That's what it means. Or usually you'll see the letters I. Mostly people use I or X or a single letter. I can say for I in my list, print I. You get the same result. Okay, so that's the idea of for loops. Let's see another example. Let's create a list using the range function. So we can use the range is a built-in function that we can use to create a list. So we can say range, let's say 0 to 22. That will give us a list of numbers from 0 all the way to 21. So that's the range function. And we can pass the entire range function with a for loop. We can simply say for, let's say, numbers in range 0 to, let's say, 7. For numbers in range 0 to 7, we can say print numbers. In this case, we have to cast this range as a list. Okay, so this will convert our range into a list. Now if we run this, we get 0 through 6. Great. For numbers in, so we are converting this range function and then casting it as a list, print numbers. Then all the numbers from 0 through 6 will be printed out. Another way we could have done this is by saving our range function in some variable. Let's say number list is equal to range 0 to 22. Run that, and then if we call our number list object, we get a list of numbers from 0 to 21, and then we can pass this. We can use for, let's say, x in number list, print x. We could do that, and numbers from 0 through 21 will be printed out. But this is using for loops directly by creating a list using the range function. Hello everybody, and welcome back. In this lecture, we'll continue our discussion on for loops. We'll see how we can iterate items in a given list by using the index of the items, and we'll look at how we can use for loops in iterating elements in a string. Let's start by creating a list of items, and we'll save it in a variable called items. Let's create a few items. Item 1, item 2, item 3, say item 4, and let's add one more item, item 5. So what we'll do is we'll use the index of each item to iterate through our list and print out these elements in our list. So remember, we have looked at the length function before. So for instance, if I want to find out the length of my items list, I simply pass items into my length function, and that will give me 5. Okay, now let's use and you also remember the range function. If I say, let's say, range 6, that will generate a list of numbers 0 through 5. So what we'll do is we'll pass the range function into the length of these items. So in this case, range, and then length of our items. So that will be, we'll use this as our index. So if we pass that, we get 0, 1, 2, 3, 4, which is correct, right? Index 0, 1, 2, 3, 4. So we'll combine both the length and range functions to find out the index of our items. So we can say for I in range, then we'll pass length of our items object, which is a list, colon, then we'll print out our items. Then we'll print our items at index I. So if we run this, we get item 1, item 2, item 3, item 4, and item 5. So for I in range, length of the items, so length of my items is this range, length of my items is 0, 1, 2, 3, and 4. Then print items, which is this, at index I. So index I will be index 0, 1, 2, 3, 4. Then we get items, each of the individual items. Okay. We could have also printed, to make this more visible, let me show you another way by printing more details. So for I in range, length of our items, then colon, print, let's say item at index, and then I is, let's see what else can we print. Yeah, that should be good. Items at index I. So this will print out each of our individual index and then the corresponding items for that index. And then let's convert this to a string of I, because we cannot concatenate different data types. So all of these are strings. We cannot concatenate strings and integers. So I'm casting I as a string. So let's print this. Okay. Now we get item at index 0 is item 1, right? So if I call my items list, here I have, so item at index 1 is item 2, and then at index 2 we have item 3, and so on, right? Okay. Let's look at one more example. So I'll use the same items object. Okay. And let's start. Let me define another variable number, and I'll set it to be equal to 1. And we can say for item in items, let's print number and then item. So what do you think we'll get if we run this? Let me run it and show you. So we get 1, item 1, 1, item 1, 1, item 3, item 4, and so on. But what I want is, I want to print out like first one is item 1, and then 2, item 2, 3, item 3, 4, item 4, and so on. So in order to do that, so we start with number 1. Then for item in items, print this. Then we need to add. So after going through the first item, we need to add 1 to this number, right? So that it keeps adding. Every time it goes through the for loop, it will keep adding 1 to that number. So after this, I'll add number is equal to number plus 1. So run it again. Now we have 1, item 1, 2, item 2, 3, item 3, 4, item 4, 5, item 5. Okay? And if you want to use indexing. I mean, if you want to show the correct index, you can start with 0 and then run the whole thing. So at index 0 we have item 1, index 1, item 2, and so on. I just wanted to quickly show you like a combination of things that we can use for finding out the index. This is the more appropriate and nicer way, I think. Great. Next, let's look at how we can use for loops to iterate items or elements in a given string. Let's say we have a string called name, and let's say Michael. So we can iterate and print out each of the individual alphabets in this name string. We can say for characters in our string name, we can simply print the characters. So that will print each of the individual letters. We could have said anything that we want. For alphabets in our string name, print alphabets. You can use anything that you want, but make sure what you have here and what you are printing are the same objects. Okay, Michael. I could have said for I in my string name, print I. That's also possible. Let's see another example. String name is equal to today is a great day to jog. So let's run this. We can say for characters in our string object, in our string name, print characters. So that will print out each of the individual elements or alphabets in the list, including this empty space. So today, and then each of them. We could have also said, let's say, for elements in, let's say, today is called print elements. So today is called. Each of the characters are printed one by one. So we can directly pass our string in the for loop. Okay, let's look at one more example. Let's say for name in, so the earlier example we saw, for name in Michael, print name, run it, we got name. Yeah, that's all I have for this lecture. In this lecture we saw how we could use for loops in iterating elements in a string, and we looked at a couple of examples of how we can iterate by using the index of our items in a given list. Thank you, everyone. Hello everyone, and welcome back. In this lecture we'll continue with our discussion on for loops in lists. Let's see one example. We'll use for loops to see if a number is divisible by 6. Let's have a list of numbers. Let's say numbers is equal to 2, 3, 6, 8, 12, 15, 18, 22, and 26. So we have a list of numbers. What we'll do is we'll use a for loop to iterate through each of these numbers and see if they are divisible by 6. we know that a number is divisible by 6 if it's divisible by 2 and also 3. So we'll use this knowledge for our for loop. If a number is divisible by 3 and also by 2, it means it's divisible by 6. For instance, to find out which numbers are divisible by 3, we can use a for loop for, let's say, for numbers in our numbers list. We can say if our number modulus 3 is equal to 0, it means the number is divisible by 3. Print, let's print the number. Okay, so modulus means number divisible, number modulus 3 means when that number in our list divided by 3. If the remainder is 0, that means that number is divisible by 3. For instance, let's say we have 6. So 6 modulus 3 is 0. Because when you divide 6 by 3, there is no remainder. So if we simply say 6 modulus 3, the result is 0. And if we say 5 modulus 3, the result will be 2, because the remainder is 2. So that's modulus. Now if we print the statement, if we run this, only the numbers divisible by 3 will be printed out, which are 3, 6, 12, 15, 8, and 18. Let's run it. Integer object is not iterable. Oh, let's run our cell first. We didn't run our cell. Now let's run it again. Okay, we have 3, 6, 12, 15, and 18. So this is how we know a number is divisible by 3. Similarly, we can do the same to find out which numbers are divisible by 2. In that case, it will be if number modulus 2 is equal to 0. Okay, we have the idea now. Now let's see which numbers are divisible by 6. So we have our numbers list. Let's do that. So we can say for number in our numbers list, what we'll do is we'll first check if our number is divisible by 2. So we can say if our number modulus 2, if our number modulus 2 is equal to 0. So in this case, at this time, we know that our number is divisible by 2. So the next thing we need to check is if a number is divisible by 2, if number modulus 2 is 0, let's also check if that number is divisible by 3 also. So we can say if number modulus 3 is equal to 0, so we're doing a second check. We can print, then we can print, let's print the number. Then we can also print the above number is divisible by 6. It makes sense, right? Or else, now let's close our else statement. Else, let's print the above number is divisible by 2 only. Okay,
So we have that. So the first thing we checked was if the number is divisible by 2. Yes. If that's true, also check if that number is divisible by 3. If it's true, that means the number is divisible by 6. Else, let's also print the number. Print the number, and then the above number is divisible by 2 only. Great. So we have taken part of the divisibility by 2 and 6. Next, let's take care of divisibility by 3 only. So here the outer if we have if number modulus 2 is equal to 0. So let's finish that if statement. Let's close it by our else. Else we can say if number modulus 3, if number modulus 3 is equal to 0, we can say the number print, let's print the number, and then we can also print the above number is divisible by 3 only. Else let's print the number, then let's print the above number is not divisible by both 2 and 3, or we can say the above number is not by both 2 and 3. Okay, let's look at our statements one more time. Let's see what's going on. So first we have for num in numbers. So we have our numbers list. For num in numbers means for each element in our numbers list. Okay, for num in numbers says if our number modulus 2 is equal to 0, if that number is divisible by 2, execute this. So check this condition. Check also if the number is divisible by 3. If that is correct, so the number is divisible by both 2 and 3, which is divisible by 6. But if that condition is not correct, it says the above number is divisible by 2. So since we are checking divisibility by 2 first, it's divisible by 2 only. Okay, now if this condition fails, if the number is not divisible by 2, it means go directly to the else condition. And in the else statement, it says if the number is divisible by 3, print the number. And if the number is not divisible by 3, it means the number is not divisible by both 2 and 3. Okay, now let's run our code and see which numbers are divisible by 6. So run it. Okay, first we have the number 2, and it says the above number is divisible by 2 only, which is correct. Then we have 3, the above number is divisible by 3 only, which makes sense. And then we have 6, the above number is divisible by 6, which is both 2 and 3, good. 8 is divisible by 2 only. 12 is divisible by 6, makes sense. 15 by 3 only. 18 by 6. 22 by 2 only. 26 by 2 only. Okay, we are lacking the last condition here, right? Not divisible by 2 and 3. So let's add one more number in our list. We can add 11, 13, let's say 25, and run the numbers again, then run our code here.
Okay, so where is 11? So 11, here it says the above number is not divisible by both 2 and 3. Great. 13, the number is not divisible by both 2 and 3. Great, so our code is working. So this shows you how we can use the for loop in conjunction with the if statement to see if a given number is divisible by 6. As an assignment for you, try if a number is divisible by 12. So a number is divisible by 12 if it's also divisible by both 3 and 4. So try that as an exercise. Thank you everyone, and in the next lecture we'll see how we can iterate through a sequence of lists using for loops. Hello everyone, and welcome to the lecture on for loops in dictionaries. In this lecture we'll look at how we can use for loops in dictionaries. Let's start by creating a dictionary, and we'll store our dictionary in a variable called myDictionary. And let's pass a few key and value combinations. So our first key will be, let's say, first name, and value, our first value will be Joe. For our second key and value combination, let's say last name for our key, and for our value we'll use Smith. Let's have another key and value combination. For our key, let's say state, and for value let's put LA, and for our final key and value combination let's use age as our key, and for value let's say 55. So this is our dictionary, and if we call our myDictionary.keys, we get myDictionary.keys. We have a list of our keys: age, first name, last name, and state. Similarly, if we call our values method, that will list out all the values of our dictionary, which is 55, Joe, Smith, and LA. Now what we'll do is we'll use a for loop and iterate through our dictionary and print out the keys and values. So we can say for, let's say, key and value in our dictionary object myDictionary, that we'll use the items method. So for key and value in myDictionary.items, we can simply print the keys and values. Let's format it. That will be for keys, and then the second empty parenthesis will be for our values. Then we'll call that format and pass key and value. So if we run this, we get our key and value, right? Age is equal to 55, first name is Joe, last name is Smith, state is LA. Let's have some space in between those. Okay, so for key and value you can use whatever you want here in our dictionary object that we called the items method. Remember, the items method will print out both the keys and values. Then we said print some print formatting, and we passed key and value. So age is equal to 55, first name is Joe, last name is Smith, and state is LA. So this is the use of for loop in printing out keys and values in our dictionary. So in this example, calling this method, our dictionary.items method, requires generating our entire list of key and value pairs in memory. And in this case, our dictionary is only of length 4. But what if your dictionary is super large? In that case, if your dictionary is very large, it can affect the performance, right? It will affect the performance of your program because it has to generate an entire list of key value combinations in memory. So in case of a large dictionary, that will affect the performance of your program. And in order to avoid this performance issue, we can use another method known as the Iterations method. So using the Iterations method, we'll avoid a performance issue raised by generating an entire list of key and value pairs in memory in case of a very large dictionary. So this Iterator method, it's a generator object, it's a generator method, and a generator simply allows us to iterate over an item one at a time. So when we have a list of items, a generator allows us to iterate only one item at a time. So in our dictionary example, it will only iterate one key and value at a time. So it will pull up one key and value into our memory, and then it will be discarded. And then the generator will move on to the next key and value combination, and then use that, and then it will be removed or discarded after that. So we won't have any performance issue by using the Iterations method. So let's see how to do that using the Iterations method. So we can say for key and value in our dictionary object, my dictionary dot iteritems, that's the method name. We can simply print, let's say, key and value. So run it. We get age 55, first name is Joe, last name is Smith, and state is LA. Let's add some formatting to make it look nice. So we add 1 is equal to for value, and then we'll that format, and then pass key and value, run it again. So we get the same exact result, but when we use Iterations, this is a generator method or function, and while using this Iterations generator method, it allows us to iterate only one item, one key and value combination at a time. So it puts the first key and value it gets into memory, uses that, and then removes that immediately and moves on to the next key and value combination. That way, we won't have to sacrifice our memory, and the performance will not be affected by using the Iterations method in case our dictionary is super large. And similar to printing out keys and values using the Iterations method, we also have other methods for returning keys and values, and they are called the iterKeys and then iterValues methods. Let's look at an example of those. So we can say for key in our dictionary, my dictionary object that iterKeys, you can say print key. So run it, all the keys are printed. Age, first name, last name, and state. So compare this method to the keys method we have on a dictionary. Okay, so that's the difference. Here you see, it generates an entire list of all the keys using the keys method, right? But here the iterKeys, it generates one at a time, so it won't affect the performance. Similarly, we can print out all the values by using the iterValues method. So for value in our dictionary object mydict.iter values, we can print value, and we get the values from our dictionary. So this is all possible in Python 2, whereas in Python 3 we don't have these methods. We don't have the iter methods in Python 3. So there is no iter items, there is no iter values, there is no iter keys in Python 3. So this is only for Python 2. So for Python 2 we have the option to use one of these iter methods, either iter items or iter keys or iter values, to iterate through only one item at a time, whereas in Python 3 we don't have those. So in Python 3 this methods already perform, the items method already perform the generator function, so we don't need that. We don't need the iter methods in Python 3. So those methods are only in Python 2. Great. This is what I have for the lecture on for loops in dictionaries. Thank you, everyone. Hello, everyone, and welcome to this exercise. We'll look at 5 questions on for loops. We'll try to attempt these questions by using our knowledge of for loops mainly and if statements. Okay, these are the 5 questions. The instructions are given. These are all the instructions. Take a moment and tackle those questions. Let's check the first question together. It says prompt a user to enter an integer n. Find out all the divisors of the integer by checking the modulus of all the numbers between 1 and n. So we're trying to find if any of those numbers, their modulus is 0. Finally, print out a list of all the divisors. Example, if n is equal to 6, we'll be checking the modulus of 6 modulus 5, 6 modulus 4, 6 modulus 3, up to 6 modulus 1. So whichever modulus gives us 0, it means that number is a divisor. For example, if the user enters the integer 6, these are the divisors of 6, 1, 2, 3, and 6. Okay, let's write our function together. Okay, first we'll prompt the user to enter an integer. So we'll use the raw input function since I'm using Python 2. If you are using Python 3, use the built-in method or function input. So raw input, enter your integer, and then we'll save this in a variable called number, and we need to cast it by putting it in parentheses, so it's an integer. We need to cast it. We need to cast this prompt message to an integer. Okay. What we'll do next is find out all the ranges between 1 and the integer the user inputs, and we'll save that in a variable called, let's say, numRange. So that will be list. We'll use the range function, so the range will be between 1 and the number they enter plus 1. So for instance, if the user enters 8, so this will be range 1 to num plus 1, 8 plus 1, 9. So range 1 through 9 means 1, 2, 3, 4, 5, 6, 7, and 8, but not including 9. That way we'll be checking 8 divided by 1. 8 modulus 2, 8 modulus 3, all the way up to 8 modulus 8. And then whichever gives us 0, that means it's a divisor of 8. Okay, so we have our list now. So this will contain a list containing numbers 1 through 8. Then we can use a for loop to calculate modulus of each of these numbers in our list. So we can say for the numbers in our num range list, for numbers in num range, if the number, if the input, right, modulus the individual number is equal to double equal to 0, because we are comparing if this modulus is equal to 0. We can say, but before we do that, let's create an empty list to contain all the divisors of the given number. So I'll just call it divisor num, and we'll create an empty list. So we can use this for loop and then append to our empty list. So that list will contain all the divisors. So if num modulus number is 0, we can append to our divisor num list that append number. And finally, we can simply print out this divisor number, so this list. Then we can print divisor num. Okay, let's see what we did step by step. Enter raw input, enter your integer, let's say 8. So that will create, we have 8, and then the num range will create a list. So this will contain a list of numbers 1, 2, 3, 4, all the way to 8, right? Range 1 plus num plus 1. And then we have our divisor num list. It's an empty list. This is empty currently. And then for number in num range, so the first number for each numbers in our list, let's say, so for 1, when this is 1, it will be if number modulus, if num modulus number is equal to 0. So the statement will be if num, our number is 8, modulus, the first number in our list is what? 1. It will check if it's equal to 0. If that's true, we will add this number, which is 1, to our list here, to our empty list. So this list will contain 1, and then it will check for the second element too. If that's 0, if the modulus is 0, it will add it here, append it here, and so on for all these elements here. Okay. Now let's run our program. It says enter your integer. Let's try 8. So we have 1, 2, 4, and 8, right? That makes sense. Let's run our program again. Enter your integer. Let's say 12. And then those are all the divisors of 12. So 1, 2, 3, 4, 6, and 12. Good. How about 9? So for 9, it should be 1, 3, and 9. 1, 3, and 9. Let's try a bigger number, larger number. Let's say 1024. So these are all the divisors for 1024. Let's try even a bigger number. So those are all the divisors. Okay, so that's the first question. Now let's move on to the next question, to question number 2. Okay, question number 2 says, we have a list here. Use a for loop and if statement to find out if the numbers in the list X are positive, negative, or 0. And if the number is negative, find out the absolute value of the number. So we'll use a for loop to go through each of these numbers, and then we'll find out if each individual number is positive, negative, or 0. And if the number is negative, we'll calculate the absolute value of that number. Great. Let's look at the solution together. So let's start with our for loop. You can say for each of the numbers in our list X, so for each individual number in our list X, if the number is greater than 0, we can say print the number, and then we can say is a positive number. How about if the number is equal to 0? You can say elif number equal to 0. We can print the number, and we can say is neither a positive nor a negative number. Then the last condition is if it's less than 0, else we can print the number, then we can say is a negative number. And if the number is negative, we also need to calculate the absolute value, so we can also print that out. We can say and its absolute value is ABS's absolute value. We can use the ABS method, so absolute value of, and then we can pass the number. Okay, looks good. Absolute value of the number. So the only thing we need is we need to run the cell. Let's run it. Now let's run our program. Okay, here we have the result. It says negative 3 is a negative number and its absolute value is 3. Good. Negative 5 is a negative number and its absolute value is 5. Great. Negative 11 is a negative number and its absolute value is 11. 0 is neither a positive or a negative number. 2 is a positive number. 4, 6. So those are all positive. And this number is negative. And here is its absolute value. And finally we have this positive number. And so this example is fairly straightforward. We use the combination of for loop and if and else statements. So by using for loop once here, we are able to check our if statement conditions for each of the elements in our list. Great. We'll continue with the remaining questions in the next lecture. Thank you, everyone. Hello, everyone, and welcome back. Let's continue our exercise on for loops. Let's look at question number 3. We have a list here. It says, use a for loop to print out all the adjacent elements in the list above. So what we need to do in this exercise is print out all the adjacent elements. For instance, the adjacent elements here will be 1, and A, so adjacent to each other, and then it will be A and 2, and then 2 and B, B and C, and so on. So those will be the adjacent elements. Let's look at the solution together. So we can say for, let's say, x in range 1 to length of our list. So x is an element in our list. For x in range 1 to length of this list, we can say our list at the index x minus 1, so that will be the first element, and then the second element or the adjacent element will be list 1 at index x, and we can save this in variables. Let's say the first element and then the element adjacent to it, let's save it in variable second. Then we can simply print out first and second. So to show that they are adjacent, we can print out so that we can get a loop, a tuple. So this is fairly simple. For x in range 1 to length of our list, so this means range 1 to length of our list is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in this case. So range 1 to 11. That means this will create a list 1, 2, 3 all the way up to 10, right? Since it's a range. So for x in range, for each individual element in our list, the first element will be list 1 at the index x minus 1. Since we are using a range, the first element, the first index is 1, right? So our list at index, first element is 1, 1 minus 1 is 0. So list 1 at index 0 will give us this, right? Index 0, so 1. So this will be 1. And then list 1 at index x will be x is 1, right? So list 1 at index 1, that will be A. So this will be A. So that's when x is equal to 1, right? So range 1 to 11. So for x in range 1, and then when x is 2, list 1 at index 2 minus 1 will be A, and then list 1 at index 2 will be this element, this number 2. So it will keep calculating that for each of the elements in our list, and we are printing the first and second element. Okay, let's run it. Here we have our tuple with each of the adjacent elements. So if I copy my list, then place it here, we can see that they are adjacent, right? 1A and then A and 2 and then 2 and B, then B and C, C and D, all the way up to 6 and 8. Great. Let's look at question number 4. So question number 4 says, write a program that will count the length of each word in a given string. So this is an example of a string. And it says, and place each word in a separate list start out with an empty list and append to each list by using for loops and if statements. Then we have good luck. So the first thing we'll do is we'll use the split method to split each of these words wherever there is a space. So we'll use that, and then we'll calculate the length of each word. For instance, the word right, the length of right is 5, and then this is 1, this is 7, and so on. We'll calculate the length of each word, and then we'll start out by creating an empty list for each of the words. So we can create a list for words containing 3 letters, for words containing 4 letters, and so on. So once we find out the length, we'll append to the appropriate list. So count has 5, so we'll append it to the list for words with length 5, and we'll do that for each of these words. And finally, we'll print out the list of all those specific lengths. Okay, let's look at the solution together. Let's run the cell first. Okay, so we have our string. The next thing we'll do is create empty list to contain all those words, and we'll just save them in variables, let's say 3. So that will contain words with length 3, 4. So we'll do the same, 5, 6, 7. So this list will contain words with their corresponding lengths. And then let's create another one called article to hold words with lengths. So this will be if length is less than 3, for instance. And then let's create another one, rest. So that will be for all the words with lengths greater than 7. Okay, now that we have our empty lists, we can start with our for loop. We can say for word in our string, what did I name it? st, right? Okay, let me copy this, paste it here. So we can say for word in our string st. So we'll use the split method on it. For word in our string that split. So for each of the word, we can say if length of the word, if it's 3, we are using double equal because we are comparing the right and left side. If the length is equal to 3, we'll take the empty list for 3, which is this, and then append that word to it. So 3 that append word, so that specific word will be appended to this list. Elif, if length of the word is equal to 4, we'll append it to the list 4. For that append the word
So Elif length of the word, if it's 5, we'll append it to the 5 list. 5 that append word. If the length of the word is 6, we'll append it to the 6 list. And if the length of the word is equal to 7, if it's 7, we'll append it to the 7 list. 7 that append the word. Now let's take care of words with less than 3 and greater than 7 characters. So Elif length of the word is less than 3. We'll append it to the article character, to the article list, article that append the word. For any other condition, we'll append it to the rest list, else rest that append word. Finally, we can display those individual lists by using the print statement. You can say print, let's say words with length is equal to 3. Then we have our list 3. So print words with length is equal to 4. And then the list containing 4 letters. Print words with length is equal to 5. And the list containing 5 letters. 5. Print words with length is equal to 6. Then we can print out the list containing 6 letters. Then print words with length 7, and that will be the 7 list. Print words with length less than 3 will be in the article list, and print rest of the words, and then our list rest. So that will be the program. So let's run it. Okay, we have our list. We have article is not defined. Oh, so this is misspelled article. Let's run it again. Okay, good. Words with length 3. We have that list. Words with length 4. Words with length 5. 6, 7, less than 3, and rest of the words. So this looks good. Another thing we can do is we can include a line break between each of these lists so that it's more readable. So print, let's add some line breaks. Say times 15. Hopefully that works. I'll copy that and then paste it under each print statement. Command V, Command V, Enter, Command V. So that way it's more readable. It's easier to distinguish each of this list. Okay, let's run it again.
Okay, much better now, right? Words with length 3. So we have those words. These are the words with length 3. Words with length 4. You can check out the list. Words with length 5. And finally, we have the rest of the words. So it's much nicer to read and distinguish each list. So to recap what we did, we started by creating an empty list for each of these lengths of words, 3, 4, and so on. And then we used the for loop to check the length of each word in our string, and we placed the word in the appropriate list. And finally, we printed out the list and its corresponding words. We use the print statement. And one thing to note is that we place the print statements outside of the for loop. If you place it inside of this for loop, it will be printing all of this every time you check the length. Okay, that's why we printed it outside of the for loop. Great. As an exercise for you, use the same program, and instead of saving a string here, try to prompt a user to enter a string, and then take the prompt message and use this for loop to find out the length of the words that the user enters. Thank you, everyone, and we'll look at the last question in the next lecture. Hello everyone, and welcome back. We'll look at the last question on for loops. Before we do that, we mentioned in the last lecture that we can prompt a user to enter a string and use the program that we built to find out the length of each word. Let's do that. So instead of this input, we can use the raw input function and prompt the user to enter a string. Raw input, enter your string now. We can do that. For Python 3 users, use the function input. Okay, now we can run this. It says enter your string now. This program will count the length of each word and place it in the appropriate list. This should be nice. Okay, let's run it. So enter your string now. We have our string, which is this, and then words with length 3 in our list. In our string, these are the words. Words with length 4 looks good. Length 5, 6, 7. Words with length less than 3, and the rest of the words, we have those. So we can do that also. And after the statement, to look it nicer, we can add a line, print, let's say this, times 17 or 16. Then if we run it again, let me just copy some of this to save some time. So we can copy that, Command C, paste it here, Command V. Let me remove this big space. Okay, and run it. So enter your string now. We have our string, then words with length 3, 4, and so on. So that's the line break. This is the line that we added. Looks like it's a little bit much. So we can make this 15 or 14 and run it again. Let's paste it, remove the space, and run it. And it looks much better now. Okay, now let's check question number 5. So it says, define two variables, punctuation and numbers as shown below. So I have already included that. A variable containing punctuations and a variable containing numbers. Then prompt a user to enter a string with a combination of numbers, punctuations, and characters or alphabets. And use a for loop and if statements to find out if the character is a number, alphabet, or punctuation mark. And print out a string of all the numbers, punctuations, and alphabets. So for instance, let's say the user enters this string. It's the last week of November and it's called with a bunch of numbers and punctuations. So what we'll do is we'll check each individual character, each individual element in the string. So we'll start with I and then T, then apostrophe S, and so on. And if each of this character is not in punctuation or numbers list, we'll add it to our string for alphabets only. And if it's in the punctuations string, we'll add it to our string to contain punctuations. And if any of these characters are numbers, we'll add it to our numbers string. So we'll start by creating 3 empty strings for alphabets, numbers, and punctuations. And we'll use a for loop to check each of these elements in our string and place them in their appropriate string. And finally, we'll print out all the alphabets, all the numbers, and a string containing all the punctuations. Okay, let's look at the solution. So I'll run that cell, and let's start by prompting the user to enter a string, and we'll save their prompt message in a variable called myString, equal to raw input, and then we'll ask them, please enter your string now. And then we'll create our 3 empty strings, one for alphabets, and we'll store it in a variable called alphabets only. And let's do the same for numbers and punctuations, and I'll save them in numbers only. And for punctuations only. Okay, next let's use our for loop. You can say for character, so we are checking each individual character. For character in our string myString, which is the prompt message, whatever they enter. So for each character in myString, so the first thing we'll do is check if the character is in this punctuations and number string. So we can say if character is not in punctuations and character is not in numbers. So if it's not in either of those two, we'll save it in alphabets only string. So we'll add it to that string. So we can say alpha only is equal to alpha only plus the character. So we start out with an empty string, and then we'll add an alphabet to that empty string. So we'll keep adding. And let's do the same for the other two strings here, numbers only and then punctuation only. Elif character is in numbers. So if it's in our numbers string, we'll add it to that string, to the numbers only. Numbers only is equal to num only plus character. And let's check if it's in punctuations. Elif character in punctuations, we'll add it to the punc only string. Punc only is equal to punctuation only plus character. And for everything else, we'll just print out a message else. Let's print out something for the user. Let's print out, I don't know what that character is, or something like that. Okay, so this will be printed out for each character that the program doesn't know. And once we have that, we can print out all the strings now. So we can print alphabets, you can say that, and then our string alpha only, and print numbers num only, and finally we can print punctuations or punctuation, then punc only. Let's run it. Okay, please enter your string now. Let's say it's called today, and I wonder if it would get any colder. Okay, enter. Oh, card. Oh, this shouldn't be card, this should be car. Let's run it again. Okay, please enter your string now. 45, it's called today around 24 currently, and I wonder if it would get any colder, and some characters and numbers. Okay, enter. Okay, now we have alphabets. So we have a string containing our alphabets and numbers, and finally punctuations. That looks good. Another thing we can do is let's include a line so that it looks nicer and we can see it clearly. Let's say that times 15, and we can add a line break in between each of the print statements. So print some lines times 15. Let me copy this and paste it underneath this too, and run it again. Let's say it's called at the moment, and it looks like it will get colder or something. Okay, and run it. Okay, please enter your string now. We have our string alphabets. So we have our alphabets, then numbers and punctuations. So it's neat. So to see what we did here, we started by prompting the user to enter their string, and then we created empty strings for letters, numbers, and punctuations, and for each character the user enters, we check if that character is not in punctuations and numbers list. So we have our punctuations and numbers, and if that character is not in these two strings, we place it in our alphabet only string, and we keep adding to this empty string. So that's the first if condition, elif character in numbers. So if the character the user enters is in our number string, we add it to the numbers only string, and we keep adding to that string. And finally, if it's in the punctuation string here that we defined, we add it to the punc only string. So we keep adding to one of these three strings for each character. So that's what this for loop and if statement does. And finally, we print out our three strings: alphabet only, number only, and punctuation only. Note that we did not include these print statements inside the for loop. Otherwise, it would give us a bunch of these results. It would give us, let's say, it will say alphabets, and then it will say I, and then another one, alphabets, it will show us T, and so on. So that's why we did not include this print statements inside this for loops and if statements, because we only want to print out the last string containing a list of all the elements in the appropriate group. Because if we include the print statement here, it will print out, let's say, the first character A. It will say alphabet only, alphabets, and then A, and then alphabets, and then T, alphabets S. So it will print out this line for each individual character here, and it does the same for numbers and punctuations. That's why we did not include it inside the for loop. Great. Another thing we could have done is we can define our string. So instead of prompting the user, we can simply, let's say, let me copy this, Command C. So I'll comment this one, and then paste the other string. So we can define our string like this, and then we can simply run it. So if I run that, it gives me a list containing our alphabet string, numbers, and punctuations. We can do that also. Great. Thank you, everyone, and I'll see you next time.